So good morning, everyone. Welcome to this 133rd edition of the Zak World of Fac conference series. My name is Ahmed. I'm part of the organizing team here. For those who are attending the event first time, I'd like to quickly run you through the event, what we've been doing, and what this history is. Yeah. So we've started the Zak World of Fac conference series here in India back in 2012. So it's almost 12 years. This is edition 133, across different countries, different continents, right from New Zealand up until Canada. It's been a great experience. Facades are designed, engineered, installed, looked at very differently in different countries. Gives us an edge in terms of taking the best practices from one region and try to bring them to another region. So that's been exciting, and facades itself are exciting. Unfortunately, it was not too well recognized. Interiors are still the glamorous part of a building, but I think facades are still more important. I'm not saying just because we are doing these event series, but it's the external of your building. If your building is beautiful, obviously, you get more value to it. So now finally, I think with sustainability becoming an important factor, facades are being taken seriously. There are no more your glass boxes. There's a lot of experimentation in cladding materials. Opacity is coming back. People are going back to stone cladding, natural cladding, terracotta, and other stuff. So it's very interesting. I think we're in a good phase. India is right at a place where we're also building new buildings. So I think it's the right time to incorporate all these practices. We don't have too much of an old building stock. So that's another issue we'll need to tackle. But I think with the new builds coming up now, I think this is the right opportunity. So as I mentioned, events all across the globe. Been a great experience for me and my team organizing this in different parts of the world. Of course, this is the 9th edition. No other city in the world has hosted this many editions. In Mumbai, I'm talking. Dubai is number 2 with 8, and London's at 6. So we keep this going until we can. No events possible without event partners. I'd like to start off by thanking our presenting partner, Shuko. Shuko is a world leader in aluminum door, window, curtain wall systems, one of the strong pillars of growth of this event globally. Powered by partners, Aluplex. Aluplex, one of the leading facade engineering contracting companies here in India. A premier partner with Alstone. Alstone is aluminum composite panel and other cladding material supplier. Associate partners, starting with AkzoNobel. So we've got the powder division called Interpon and the liquid division of AkzoNobel called Trinar, both exhibiting today, powder coating and liquid coating solutions. Cotswold, UK manufacturer of hardware fittings, represented by their partner Alok. Danpal is a company which specializes in polycarbonate roofing and cladding solutions. Dow needs no introduction, one of the leaders, Dow Corning, formerly known as Structural Glazing Solutions. Euramax, again, a coil fabricator from Europe, represented by their local partner, Diamond Engineering Corporation. FG Glass, one of the leading glass processors here in India. Fundamax, Austrian company, high-pressure laminates, inventors of using laminates in the external cladding, one of our long-standing partners to the Indian series. GE Silicons, represented by their local partner, Diamond Engineering Corporation, structural sealing and bonding solutions. Hilti, European company, multiple products. I'm sure all of you know about Hilti. I can go on for minutes for their product range. Intertech, they are into testing and certification, very important, especially when you're getting your products and facades tested. Kinlong, Chinese company, very popular here in the Indian market, a lot of products, glass hardware, fitting tools, etc., etc. Curare is the mother company of the laminated glass interlayer, Throcifol and Sentry Glass. Ozone, Indian manufacturer, glass hardware, fitting tools. QMA, okay, so for coating, the standard followed is Qualicoat. QMA is the authority which handles the Middle Eastern and Indian region. So when you coat your aluminum profiles or steel profiles, you will need to get certification on done if the coating is done right or not. So Qualicoat is the certifying authority for that. Qualicoat is based in Switzerland, but their Middle Eastern and Indian representative is QMA, which is the Quali Middle East Association. So very soon you will see Qualicoat also becoming a norm with consultants in India also. So it's important that the coating is done as per Qualicoat standards. Raina Industries, local manufacturer, they've got all glass fiber reinforcement stuff and other concrete related stuff which can be used on the external cladding also. AC controls from the UK, they've got smoke ventilation via a form of actuators, so they have an interesting solution. Another UK company, Siderise, represented by their local partner Alok, they've got cavity barriers for curtain walls and ventilated cladding. Perimeter protection. Terraco Swiss company, they've got a solution called EIFS, External Insulated Facade System. That's another external insulated finishing system. That's also another interesting product which is now picking up in the market. And of course, our main exhibition, which is a month from now in Mumbai, from the 26th to 23rd to 26th of November at the Bombay Exhibition Center. We'll urge all of you to attend. We've got a big show this year. Back, finally, we've been able to beat our pre-COVID level square meter wise. So it's good to see that India's back on track after COVID. So 23 to 26 November. Our next one is in New York next week, our second biggest in the series. Another one in Vietnam. We've got one in Montreal in between. And then our biggest in the series is London on the 8th of November, close to 1,000 people attending. We've got a black tie dinner also post the event. So yeah, so this is what we've been doing with the Zak World of Façade conference series. And for today's event, we've got an interesting agenda. I think we start off a little bit on sustainability, get into high-rise residential facades. I think that's the popular theme over here, and most of the projects are residential high-rise, so I think we'll get into that. Slightly deviate in the afternoon to a more complementing topic of fire safety. We've got first time also talking on security glazing and other stuff, which is also very important now. Eventually, our podium areas and all will start to all be specced with high performance security glazing solutions. We're getting into that. We end with a little bit of lighting and then BIM digitization and also it's an interesting agenda. And also what we have done is post the event, we've taken the venue luckily for an hour. So if you're not able to see any of the booths, you can visit them post the event. We've got an hour of networking after the event. So you need not rush in the breaks in case if you're not able to see all our vendors. We've got 22 partners today. Please visit all of them. All of them have different solutions. They're looking forward to having a chat with you. We've also recorded today's event, so the presentations we've got permission to share with you. We'll send a YouTube link a week from now, and we'll take this forward. With a feedback form, you can then access the YouTube link. So that's it from me. I'd like to call upon today's event host, Bhavana Bhatia. She's going to be taking you through until the end of the event. Thank you.
Thank you so much, Ahmed. Well, ladies and gentlemen, a very, very good morning. When I see such bright and vibrant faces, I always thank the Almighty for bringing all the leaders together. You're the ones who help us beautify the world around, and today allow us a moment to help you in your professional endeavors by helping you to network and connect with the leaders. Firstly, could we have a huge, huge round of applause for each and every one present amongst us? Come on, ladies and gentlemen, you've got to make some noise today. Well, a very warm welcome. My name is Bhavana Bhatia, in the industry for over a decade, emceeing landmark events. And it's my honor to represent the group Zak today. Firstly, there's a very important announcement which I'd like to bring to your notice today. Zak completes 30 years. And I think that requires 30 folds of applause for each and every one at Zak. I've had the honor of introducing the group today. I've had the honor of interacting with somebody who's popularly known as Zak. Of course, he's right there amongst us. His idea of perfection, his ideology, his vision is what impressed me. And I must say that there are few people in the industry whom I come across who impress so profoundly as the Zak group has. So thank you so much for onboarding me on that. Well, ladies and gentlemen, I'd like to welcome you all to the 133rd global edition of the conference. And in Mumbai, we're talking about the 10th very edition. It is the Zak World of Façades. Of course, it's great to see you all in the morning today, and we're talking about world's premier conference on facade design and engineering. The Zak World of Façades has attracted more than 30,000 plus delegates across 132 completed editions, and we're talking about 35 plus countries. It's so exciting to see leaders across the world come together, and as you know, collaboration is the key for that. Today, we're excited that we have a great lineup of speakers whom we'd love to engage with and interact with. So ladies and gentlemen, on that pious note, and of course, welcoming all the dignitaries, it's my honor to first kickstart with our first session. We're talking about the topic coming up, beyond the surface, the multiple facets of building facades. We have amongst us the director of Morphogenesis, John Alok Decruz. Let's give our gentleman a warm round of applause and welcome him on the podium. Come on, ladies and gentlemen, you gotta be louder. Let's welcome our first speaker. Thank you so much, John, for joining us today, and welcome. Over to you.
Okay, firstly, thanks, Bhavana. Thanks, Ahmed. I think, to get so many people into the room to begin with pre-10 o'clock in itself is quite an achievement. So great to have you guys all here. I'm going to be taking, I think, a special mention also in that case to senior at the back that was ushering everybody in the last moment, getting, no seats in between to be left free. So good job. I'm going to be taking you all through facades related to 3 projects in particular that I want to take you all through. And the premise being sustainability, really. Like Ahmed was mentioning in the beginning, yes, we're talking about facade systems. Yes, we're talking about a complete system that envelopes the building. However, it's not necessarily a completely curtained system. It could be, it could have glass, it could have solid volumes itself. So the idea was to take you through these 3 projects. The first one focusing on microclimate, thermal comfort, and cultural relevance. Also, I'd like to bring a little bit of a point of, let us say, how a client has to do with every project, because facades tend to build a lot of legacy over time. And when we look at facades, we look at the uniqueness that can come about of in a project. And we put 3 things down over there. We say climate, context, and client. So the climate is the easily understood one. Buildings sitting in different zones obviously have to replicate the particular zone. So a building sitting in Rajasthan cannot look like a building sitting in Kerala, for example. Context is how the bylaws, etc., are perceived. What is the relevance of the cultural relevance in the years gone by, and finally the client, because every client, like I said, is building some legacy. So over here, the target setup with the client was, he said one simple thing, Pankaj Bhai. He said better than home. Okay, so he was looking at his employees. He also had this vision of having something iconic. So we were looking at something iconic, which is where we came up with the microclimate screen, which is a massive 50-meter tall, 130-meter long screen that basically acts as a sieve to create a microclimate on the rear side of the project where his people sit. Over there, so you've got a very solid wall up front, and then you've got a very porous, where the facade tends to disappear in the background on the rear side. The second project we're taking you through is a project we're doing with Infosys. So here we're looking at high-performance facades. And something that came about when we went in first pitch to Infosys for this project about 4 or 5 years back, the project is now complete. It was an international competition. And we went about with a pitch that formed around being totally off-grid. So we decided on this 100-acre campus or so to look at how could we create a small little oasis for 20,000 people and keep them off-grid for energy. So 0 energy from grid, 0 water from grid, and 0 waste to landfill. And we went there with a complete team, including all consultants, including energy consultants, performance consultants, and presented. And we got selected over there. Something very interesting that Mr. Murthy said was, this is exactly the approach we're looking at. We're looking at very high-performing buildings today. Over the last 20 years, if you see our buildings, we've designed buildings that were replicas of buildings sitting in the West. The idea being that at that particular point of time, we had to prove to the West that anything you do, we can do, because we needed their work. Today, we don't need their work. So we definitely can build today for the context that we sit in. And we also have 15, 20 odd years that we have to correct for as well. So we're looking at buildings that can actually start giving back. The third building that we're looking at is the Surat Diamond Bows. I'm sure you all have heard about it over the last couple of months or so. In the Surat Diamond Bows, we're looking at the fifth so-called elevation. So every building, every volume tends to have 4 elevations that sit on the 4 sides of the building. The fifth elevation could theoretically is, the top of the building that encloses it and then forms the final envelope. So we don't really restrict that to the top of the building. We're restricting it basically to every other coplanar surface, which in fact is, the whole site if you look at it. The idea being that if I pick up any site, I should be able to, at the end of finishing that project, I should be able to give back that many square footage or square acres back to the people, ideally as landscape, as green, as ecology. So any site that you pick up a 5-acre site, you should at the end of that project be able to give the people in that project 5 acres of green, of landscape, of that horizontal plane. Because you are going to end up with that plane, wherever it may be, on site, on a podium, on a rooftop, intermediate levels of terrace, etc. Again, going back to the culture of the client, this is the Diamond Bows. It was set up around 4,000 odd diamond merchants that decided to come together all the way from a 500 square feet office in the complex going up to about a 50,000 square feet. And understanding the business, a lot of times in architecture helps you understand the brief and therefore understand the product that you're trying to design. So over here, what we got was that each person as within that group, they tended to do a lot of their business, not really in the workspace. They tended to step out of the workspace and do it in the remaining, the leftover space, the negative space. So the internal courtyards, all of the circulation space. Those actually form the points at which people would actually close business. So jumping in. Zydus, this sits in Ahmedabad. So that's the screen that you see, Like I said, the vision from the client was something iconic, yet being better than home for each employee. And what we came up with was these walls that you see 2 of them, there's a third wall behind. These walls span across 130 odd meters, they're 50 meters tall. This is the first view that you see of the building. A lot of times it also is quite difficult for clients, so this particular client used to get calls for the 2-3 years that the project spent building. They used to get calls and people would call saying that you've got these solid concrete walls up against the main front of the site, the highway, so what is this? People tend to, build glass, build a lot of porosity, have a lot of light, things like that, that normally visually seem acceptable from exterior sides. But we had a solid wall, but this was the west wall. So what we went about doing was, we were looking at these 3 walls as, protection walls to be able to protect the entire, ecosystem, the small little, oasis we were creating on the inside. So what we ended up doing was, we have 3 doubly curved screens, as you can see, cotton steel walls. All of the circulation, all the non-habitable space tends to sit within these walls. So all the circulation, staircases, cores, toilets, meeting rooms, server areas, all the non-usable spaces, the breakout spaces. And then beyond that, what we have that you see there are very linear, north-south oriented glass buildings that open out onto multiple different courts. So great amount of connectivity from inside and outside, yet completely shielded by this microclimate screen from the west side. And therefore, we were able to hit amazing targets on 40% reduction in energy performance, 50% reduction in heat gain on envelope, 100% solar control, so no direct sunlight, no requirement of blinds or glare, 100%, 90% daylight, zero glare, and a 7 to 10 degree reduction on all the outdoor space on the inner side. So those are some of the flow plates that we had designed. We obviously, because these walls, like I said, were doubly curved screen walls up front, we did need to get into a certain amount of modeling. So it was all done off BIM. However, so three-dimensional, we obviously had to draw it up on BIM. One of the saving points that we're trying to show you here was each wall, and that's the smallest wall that you see, had 1420 entry points to be able to capture the curve of that wall. If somebody had to do that, even if I spent 2 minutes on each entry point by cutting an elevation and section, it would take a person, a week just to extract the points for the smallest wall. And that's where scripts come in. So we were able to extract everything out in basically just like that. So a visual of how, the wall protects on the outside and the space that you see on the inside. What we also looked at culturally over here was to go back and do some research. So we see the forts of the region, and that's where we picked up from the fact that, these really tall walls, rampart walls, a lot of depth to the wall that starts basically acting as a solar catchment and therefore reduces the transmission of heat. We also looked at, because we were looking at this as a sculptural element sitting over there in landscape, we looked at metal work, metal being the most malleable. So the Kansari, work over there, and we picked up the material cotton steel. And finally, on these huts that you see, the mud huts, the use of these little mirror works, that they use to kind of articulate their facades. That's what you see in those triangular dichroid panels that kind of puncture through and bring some filtered light through those walls. There was a lot of jugaad also that came into, the actual construction of those. So if you just saw that video, we imported certain amount of shuttering from Germany. However, in the usual Indian way, we had to bring in our little intervention of jugaad in, where the laborers were basically using these small little fattas and using them as the gappers, because that basically those sheets act like egg crates, and therefore they're malleable in both directions. And that's where those little fattas of wood came in to allow for that. So some visuals again of the building on the outside, the sculptural side towards the west, and then how it opens up on the eastern side with pure north-south facing. Coming into the second project, Infosys. So here we were targeting three things. We were targeting 100% daylight, we were targeting 100% glare, and we were targeting minimizing solar gain. So yes, we want daylight, but we don't want heat. Okay, and that's the the fine line that everybody in this room is always trying to adjust between. Any vendor that we're talking to for glass, for a material of cladding, it's always it's the game between these three. Apart from, like I said, being off-grid from energy, water, and waste. So these are the parameters we set down. We said 100% daylight autonomy. We said less than 10% solar exposure, so direct light that then leads to glare on the workspace. Less than 0.75 watts of heat load. Conventional buildings will tend to sit at about anywhere 2 to 4 watts. Any good rated building today would tend to sit at about 1.5. The target was to try and half that. And finally, zero glare. So what we went about doing was worked out the flow plate required based on the modules that the team worked with. And so that is technically, a square flow plate. And we broke that down based on the amount of daylight penetration to what the ideal flow plate width would be to hit 100% daylight. What we then went about and did was look at the orientation. Now, Nagpur sits at 22.5 degrees latitude, which automatically means that if you start angling your tower to that particular angle, what you're able to do is you're able to negate one side. So you angle it towards the west. You therefore have to deal with the west sun, but you can completely cut out the east sun. And same for the other side. So obviously, north and south are easier to deal with horizontal shading. However, east and west will always require, and no matter what you do, even on a pure north-south building, you are still going to have some amount of east and west. The point is that when you get west sun in and you try and counter for that, your fins will angle to such a way that you will therefore allow east sun in. And that's why that angle helps to negate one complete side out. So these are some simulations of what we were targeting on daylight and solar exposure. So as you can see, we integrated now, or when coming to daylight, we want to get daylight in, you want depth in, and that's where the integration of this particular light shelf came in. So light shelf to allow for sunlight to come in, bounce off, penetrate further in. And what we've also done is we built up a spandrel panel. Now conventionally, when you go into a workspace, people tend to want to have full daylight, full openable, full glass. That is something that you will tend to do whenever you're designing, let us say, a leasable space where you don't know the end client. When an end client normally steps into that space, they step into a blank, empty office, and therefore they are looking at maximum light. However, when we start working with clients like this, that roughly know who their end user is because they themselves are occupying the building, that is where we come in and we start building in spandrels, because any light that you actually gain below this point is only heat. It's not really adding to the value of light that you're getting on a tabletop, which is your usable light. We then further went into the actual design of the fenestration. So looking at DGU systems, optimizing the DGU system a little bit on SAGC to be able to drop wattage from about 1 watt of heat gain to about 0.8. Spacing of shading. We were technically able to space the shading to even drop it all the way to 0.5. But it's always a trade-off between the amount of views that you're trying to capture as well as the shading you're building. So we came about with the second option, which was tended to be a 600 or so spacing. That gets us to 600 size, 1200 spacing. That gets us to about 0.7. And that's how that shading tends to work. So like I said, cuts out totally on one particular side and then has to only deal with the other side. Another thing that we also worked on was the play of the shading itself to bring some dynamism to that facade. And so what we looked at was in the workspace where we intended for people, they have very clear divisions within these work groups of workspace areas and collab spaces. The idea being the workspaces are very focused working, and you are definitely not looking at an ounce of glare on any table, while the collaborative spaces tend to be much more brainstorming, views to the outside, much more enhanced connection to outdoors, connection to time, connection to landscape. And therefore, what you see over there was we worked within a play of facade ranging between a 45-degree to a 60-degree across the workspace area and the collab areas. The light shelf and solar section. And so finally, what we were able to achieve, and that's what you see inside there. We were achieving a 300 plus level of lux. There is no direct light, as you can see, all across the flow plate. That's a view from the inside. That's the solar meter over there. So we're at a 300 plus lux over there. No glare, as you can see, 100% daylight. Some of the other things that you see in that picture are radiant cooling, for example, on the roof, along with low velocity fans and all. Infosys were even able to, so when you do an end user building, the client themselves can also start looking at systems. So obviously, in our control as architects, and every vendor over here, our control is really on the facade. That is the one thing we can control. We cannot possibly control the number of people that step into that building. We cannot normally control the amount of equipment that goes into that building. Okay, but we can control the envelope. And those are the three things that in the end lead to the amount of heat that gets into a building. In the case of Infosys, we were able to look at the systems. So we did look at a radiant cooling. We were able to enhance air movement through fans and therefore add to that. So finally, what from the targets we set about, what we were able to hit. We hit 90% daylight autonomy across the flow plate. We were able to get solar exposure hours to under 5%. We were able to get the solar load to 0.66, and glare criteria was 100% glare free. Apart from this, we were also able to do massive amounts of drops in performance. So performance dropped to 50% almost on the energy consumption. We were able to take up with the system of radiant cooling, along with air conditioning, along with the use of fans to move air. We were able to push conventional benchmarks of about 200, 300 square feet a ton to 800 square feet a ton on air conditioning loads. We built obviously a very dynamic kind of facade that related to the interior space and a glare-free space. So as you see there, daylight, there's a slight sliver of daylight that's hitting the floor, not actually getting to the tables. That's the built image. And finally, Surya Diamond bows. So here, like I said, we were targeting how do we enhance the amount of landscape, the amount of green on site? How do we deal with the population? So if I come to some of the pain points, we were looking at a cost benchmark of about $50 per square foot or $500 per square meter. We were looking at approximately 6.5 million square feet, single go building. We're looking at densities of about 65,000 people coming in, 10,000 cars. Like I said, we had small offices, 300 square feet carpet going up all the way. We had multiple units, so we had multiple owners. This was normally the scale of meeting, this was a client meeting normally with Surya Diamond Bows, because roughly 100 people would turn up because there were 4,000 clients. And finally, we were looking at a lot of adaptability because the Gujarati community, looks as community and the power of the multiple, very well. And therefore, the idea was that the coming together of one person could give a large order. If an order ever came in that was really large, how do 10, 15, 20 people come together and be able to deliver that order? At a macro climate level, what we were looking at was, again, north-south oriented buildings, as you can see, space between buildings so that all of the landscape is ideally shaded while the buildings are not, so daylight. And when we come to the micro level, and that's where this particular part of the topic actually starts, is where we started looking at that, again, that entire central spine, which formed most of the circulation. So we have a massive amount of area there. This is all naturally ventilated. The reason why you see the form of that spine that opens out to either side is to create the venturi effect, to accentuate the wind movement through. We also do have these vertical forests that kind of grow up the tower, create a stack effect, and naturally pull the air in more. Bring in a lot of vegetation over there, drop the temperature. We've also added radiant cooling here all along that spine that further enhances the temperature difference. So that's how those central kind of greens work. That's how the external landscape greens work. We've got about half a kilometer, of length of spine over there, completely naturally ventilated, that forms that breakout space. The radiant cooling system being installed, and then some visuals of those inner landscape lungs, green forest lungs developing. So overall, we were able to shift about 30% of the entire brief here into, sitting between the facades, almost sitting between, completely porous facades, and acting completely passively conditioned with nearly nil mechanical lighting and some amount of radiant cooling. We were also, therefore, overall able to drop both CapEx costs and OpEx costs. Yeah. Thank you.
Thank you so much. Thank you. Ladies and gentlemen, a big, big round of applause. What an iconic presentation. You know, I must say, John has truly engineered landmark buildings, landmark architecture, and of course, the world is now recognizing it, and we're so proud of that. Well, on that note, thank you so much, John, for joining us today and kickstarting with our event. Next up, for our next talk. So first we started beyond the surface, the multiple facets of building facades. Now we're going to our next topic, which is facade in high-rise buildings, unique applications, as well as energy-efficient installation systems. Well, we're elated that we have with us the VP Sales and Application Engineering, Fundamax, T.S. Aditya, joining us. Let's give him a warm, warm round of applause whilst as we welcome none other than, ladies and gentlemen, T.S. Aditya. Come on, you can be much more louder with that applause, everyone. Let's get it going. Thank you so much for joining us.
Good morning, one and all. I hope my voice is audible. So, thanks to Zak for organizing this conference. I would like to start the presentation with a small video.
Change. Change is our constant. A journey over the last 130 years. We are rooted in change. Change is our way. And we are doing it again. We are changing. We think freely. We think ahead. We are Fundamax. We live perfection. We love design. We respect individuality. We complete what nature gives us. And we know where our journey is taking us. We are open for new ideas, for inspiration, for tomorrow. Open for you. And open for you to create. Fundamax.
So the topic for today would be high-rise buildings, and then we'll look at some unique facade applications. At the same time, we'll also look at some energy-efficient facade systems as well. Looking at the history of high-rise buildings, you can see a lot has happened over a period of time. If you look at 1908, you have the Singh building, which is slightly less than 200 meters. And over the period of time, one of the tallest skyscrapers that we have is Burj Khalifa, which is over 850 meters. And these are a few of the tallest buildings in India, which is Palais Royal in Mumbai, which is 320 meters, Supernova Noida around 300 meters, and then we have the 42 in Kolkata for about 268 meters. So let us look at the prerequisites of a high-rise building. There are few things that come to your mind when you talk about it. First thing, obviously, is the aesthetics. Everyone wants to create a new design, which can have a long-lasting impact. And second thing is the energy efficiency. We all talk about energy efficiency. We'll try to understand what kind of thermal comfort you get and what is the energy savings you get by implementing certain facade material. Then we also talk about wind load. Obviously, you have the chimney, you have the tunnel effect, and then you have a lot of buildings that are designed, especially which are facing seacoast areas for 3.5 kPa, 4.5 kPa. So the system and the product should be able to sustain heavy wind loads. And then we have fire. Of course, you have the chimney effect where fire spreads very rapidly, so you need to use the right kind of installation systems, which is fire rated, which can withstand 60 to 120 minutes based on the facade consultant specification. Then we have, the product should be very easy to install. You have obviously unitized systems and various other installation systems which will also save time and which can also speed up your work. Then we have maintenance. The most important thing is once you complete the facade in the beginning, everything looks great, but over a period of time, how you maintain it and how sustainable it is equally important. Coming to Fundamax, Fundamax is high pressure laminate, is manufacturing high pressure laminates and other interior products. The company is formed in 1890. So talking about the aesthetics, there are two basic parameters that we have to consider. One thing is how the product performs over a period of time. So it should not have any kind of, effervescence or any kind of salt formation, or it should not fade, it should not delaminate, it should not warp. So these are the few things that generally come to mind when you talk about a facade material. So two important parameters is artificial weathering and UV, which are very important, because half the times panels fade because of direct ultraviolet rays. So there are certain testing standards as per EN ISO 4892 Part 2 and Part 3. Every panel has to be tested for a high pressure laminate for about 4,500 hours for UV and weathering, which is scrutinized in an accelerated chamber. And you have diodes which emit UV rays, and also you have some small blowers which blow sand and dust particles. And after 4,500 hours, you remove the panel and check the degree of fading, which is called the grayscale test, which is done as per EN 20105. And then if it's above 3, then the degree of fading is not visible to the naked eye. Then you can actually call the panel that is certified to be used as per EN 438 Part 7 norms for exterior facades. So we have different classifications of products. We have a Class B product, we have Class A2 product. So depending on the requirement, Class B is basically a flame retardant product. Class A2 is completely a non-combustible material. So we adapt a system called rear ventilated facade system. There are 3 prerequisites. The gap between the facade panel and the wall should at least be more than 2 centimeters. There should be a gap on top and bottom of 2 centimeters so that there's free flow of air behind the panel. And then you have a concept called, energy efficient facade system, where the hot air enters through the cavity and then rises up because it is less denser, and then you ensure that the air is pushed out from the top vent. So this ensures thermal efficiency and keeps your building cool. And there are other uses of, rear ventilated facade system, because the sections act as bracing, they cover up the cracks, you have better acoustic properties, and then you also have, you can avoid diffusion of water vapor. Generally, the dampness in the walls and all come because, when there's water and when the water remains there for a longer period of time, you can see the dampness inside. So all those can be avoided if you use the right kind of installation system. Coming to Fundamax, we are not just into product selling, we sell the complete system. So we design our own dead load, wind load brackets, depending on the specification of the architect and the consultant. We design what should be the spacing between the framework, what kind of brackets to be used, whether we need to go with MS brackets, aluminum brackets, everything is designed by Fundamax, including the fasteners. So there are different systems. The one that we have seen earlier is the riveting system, which is the traditional system used for HPL. But of course, when it comes to ceiling applications, a lot of them do not want to see those rivets. So we also work out new systems which include the clipping system, which can be used by making a lap joint in the panel and then using a clip, which is fixed using a L angle fixed to a dead load bracket, which is anchored to the ceiling. This will ensure that you have a seamless finish, and the groove between the panels is also minimized to 2 mm. We also have an undercut system, and for this we use clips which are fixed on the back of the panel, and then they are fixed onto a horizontal profile, which is supported with a vertical profile and a bracket. So this can be used, this undercut system, you need a minimum thickness of at least 8 mm, because the screw that goes into the panel, which is used to fix the clip, is at least minimum 6 mm in depth. So you need minimum 8 mm to 10 mm, and the thickness would vary based on the wind load. So we have to look at the wind tunnel, we have to do the wind tunnel analysis. We have to look at the impact of wind load. And, the costing of the framework can go tremendously high based on the wind load that is given to us. If it is 3 kPa, 3.5 kPa, the cost of fabrication, the size of the dead load brackets will change drastically. And depending on the height of the building, either you have to increase the thickness of the framework, thickness of the panel, or decrease the spacing between the framework. We have also done some energy simulation. We have used a software called eQuest. We try to understand the sun path analysis by using software like Ecotect, which is, again, in compliance with IGBC. So we try to take a case study to analyze, if you use a cladding material like HPL, what is the exact kind of energy efficiency you get? So we have taken a 10 meter by 10 meter building, and then we have taken a height of 5 floors, each floor being around 3.6 meters. And then we have considered the north and the east facing with cladding, and cladding, and south and west with glass. And then we have tried to analyze what is the kind of impact that you're going to get by using this system. When you calculate the U value of any system, then you'll have to consider not just the panel, but you also have to consider the substructure. You also have to consider rock wool, and you have to consider the U value for the entire system. We were able to achieve a U value as low as 0.45 watts per square meter Kelvin. So now looking at that, traditionally people generally for high rise tend to go with the normal texture paint. So instead of using a texture paint, if you use the system, which is obviously much more expensive, then what is the break even? So we have realized that if the energy savings, because the load or air condition reduces drastically, we could identify that the break even can happen from the 5th year, and after the 8th year, literally you'll start saving the money in terms of your electricity consumption. When we use a rear ventilated facade system, then because of the chimney effect, the fire can spread very fast. When you talk about fire, the basic substructure that is used by most of the facade manufacturers is aluminum. Aluminum melts at 600 to 660 degrees centigrade. So even if the panel does not give away with the temperature of 600, but your framework is going to collapse. So the entire framework can collapse along with the panel. So it's very important to understand what exactly is the substructure used, and adapting a principle of rain screen facade system where you compartmentalize the complete facade. So wherever you have an opening in the dead wall, generally fire accidents happen because of short circuiting somewhere, and then you have a lot of combustible materials inside the building like carpets, your furniture and other things, and fire spreads very fast. So wherever you have an opening in the dead wall, fire enters through the dead wall and tries to spread because of chimney effect. So it's very important to compartmentalize various things, use fire stops at the right location so that you can arrest the fire, make sure that because of lack of air supply, it gets extinguished in that specific compartment and does not spread to the adjacent compartment. So these are some of the high-rise buildings what you can see in India that we have executed. Jain Heights in Bangalore, HM Construction in Bangalore, and this is a 13-storied building, Mantri Lithios again in Bangalore. Then this is Mahindra Luminaire in Gurgaon, and this is the largest single-owner residence. I think we all know what this project is. And Vasant Kunj in Mumbai, we have used the black decor and the wooden decor. And then you have SBI Noida, it's a residential tower. This is Trill in Chennai, where we have used it for a lot of spandrel areas and also for the vertical facade cladding given to the sides. It is G+14 building. These are few projects, international projects done in Moscow. Again, they're high-rise buildings around 83 meters in height. We have done 3 blocks for them, and we have also done Green Park block for the residential complex in Moscow. Now we have seen some of the high-rise projects and then what are the prerequisites. Now we'll go through some of the unique projects. Here the panels are perforated panels, 700 mm by 700 mm panels. They're suspended on stainless steel ropes, and it is a kinetic facade. So based on the wind flow, they keep oscillating. Some of them are singular panels, some of them are doublets, some of them triplets. And this is during the night view. This is a project in Vizag. It's surrounded by hills. You can see panels which are at different levels. This is for Kai International School in Bangalore. Again, we have done the profiling at the edge and the cladding here. We have integrated with semi-entire system. This is done in record time of 2 months. So wherever you see the opaque panels, it is Fundamax, and the transparent panels are glass. This is a project in Czech Republic for a station, and we have used our MLOOK panel, which has a glass fiber mineral core. This is for Ahmedabad University. It's a lower system, and they are manually operatable lowers. You can also integrate your lowers in such a way that based on the sun path, based on the heat ingress, it can automatically open and close based on the requirement. You can also automate it, but this is a manually operatable lower system. This is a parametric ceiling. This is for a KMCH library block in Coimbatore, where we have used exposed concrete kind of finish. This is school building. You know, this also not only improves the aesthetics, but also acts as a safety grill, because there are primary school students' classrooms behind us, and it also ensures that kids don't jump over it. This is again a parametric facade. You can make it vertical, horizontal. You would have seen a lot of these kind of projects internationally. So we use rivet, and then we try to design we understand the curve pattern, and then we make closed curves so that it appears like a wavy structure. This is again a parametric application. So coming to Fundamax, the company is formed in 1890. We are there in the industry from more than 130 years. We are formed in India in 2007. We have executed close to 15,000 projects in the last 15 years. And we operate through our channel partners. We have around 62 channel partners across India. So they are the ones who are going to supply the material and also do the complete installation. We provide services of shop drawing. We do the complete analysis. We do even the structural calculations. Of course, it has to be vetted by a structural consultant before it is approved and before we do the installation part. And our manufacturing facilities in Austria. We are in discussions to start a plant in India shortly. So we maintain a stock of almost around 1 lakh square meters at any point of time in our Bangalore warehouse, where we have our corporate office as well. So this is about Fundamax. And just as a summary, this is a just to close the discussion, this is with the glossy panel. You have the perforated panels, you have louvers, you have manually operable louvers, and you have parametric facades. We have a booth outside, so please do come and visit, and we'll be very happy to guide you. Thanks for the opportunity.
Sure. Thank you. Come on, ladies and gentlemen, let the applause continue. Such iconic and great projects they've executed. You know, I must compliment T.S. Aditya, of course, on the great projects, but also the amazing, unique applications which he pointed out during his presentation and the detailing which he showcased. I think let's give him once again a thunderous round of applause for showcasing such great projects. Well, now, as we said, that we are here to unite, we're here to learn, connect, and innovate. Of course, we're looking at a global perspective. My next speaker, who's going to be joining us, has traveled all the way from London. So I'm going to say a very good morning. I'm going to welcome him with a huge round of applause. Ladies and gentlemen, we're talking about global leader of the Building Envelope Skills Network group. We're talking about none other than Russell Cole.
Thank you.
Come on, ladies and gentlemen. Thank you, Russell.
Thank you. Good morning, everyone. Good to see you all again. I'll go quickly through my presentation, and I'll try not to go over time. Last year, you might remember my rather ambitious presentation about how facade industry can save the world. And you might remember this escalating concept around how to build a better building and how to reduce the environmental impact. I'd like to hone in on one part of that today. Now, the reason being is that I get a lot of work looking at facades that have failed and things that are going wrong with buildings. And also I see that a lot of wastage happens during the construction process, and I see that a lot of buildings get demolished or replaced too soon. So how can we stop that? I'd like us to always build to last, right? You know, there's a huge investment made when we do a new building. It's money, it's effort, but it's also, most importantly, materials and energy that have come from the environment and potentially might impact the environment. We need to create assets to communities and actually build local heritage and personal memories in these spaces. The cost of waste is enormous. The shortened service life of a bad design, unhappy occupants, waste of materials, increased energy and carbon, and then also the impacts on communities as there's always building sites happening around them. By the way, this actually is a 70-year-old classic school. Those architecturally trained amongst you might recognize it. It's the first modernist school. It survived because of its of that being the first, but many generations of school kids have suffered cold and overheating and wind blowing through their building for 70 years. So we need to look at unsuccessful buildings and think about how we can avoid them. They'll be redeveloped. They give a poor market perception. They'll drop in value. They'll look shabby and deteriorate. They'll be uncomfortable. And of course, so high cost of maintenance and always being looked at. And as I say, they might get demolished, which then of course creates waste. And obviously we want to avoid waste. It shouldn't go to landfill, we should do something with it. But normally we know that chaos is created when we demolish a building. So we need to move towards circularity, but the best thing to do would be to not have to demolish or replace things. If we can build to last, we'll be serving the ecology well. Okay, an extreme example, Portcullis House, designed for 100-year design life, really changed the design decisions made during the development of that building. So what's a well-built facades? Well, I actually define it by what it's not, right? The performance is essential. It's got to be safe, of course. It shouldn't be leaky or moldy. Things shouldn't be falling off. We shouldn't have air leaks. It's simple, really, but we all know it's very complex to achieve that. So let's drill into that a bit. Now, those of you who know me will know that this is a very old presentation or concept from 20 years ago when I was trying to explain facade engineering, facade consultancy to architects. And I came up with this hierarchy. It still holds pretty well, and I actually use it to structure specifications and the like. So the most fundamental thing a facade needs to do is to be safe. It needs to form an enclosure. It needs to provide a structure around people. It shouldn't collapse. It shouldn't be a fire threat. Then the facade needs to act as a barrier. It needs to keep things out like water, pollution, strong air, strong winds, and maybe sound. But we actually want some of those things to come in. So the facade needs to act as a filter. We need to control how much light comes in, how much heat comes in, how much temperature variation happens across the building envelope, airflow, and maybe you want to be connected to the sounds outside. So we can design our facades to filter the external environment and what comes in or goes out. Then we move on to aesthetics. It's important, there's a certain, it is going to define the building, it's going to mean it takes its place in the community. But the function needs to be reconciled with this appearance. It needs care and beauty and good design to do well with aesthetics. And finally, we need an integrated facade that is holistically designed with the building so that it all comes together, operates well, and has a minimal impact on the environment. I call it the move from what a refugee might want to what a utopia might have. And of course, real world gets in the way. There's all sorts of constraints and influences on this. But I'd like to go through a bit about what goes wrong in the event of failure and feed into the issues that come around from bad design. So strength failures, things falling, things breaking, buckling, fires. The thing about these failures are they're quite newsworthy. They're extremely significant. Clients are terrified of structural failures or fires in their building with good reason. These are safety issues. So, it's important to nail this first. What we all don't want is a phone call when you come back to work to say that a piece has fallen off one of our buildings. And then we think about if there's a failure of the barrier. Now, if you've ever had a building that leaks, you know you've got a very upset client. There's all sorts of consequences. People have to rush out there. It's a really big failing of the building. However, it's not quite newsworthy. It's not going to be on the TV unless it's kind of like a scandal because it's a government building where they've spent lots of money, right? Important, but not as important as, say, the structure. Then you've got the environmental improvement. If you fail on the filter, you're looking at uncomfortable people. It's too bright, it's too hot, it's too cold when you sit near the facade. The energy bills have gone up. Things will be done about it. They need to be fixed. Things can be improved. People might take to leaving their blinds down the whole day or even putting extra covers on their windows to stop the heat coming in. So it does have an impact on the ability, the value of that property, and it does have the impact on the users. And then if we think about aesthetics, poor weathering, discoloration, uneven finishes, things out of line, things sagging, all of these also build a bad perception of the building. They certainly hit its status. People maybe don't want to work in that ugly, badly cared for building. So it will drop the perception of the building. So it's important. And of course, there's plenty of things that can go wrong aesthetically. You can get lots of things bowing. And this is what happens if you mix up your vertical and horizontal roller wave, by the way. And then we get to the integration. If you didn't integrate all of this, actually, it's a loss of opportunity. But I think you can see by reversing the order of my hierarchy, the importance of get the fundamentals right, structure and barrier, and then do what we can do around the performance of the facade and create a good impression. But there's certainly a hierarchy to how we approach design and what we do. So what do clients expect? What they fairly can expect is things that work. They meet the requirements we've all agreed that the facade and the building should achieve. There should be some delight at the end of the project. So they invest in their consultants and their architects, and they pay the contractors to deliver, normally set through a contract, right? Yes, time, budget, and quality all needs to be met. But of course, the real thing is none of us want to go back to a building and go and fix things. So it should be right first time. There's a clear contract, but things along the way means that isn't always what the outcome is, and that's what I'd like to dwell on for the rest of the presentation. So, when a project falls short, occupants are disappointed, tenants are unhappy, they might be disrupted by repair works, clients complain, there'll be a loss of money, might be even disputes, but really importantly, precious value of the materials and energy that went into the building that building has been wasted and destroyed. And worst of all, the building might only last 10, 15, 20 years before it needs to be refurbished. And of course, things can happen at every stage of a project. So let's go through that in a bit of detail. So at design stage, structural engineer under-designs something, the brackets are too weak. You might have weak details, I call them, ones which cause leaks, ones which cause air ingress, and ones that cause condensation. Insulation might let too much energy in or cold out or whatever you want to think about. Inappropriate materials will cause problems. Movement joints need to be respected, and breaks in the air and water lines will cause trouble. So there's a lot of things that need to be resolved at the design stage. But then we go into production. One of the biggest impacts here is choosing the right materials. It's got to be carefully selected and specified. It's got to be right for the exposure. It's got to have a consistent appearance. It might be a naturally variable material like stone, so we need to work out how to manage that variability or control the quality of something like a paint finish. Flatness, reflections, and appearance will all impact the aesthetics. Strength, thermal properties, And of course, a special category is glass, where there's enormous numbers of issues that can arise, right? You know, float glass can have bubbles and inclusions. Lamination can be distorted, it could delaminate. And then we get things with tempering, making the glass move from being a nice flat surface to being uneven and distorted. And double glazed units can all fail in service if they're not built properly with seals around the edges. And here you can see anastrophy, the leopard spots on your glass, and delaminations. These ones are only in the edge zone, but if they start to spread into the visual area, we know we've got problems with that glass that probably go beyond visual issues. And then once we've built panels, we need to look after them. So we invest a lot in materials. There's a lot of time spent in factories, a lot of energy spent, the time and cost of the workers. Now, why have I put a picture of a hammer on here? Well, this is my friend Richard in Singapore, who used to work for a subcontracting company. I'd do an inspection, and then I'd catch up with him in the evening over a beer. He wasn't on site, so I told him how I'd gone to site, and there was this big scratch across the glass on this panel I saw waiting to be erected. The next morning, Richard, who's quite a colourful and dramatic Welshman, picked up his hammer, went out on site in front of his workers, and threw the hammer at the curtain wall panel that I spotted the scratch on, destroying it, smashing the glass. The workers were horrified. Why have you done that? And he shouted at them about how much value they'd ruined by putting that scratch on that glass. You know, he knew that the glass had to be replaced. The glass can be replaced, the panel can go up. But those workers learnt a lesson to be careful with the handling of their product. So there's a lot of things we can do, but I like the concept there that we have to protect the value of our designs and our production right up to that point where we hand over the building. So, you know, I've just talked about scratching, dropping things, storing things on site. They need to be respected. They need to be out of the mud. They shouldn't be beds for workers to sleep on or have their lunch. And then we should be careful about, once we've installed something, that it's well protected and it doesn't deteriorate. And then, of course, we all know that things happen during installation. Things get broken, fixings are missed, things go out of tolerance. You might put things up in the wrong sequence, the protection might get trapped, and then it might get exposed to the weather before handover. And then in service, things go wrong as well, right? And these are probably more either a result of the workmanship, or they might be the result of design. So things might fail in the wind, may have not accounted for building movements, things might fail in Britain corrosion, etc., etc. There's a lot of things that could go wrong here. So what do we do for success? Again, of course, it runs through the whole sequence. So for me, it's vital to invest in design. There's a lot can be solved, a lot of good decisions can be made, a lot of bad decisions can be avoided. So go through the material selection, look at mock-ups, have samples, get into the technical details, research them, go and visit them where they've been put up. Design, take it to a resolved level, get into the non-typicals, make sure you've considered all of the forces acting on those panels or that cross-section, all those interfaces. I'd like to dwell a little bit here on design life. Like I said, you know, we start a building, and one of the first conversations should be around, well, what's the design life and the expectation for how durable the materials need to be, how far do we go between maintenance? So, you know, design life is the point where it can't be refurbished or repaired. There's definitions of this in British standards, and it's normally a product of the deterioration of the materials, or the systems become inoperable. Service life is similar, but is not set at design, but it's actually what happens, you know, the time at which the maintenance will not be adequate for it to maintain its appearance or performance. And then, contractually, we have a warranty and the warranty period, right? So that's at some point, contractually, we're going to set a time, and then the contractor's going to say that they will replace or even reinstall or reimburse if an element goes wrong. So let's think about those a bit more, right? So whenever you get a warranty, read what it's actually about, right? Sometimes it's only covering certain eventualities. It might be missing something significant. It might be limited just to replacement. They'll just deliver the new panel at your front door, or maybe you've even got to go and collect it. So go through that. What does it mean? One of the favorites I like finding is the glass supplier says that the glass needs to be cleaned every 3 months. So if you don't clean your building, your warranty is invalidated. You can't get a replacement. And of course, it only really is valid when the company is still in business. So if the company disappears, what worth is your warranty? So don't build all of your hopes and dreams on warranties. I know we spend a lot of time getting them out of people, but do look at them and do think about what's their real value. Of course, try and get it built into a network where clients actually get the relationship between the supplier as well as through the contractor. And just out of interest here, we quite often have these predicted, here's warranty periods. Obviously, you can see they're quite a bit shorter than the predicted service life. And I'd just like to think a little bit about that service life, particularly, where is it? I haven't got one here. Oh, clever me, didn't find one with the one I really wanted, which is like we say double glazing, lasts 25 years. So what's the real service life versus the design life? So at the moment in London, we're at the stage where we are going to buildings that are 25, 30 years old, and because we're trying to save carbon, we're not demolishing them. In fact, the City of London and City of Westminster will require you to do a circular economy assessment of that building. So a lot of people are looking at their buildings and saying, well, can I keep it? What to do with this building for the next 15, 20, 25 years? And a lot of the time, people go up to them and say, right, oh, well, that double glazing is 25 years old. We better replace it. I'd argue that don't do that. Go and actually have people who understand what they're doing go and investigate it. The building in the picture here is 25 North Colonnade, Permasolita building from 1990. We looked at it about 5 years ago. We were doing some work down the bottom, some work at the top, and we found out that double glazing has not deteriorated at all. We did tests on it, we did an examination. So we were able to write a letter for the client to give to his tenants to say that they shouldn't expect any major issues with that glass for another 15 years. But by doing that, we actually saved a huge amount of material and cost that would have been, other developers might have said, right, 25 years old, let's replace it now. So it does pay to check these things properly. Also, design should anticipate an ongoing life, right? So we often say the frame has got a 50 to 60 year design life. Well, that implies that you have to design it so that one day you can replace all of the glazing or some of the insulation and the panels, because those might have a design life that's a lot shorter. And one Fitzroy Square, Finsbury, sorry, I've written that wrong. 1 Finsbury Avenue, sorry, apologies, we looked at it. And actually, this was a very remarkable piece of facade technology, because even though it was 30 years old, we actually only had to change the glazing, and we got ourselves still compliant with the current British standards, which had increased enormously about energy performance. One of the other things that people need to do is make sure they appoint the right specialist subcontractors. So to all the subcontractors out there, please convince your clients that you're the right person to do this project. And clients, please make sure, because I believe this to be the most important factor of success on a facade project. Go through pre-qualification, go and visit their factories. Go through a detailed procurement process, looking at the technical submissions, making sure you've got a good understanding of what materials are going to be supplied. Do they have a good design team? Do they have a good management team? Do they have reliable people that transport and erect their facades? So check the team. Also, have they got capacity? Can they truly accommodate the building and the project in the timeframes that you need them? Other strategies. Make sure you do visual mock-ups. Make sure you do performance prototypes. Test things. It's worth a lot of, it takes a lot of time, it takes a bit of cost, but it gives so much more confidence about the quality of the product that it means that you're building what you paid for, and you're getting the quality that you paid for as well. So protect the value of completed panels. Don't smash them with slump hammers. Have good site inspections, quality control on site. Have a system for clearing defects. Follow up what's going on. Is it something systematic, or is it just a one-off that's happened? And have excellent as-built records. And get your warranties. Make sure they cover all eventualities. So think about QA records, level of detail, frequency of checks, authenticity. Are they real? Is the man actually going out and checking the panel? Audits, digital records. How do we modernize this? I'm very keen on traceability. There's a story around these two screws I haven't got time to go into, but basically the manufacturer of the panels changed the screws, caused an awful lot of problems, and an awful lot of erected panels had to be changed. But because there was traceability, we knew which panels needed to be changed on that building. So keep records. Each element of a facade should have a birth certificate, so that you can find those components or batches that went wrong. We need to be able to map the facade and say, right, that batch went in that area. And it's a key asset. It needs to be passed to the owner. Talked about inspections and quality, visual mock-ups, off-site testing, factory visits, all very important. And of course, as I said, do invest in testing. It's a trial erection. You find out if the elements go together as planned, do the workers know what they're doing, demonstrate performance, it builds confidence. Don't test to destruction, because people then only remember something breaking. They don't remember everything working as it was designed. So investigate, learn, and correct failures, put them back in the design, and check that the structure is performing as expected. Big story there if I talk about it. As I said, get through installation, watch what's going on, but do first panel productions, do first installations, make sure you've trained the workers, QA/QC, handover is really important, so is clearing defects. Just want to go into things you might do on an existing building. You might use inspection. I wanted to introduce Arab Inspect 3D. Also, we're doing lots of things now with drone inspections. So this is the Lloyd's building in London. And here we are. We managed to get permission to fly a drone around the middle of the city of London. These are images captured by that drone. Unfortunately, though, there were 3,000 of them. Where were they when those images were taken? So we had to backtrack. We had to recreate the flight path of those drones around the building, and that allowed us then to generate automatically where the images were and what location did they come from, so that we could automate a report that captured those 3,000 images and records. So it's really important now, when we're working in the digital space, to think about how we're going to manage all of that data, how we're going to present it, how we're going to analyze it. So we do a lot of work now looking at 3D representation of information, as I say, automated reports, etc. We have software based on Unity. These are 3D models which we set up of buildings. We might talk about how different curtain wall types are organized, explain that to contractors. But later on, we can take these models on site with an iPad or a tablet and start to punch in the site observations as we're making them. That allows quick reporting, but it also gives a very strong interactive database of information that we know where it's geographically located on the building. And there's plenty of ways to do it. We have a lot of competing systems in Arup, and some people have found that these simple Microsoft lists work very well. You can set them up, and you can start recording your observations on site. But in the UK, almost all of the major building sites now have these different systems for going around site. You'll have drawings loaded up on your tablet, and again, you can record locations and record observations. I would strongly recommend that contractors and subcontractors begin to investigate these software. They really do help track things, keep things together, and create that good permanent record. So the dream is that construction follows a well-resolved design. It's been an easy project to build with no corrections or changes, and good records of all activities which you then present to a very grateful owner at the end. So that's the dream we should all aim for in our projects. The risk is we collect all that information and in the old days it gets stored like this. These days it just sits in a data file and nobody can read that format anymore. So need to be careful with the data we collect and think about the end users and how to use it. And I would advocate that should be presented in a 3D interactive way that should be accessible to all. It's the same slide as last year. I do think there's a lot we can do to save the world, but building well is a key cornerstone of that proposal. Please have a look back at what I presented last year. It all requires on the industry upskilling and adopting good practices. And to that end, my final slide, I'll promote again. I would encourage people to join the Society of Façade Engineering. I sit on the board. The society is becoming very active. We are creating lots of local chapters. We call them hubs. We've got one set up in New York, Italy, Hong Kong, Dubai. Why not have one in Mumbai or India more generally? So I encourage you, please consider joining the SFE. It will create a community. You can have awards, right? We've got the awards coming up after the Zak in London, and you can get some recognition of your projects and your achievements. So please consider the SFE. And with that, thank you for your time. Please come and find me, come and find Ritesh and the team later. Thank you very much.
Thank you. Thank you so much, Russell. Well, it is said that failure is one of the biggest teachers, and the aspect of learning from failure was something which was truly highlighted in his presentation. Must say that we'd humbly like to thank you, Russell, for sharing the depth and breadth of your experience today. Once again, let's give him a hearty round of applause. And of course, we're looking forward to interacting with him on the front of SFE. That's something which he keenly highlighted towards the end. And we're looking forward for it also becoming grand, of course, with the hospitality of India and Mumbai being in it. So ladies and gentlemen, let's continue the momentum. And up next, we have our next presentation. We're talking about advanced solutions for translucent facades. And we are elated we have with us Advanced Systems Product Manager, Danpal Hassan Khateb, joining us.
Thank you. Thank you. Good morning, friends. You hear me? Okay. My name is Hassan Khateb. I'm from Danpal. And I am lucky at least twice. First, I am here with you, friends. And second, I am the speaker number 4. Most of the items that I'm going to speak, already our friends spoke. So thank you, friends. Danpal is a global company that offers advanced solution for light architectural solutions and products for the envelope, the building envelope. And today we are going to speak about the facades. And as we can say, usually facade is a wall. Okay, it's a wall, but more than a wall, it's a fence or a separator between the outside where the conditions are uncontrolled and the inside of the building where the conditions can be in our hands. We can control them. In addition, that it should be take care also to be waterproof, airproof, the insulation, the noise, acoustic, all of this. So when designing a facade, the basic rules are, and all of us know them, and they are for years, hundreds of years, are the weather, means in terms of the water and the air, what we spoke, the strength. We spoke also about the frame, the wind load, all of this that we should take care about it. The thermal, the energy efficiency, the insulation of the building, the U value. We spoke about the U value. Mr. Ahad spoke about the U value, about the SHGC, and the fire as well. All of these are the basics. Every facade should give it, and it's for years, acoustic and the maintenance as well. But recently we see that there are another aspects in terms of daylight. So the daylight, see here we can see a building that also is a comfortable view inside the building. So why daylight? Daylight is good, first of all, for the people. And all of us, we know that the daylight, our body needs an amount of light in the morning. In the noontime, it needs another amount of light in the evening. So the light, our biological body uses this amount of light. And the research shows that once we give the natural light to the building, these also help the inputs that we can have. Employees in offices can have about 12% more productivity. We see it also in the factories, in the schools, in the universities, and as well for the sales and marketing teams. So this is for the people. What happened with the owner? Once we have natural light in the building and we spend less, so we spend less money. So for the client also, the owner, he has also his saves. Third is for the environment. All the buildings that now we see recently in the last 30, 40 years, and people are talking about the zero energy, the low energy buildings, the green buildings, they are requiring this light. We should apply this light, natural light, because once we have this feature, so we use less energy resources, less smoke, then less pollution, and this is what we. Then we have the conclusion also that we have a green solution. We have also the lead points that we should, in some cases, some places are requesting. So now we know that once we are going to design a facade, the basics that we require to give, and also these additional features become basics as well. So what material we can offer? Our friends spoke about the glass. This is a very good solution. The glass we see here, a nice building with the glass, all sides. We see through it if we want. We see it's clean. But the question is whether we need all this glass around. If we need, no issue. But if not, so let us see how can we combine it with other, because many challenges are with the glass. The first challenge is with the transparent. The glass is transparent, the basic is transparent. So once the light is going inside, it's straight. The light is going straight, it does not diffuse. And during our meeting with architects that they build these green schools with the wide windows, they found that children and the people that sit near the window, they get more light, concentrated light. then they are fatigued, they are also headache with someone. So the translucent is a challenge. Then the glare itself. Mr. Ahad spoke about the glare-free, that we agree with Mr. Ahad about this. Second is about the loads. Also our friend from Fender Max spoke about the frame, about the wind load, about the distance between supports. So heavy solution need also the heavy solution also for the frame itself, and the number of support, the distance between brackets, and so on. Third is glass is fragile, means we should take care. When we have this solution, we should take care because fragile, and also it's a bit challenging. I will not say very complicated, challenging with the installation. Needs more people, means hour of installation, and also money. In terms of the U value, the same, our speaker spoke about the U value. Once we have lower U value, we know that less energy will move, means in summer days, less energy will go inside the room, and in the winter at a time when we get warming the room, less energy will go out. And so all of this become mixed, this glass, a good solution, but in terms of the cost is a bit not cheap. So if we need it very well, facades that no need to have a glass, let us look for another solution. The second solution is the polycarbonate. I came from the polycarbonate. We are 50 years in this business. What we see here also a nice building. The first one was from all sides was glass. Here we see where we need it, it's a glass. Where we doesn't need it, so okay, so let us have a solution that brings the light, block the energy moving, have the acoustic, but no need to see through it, and see a nice combination between them. In the past, people used the polycarbonate for roof, but recently, in the last 30, 40 years, we see it more in facades as well. Now the polycarbonate itself, it's not transparent, it's translucent. Translucent means the light goes inside and diffuses. Bring a comfort zone inside the room with zero glare. The weight is half weight of the glass, and in terms of impact, it's 200 times better than the glass, and it means flexible. When it's flexible, so it's easy also for installation. Friendly for installation means less labor and also less time and money cost during the labor itself. In terms of the U value, we can reach till 0.18, the U value, 0.18. Also means very good U value. And so all of this it's a fair cost, fair cost per all these advantages of the product. So again, not competing with the glass, sharing with the glass. Where no need, so in order to give all of this together now, this package of the basic and the daylight solutions, how to progress, which company to offer, which company to look for. So we say, go for a company that gives you architectural solution. Leave what we spoke about the roof. Now we need something that also aesthetic. Go for a company that have more than 20 years experience, because during this experience, our friends spoke about also what you give, you gain experience from the field, and also you usually produce and develop your products more and more. Use high quality raw material. The polycarbonate that is used, it's a high-tech product specific for architectural use. The UV protection, why also? One time we need it for protecting the panel, and one time to protect the people inside the room. That is very critical. And go for a company that gives you guidance. Guidance means from the first, when we have the idea till we have the installation. So I am from Danpal. I am happy to be here. We are a company that gives light architectural solutions for the building envelope. You can see the application here, but the team decided to speak about facades, so we speak about facades. And we have more than 50 years experience in more than 50 countries. The headquarters sits in Israel. And then we have a company in France, in Spain, in Mexico, in Colombia, in Australia. We are proud to say we have in India as well, in South Africa, Korea, and now we are establishing in the US. We already have more than 100 million square meter of solutions, and we have a huge range of colors, and also we can produce any color. We work with architects. Sometimes the firm, the company wants its colors, so also we are able to do this. In terms of guidance, we offer our software, the light and thermal analysis. From the first stage of the solution, we make the calculation together with the customer. We give him a report of the consumption of light and thermal. Together with him, also sometimes we change the solution. We ask him to change the sizes of the opens of the windows, to add windows, take out. Means together with him, we finalize the solution. And then this is, and also then we follow him with all the support. This is a project. Also, the Danpal offer all the time new generation of products. New generation of system, we call it Danpal Thermal. This is a kind of cassettes, double glaze. The product arrives ready for installation. This is what you see here is 9,000 square meter facade in Uruguay. And the facade also is with the LED. This specific project, you can see here how the cassette arrived to the cassette. Every cassette is 70 millimeter thickness. Length can be till 12 meter. Then in the side is easy for installation. Every cassette that is 900 millimeter, they connect several together and rise it. So very easy for installation. And the project itself, as I said, it can be also with LED. So like this product, like this new generation of products that we offer for facade, we offer as well for shading, we offer for interior. All the time we are having our own products design. We are really leaders in this market, and you are mostly welcome to visit us in our stand here, and we can share with you our products. Thank you.
Sure. Thank you so much, Hassan, for joining us, and of course, sharing and showcasing a glimpse of the new generation of facades. And of course, we highly value all the information and knowledge he's presented. So ladies and gentlemen, we're going to be shortly breaking in for a networking break. So the biggest event of the decade. Let's give a big, big round of applause, ladies and gentlemen, to the entire team of Zak. Heartiest congratulations. And on that front, let's continue with the learning. Well, right now for our next conversation, it's going to be on high-rise residential buildings, current trends. We're honored and elated to now have the Director of Facade and the Construction Tech Specialist, BES Consultants, Rajan Govind.
Good morning to all of you. Thank you for Zak and all the sponsors. Thanks for giving the opportunity to present this. This session I'd like to share basically experience on Mumbai trends, the projects we have worked and lessons learned, and most importantly, some cost insights. So as everybody's keen to know the cost, so we have just like to share some of our experience on a costing. So just a small introduction about BES. We work very deeply involved on any projects. We are on the site, we are on the ground. From design to ground, we support the project. Whatever we show is we work very deep on those projects. Yeah, so this is the key overview we can expect to gain some knowledge from this session. Design challenges, So Mumbai has specific design challenges in addition to general design criteria and high-rise some built reference, experience, as I said before, and current trends and some cost insights. Design trends, as everybody knows from architects or facade contractor, we all busy for last maybe about 10 years seeing various types of buildings, high-rise, super tall buildings, about over 300-meter tall buildings, and various segments. The building we have a different spec, a premium, ultra premium, luxury, various categories for Mumbai market. And the building has doors, windows, some curtain walls, some cladding, glazing, or there's a wide range of, but everything comes under either doors, windows, curtain wall, or facades. Yeah. So the system will have, as I said, either a mix of everything, or you have just purely a window system, or you have just a glass building like a typical commercial building. There's also a trend in some of the high-rises using like a commercial building concept, all 360-degree facades. So what we look from inside is different. So what we look from inside, you have a variety of different configuration. There is no limit. So unlike for other furnitures or interiors, you have a standard system. So there's no standard here. And architects come with a different idea, different modulation, and there is a requirement from marketing, sales. So each project is different. So that makes challenges to design, maybe that also sometimes becoming challenge to a contractor. We cannot unfortunately standardize. So the Mumbai challenges we face as typical to any facade design, but in addition to there are some specific challenges to Mumbai where wide segments, there's a huge variety of different market, different segments. The projects we do in South Mumbai is different. Project in outskirts are different spec. And we also have a huge challenge on local norms. So everybody work in this market, we often hear only two things, sunshade, chaja, FSI. There's only two things we always deal with it. So that's bring a lot of challenges to Mumbai. Openings, a different requirement from customer. We want a small opening, big opening, want full height sliding, off sliding. There's a huge variety of requirements. And site challenges. And we also deal with the construction quality. So the problems are unfortunately passed on to the facade contractors because the building problems. So that facade contractor has to deal with it. A very quick clip, we can understand the impact of the Mumbai rain and wind-driven rain. So you can see the pictures, we have a rain of as high as like 253 millimeter, but it happens in 24 hours. So there's a huge lot of rainwater, and it comes with a combination of wind speeds. So that's the only problem in here is you have a wind-driven rain. Wind is meaning like we have about 20 meter per second wind, which is very high when it drives to facade. Even the typical facade is works very well. You don't never see any problem. Whenever we face slightly high rain, mostly all the southwest, west facade, anything facade facing on the rain, it will get water. So that's a problem with the quality, not just a facade quality, construction. So we have to deal with the construction issues. So this happens every year. So every year we have a complaint of building leaking on that particular month and many times. So there is a solution. It is just we have to push the performances of the facades. So there is a solution. So this have a wide range. So it's put too much challenges on contractors, designers, and architects. So you have a more option means more issues. Fixed openable 2-panel, 3-panel, bigger bedroom, smaller bedroom, living room. So we have to go with various. So somebody will say residential facade is simple, but commercial facade is more simple because you have a standard solutions. And what we deal with is two things in Mumbai norms is sunshade and the floor line. What do you measure from the floor line? So everybody want to maximize the floor line. So contractor or like a designer, we hardly get a space to mount something. So we need to fix something to somewhere. And we need to have the decent space so there's no compromise. So we have to fight with that small space to fix the windows as small as possible. detailing, design changes with the detailings. When you have a different facade, mix of railing, sliding door, everything is tried to integrate. So as like a smartphone industry, we try to integrate everything. So sometimes it works, sometimes maybe lesson learned from maybe you should have not done this way. So just fighting for that small space where we can fix a window, because the FSI all measured up to the glass, up to the building line, so we don't get a space to put a railing, and they give only 150, we ask for a 200, so how do we deal with that small space without compromising design, safety, whatsoever? So there is a solution, but the solution cannot compromise on something else. So we can fix a railing on the top, bottom, below, inside, outside. There are so many ways it can be detailed without compromising. And sometimes the client puts so much of pressure, you put inside, I only give 100 mm, but then again, we cannot compromise on basic things, just cleaning the facade. It will work maybe in paper, but it cannot be cleaned. So we have seen so many challenges, pressure from the client. You put everything inside, but we strongly deny, because we said it doesn't work. Where do we clean this? And we can't give any solution which is open to misuse. Some creative idea come back, you give that railing is removable, fixable, all things. So as we have a strong design philosophy, we don't support anything can be misused. So careful about the size of opening. There are always a limitation on the opening size. What you see in the paper catalog is different, and how do we apply to the project? There are always a huge factor of safety, what you see in the design. So we can't just go with the catalog. It is showing 50 kg, my sash is only 10 kg, I have 4 times factor of safety. The factor of safety is drastically degraded when we go up on the implementation. So mindful about the openings, residential opening. We have seen a lot of projects, they go very wide opening. It's fine, you can do that, but take care of your hardware. So we have also seen many times every year, whenever we have a peak monsoon, we see this in the news, something is fallen off, so we don't want this in the building. And it is not everything the same. The small hardware work for a small application, it doesn't work for your application. So just don't go by the catalog, what they mention. The drastically is getting damaged with the poor fixing, is not fixed properly. So this is also things we have faced with the challenges, is ultimately the poor facade contractor has to deal with it. When they are not getting the right openings, good quality of openings, they can't do this, because this window these days, everything is prefabricated, factory finished. They can't do these windows for every single dimension changes. So these all need to be addressed on the construction level. So the quality of construction, they have to give certain, the contractor has a right to work with some tolerances, and the window has some allowance for tolerance. You can put a flashing, you can adjust, but you can't have like a 50 mm bearing, and there's a window where we don't have to even test it. Any water just puts in, assuming this building has no cladding. So it's directly exposed to weather. So whatever the contractor is going to seal, flashing, everything, it will just seal, leak from the substrate. So how the contractor is going to seal with this condition is just putting like a face mask of the sealant. It's not going to work. So maybe visually we can see it's going to work, but after one monsoon, it is going to break and tear. So there is an issue with the construction quality, which ultimately pass to the contractor. Either they have to rectify or improve the tolerances. So there are projects we will run through the experience on the projects as built reference. Lodha Parks, one of the high-rise buildings, 77 stories, 6 towers, used wide variety of everything on this project. Windows, curtain wall, glazing, fence, there are so many things on this building. Every building is different. There's a building start with typical windows of a small windows, curtain wall, and there's a strip glazing. So architecturally, every building is different. It is not just a replica of 1 tower to 6 towers. And the towers, some of the towers is finished with a paint finish. So our experience in this building is very large projects. So almost every contractor in India, maybe all the top 5 contractors worked on this project. Window sizes are big, and it has a lot of fins. And it has a lot of openings with a side hung opening. So it's just breaking away a typical Mumbai requirements of a sliding door. There's no sliding door here. So this project is completely different from the current trends. So we did one small thing as a innovative things on this project is passive vent. So there is a natural ventilator attached to the curtain wall. And you can see there's a vent concept. Widely used in Europe, maybe Russell knows very well. So it is Indianized version of this vent. So Indianized, we want everything cheap, low cost, so it's Indianized, but it still works. It's been tested, it is working. So it gives a brace off, you don't have to open the windows without compromising on a high-rise building problem with when you open the windows, too much wind is coming. So it's one of the good approach. Other building is different, looks like a commercial building. All sides are facades, even the corners has a curved glazing. This is totally different approach. It's never gone into standard Mumbai approach. These projects we have used a lot of openings. That time there's also CFO requirements. You need to have so much of openings. So it has, in addition to standard opening, we have a side hung opening we call CFO vents or is for fire evacuations. And the buildings, all buildings, corners are curved glazing. So there's a challenges to make the curved glazing. So it's done about 7-8 years before. So that time curved glazing is nobody has the machines to bend the profiles. So what we have seen is a picture, a clip on the side is, it just pop out a parallel windows. The whole project is used this parallel windows. And we have just integrated with the push bars. So parallel window, this is about 1500 quite wide window. You need to catch this both sides, so we need to use with the push bar system. So this is how it works. Close it. So another project is used a mix of windows and paint finish is slightly in different part of the city. The specification is different and the design is different. But he has gone to a very simple system of a side-hung window. Again, this is not a typical system of sliding door. We have everything is side-hung window. You have a punched window, paint finish, very simple system, easy to install. There's not much issue with the weatherproofing. Window with a side-hung. So if you see most of the international projects in Singapore is all preferable with a side-hung because they don't like too much of opening. So when you have a side-hung, the system get very simple. Standard window, easy to implement, the hardwares are simple and it's much more easier than dealing with a sliding door. Of course, it's market driven. Some client feedback is they don't like this, so the customer requirement is they want a full height sliding. So it depends on the market. Another project is called Bhavana, which used whole building is wrapped with cladding and windows. So there's no exposed concrete, no exposed paint finish. The whole building is with cladding. You can see a lot of fins, windows, the fin sunshade. The sunshade is not standard straight sunshade, it's tapering. So the lesson learned is basically time and money. So architect, clients, anybody sitting here, they can see anything building, especially they want to wrap the sunshade is highly complex. And it takes so much of time. Even though client is willing to spend in budget, but keep that in mind, takes so much of time. Every grid they have to install manually. This frames is getting installed 50-story building. All the work's done outside. You're not doing it from inside. You need to have a mast climber. Even gondola doesn't work. So you need to have a mast climber. There's a slow process. You need to fix this bracket and this panel. So much work. Ultimately, it is getting done with this. But it's a process. So it costs time and money, especially if you are wrapping any sunshades. Another project, Rustomji, done by Aloplex contractor or sponsor, is use extra sliding door. So this is totally different project. We have a 7-meter sliding door within the curtain wall. When we are designing, we even discuss with the client, are we really serious? Then usually they come in value engineering, no, you don't change this. The client say from the beginning, we want this design. So it is very large curtain wall integrated into the building. All the beams are finished with the spandrel. So this current trend of little bit of some project is doing, you put the curtain wall outside the building and takes like a curtain wall. So this is following this building. So this one video clip is showing, this whole thing is done almost like a 7 meter wide. Is one of the testing thing, but I think I don't have a latest picture. The building is almost 2 towers, is nearly finished. And this 7 meter entire panel they have done in a site installation as a single unit. So we have a spandrel band, and there's another spandrel band. This is whole thing as a one unit without the shutters. They have transported as a one unit 7 meter by about 3 meter without the shutters. Quite challenging. And have a railing inside. Another project called Artesia has approached with a mix of many things here. We have a curtain wall, windows, and one special thing about is the curtain wall is integrated within the, the sliding door integrated within the curtain wall. So what you see is something like this. So it's like a typical commercial building concept. You have a curtain wall, sliding door placed inside. It is not post-fixed, you create an opening. Is fixed inside and comes to the side, so they can get slightly integrated. I don't say it's fully integrated because you still see the picture frame and some detail, but better integrated. You don't see a lot of double frame, and it's been installed on the, especially all the corner curtain wall has this, and it's been tested. The panel challenge is quite big panel, so you have about 3.2 meter panel by about 3.8 meter panel height. So they're getting the performance here. This all tested like 450 Pascal wind pressure, or water test. So 450 Pascal for water test is very high. So the profiles are big. The details you will see is big. So the last few slides I will come to the cost part. So there are various designs you can do based on current trend is you do a conventional approach, just the standard mass project approach. Then maybe it's a good numbers for architect or client to understand. Because everybody work on a built-up area. That's why we put the numbers in built-up area, not in a facade area. So you can directly see the numbers. So from sales point of view, the developers always see the sellable area. So just for convenience, we put this on a built-up area. And this type of a system, approximately, we have done some detail here. Maybe you take a combination of 3-bedroom, 4-bedroom house, you will have the approximate area. So you are spending about, as per Mumbai, this is the cost in Mumbai, about 400 rupees if you are going with this for facades. So you have another approach is little bit, the trend is you take the curtain wall outside, you have a concrete chajja, everything you are complying to local norms. They're slightly higher, so it's about 491, about 100 rupees higher than the previous scheme. So, and then you have another concept of curtain wall. So you just continue with the curtain wall, there is no concrete chajja or sunshade. Then we are looking about 582 rupees, so slightly higher. So you have a typical approach 400 something, and there is a mid approach 500, and this is close to 600. So if I just put everything here, so you are looking, this is a comparison. So you have various, it is not just limited. We can just run through maybe another 5-6 different options like this. We can put the sliding door, we can put various different ways. It's just a basic. We can have some idea how much it costs. Most of the client asks, they want to have the advantage of taking the curtain wall out, so they'll get a better carpet space. So there is always we've been asked how much it will cost to build this. Yeah. Thank you.
Ladies and gentlemen, what an excellent presentation it was. Of course, supported with a lot of pictures, videos, but we were talking about not just the current trends of the high-rise residential buildings, but he also spoke about the completed projects as well as challenges. So I must say it was a well-rounded presentation. Thank you so much, Rajan Govind, for joining us on that. So well, ladies and gentlemen, it is now time for us to go into our next topic of conversation. High-rise residential facades. Well, that's something, of course, each and every one out here would love to learn. And we're talking about calling upon our next noted speaker, the head of engineering of Shuko India, Kushagra Awasti. Let's give him a big, big round of applause. Thank you.
Good afternoon, everyone. My name is Kushagra Awasti. I am responsible for engineering for Shuko India. Today I'll be speaking about, we have spoken a lot about facades, high-rise facades before. So today I will speak about the fenestration products. That is pretty common in the Indian market. So I will start off with the projects that we were associated with for high-rise, premium and ultra-premium, in the high-rise, premium and the ultra-premium segment. Starting from the north, we are associated with Umbrellas. Then we have Irio, Skyon, Gurgaon Hills, Victory Valley, and then coming a little down to the eastern side, we have 88 East, which we have executed recently. Then coming to the west side, we are already associated with Oberoi, Hirandani, and a couple of other projects which we already saw in the last presentation. Then we have, coming down south, we have association with Maya, Embassy Lake Terrace, Appaswamy, Seabros, One Hyderabad Park, and then Kohinoor, which is in the Hyderabad, Aurobindo Kohinoor. So these are a couple of projects where we have done something special, extra. And that extra we are going to see and talk about today. So we have standard products, standard fenestration products, which is good enough for a mid-rise buildings. But for high-rise, there has to be some extra effort that we need to take while designing the fenestration system. So a couple of them we have already tested also because they were custom designed or a derivative of the mother system that we use. So just to start off with an example, so I will speak about 3 projects here. The first one is Oberoi. In Oberoi, we have executed Sky City, Maxima, and Eternia. The special thing that we did was the integrated sun shading system into the fenestration product itself, along with integrated aluminum railing with mesh provision. So we saw in the last provision how difficult was it to fulfill the requirement of the FSI regulation, plus the performance, what is expected from the high-rise buildings. So here it was designed for 3 kPa interlock section, and then we had to do a third-party laboratory testing and couple of on-site testings also. So since, as I said, there were certain customizations that we had to do for the project, and we tested it thoroughly with the new parameters or the advanced parameters for this project. Then we understood that since the requirement, the performance requirement is really high, we need to have special considerations for design, especially from the wind load perspective. So we enhance the system overlap in general so that it sustains a higher pressure. This is one of the sectional detail where all the integration has happened. So whatever I spoke about is all in there. So the water requirement, the air requirement, the sun shading requirement, the integrated railing, so everything fits into that particular functional zone. So that's the engineering we are talking about. Little complicated because it was aluminum railings were required, not the glass railings. So the design stability, because we had to test the aluminum railing also. So we had to make a couple of new provisions into the existing section which was available to us. Then this is 27 Summit, which is in Bangalore. Really nice project, premium, ultra premium project, I would say. Here, the special thing is we have like a duplex apartments. All the apartments are like duplex. So there is a facade also, the curtain wall, and we had to integrate the facade, integrate the sliders and the openables into the facade element. Not so challenging, but here the requirement was it should not stand out. So the facade section and then the openable or the sliding section cannot be overlapped onto each other. It has to be a seamless transition. So the curtain wall was designed with keeping in mind that the shutters has to interlock in it. Okay, so it was a seamless integration. So what you see on the picture on the right side, in that picture, the left side is with the openable, the right side is with the fixed part. Then in this project itself, we also had the requirement of providing railings. Okay, not a big deal. again, but glass railing, and then we also wanted to have a mesh provision. So this was something challenging because the railing will come on the inside, and integrating with the mesh is actually troublesome a little from design perspective, but we managed to do so. The consultant was very keen on designing with a very high performance criteria, especially from the structural side. Bangalore is not so a wind tide zone, I would say, hardly like 1.2 kPa and 1.6 kPa, but the criteria for the structural design was kept really high. So I'm talking from the perspective of wind load and the live load combination. We will see a little more in detail going further. Another aspect in this project was the pocket sliding door. So all the units were exactly on the brim of the facade, okay? And here the challenge was to have a good water tightness on the periphery of the building. Since the slider is sitting exactly at the edge, it was really difficult for us to think from a perspective like how do we close from air and water perspective the units which is on the periphery, since it was a pocket sliding door. So we managed to do the same with a good performance. Govind sir was talking about 300 to 450 Pascal is a good and a high requirement. So here is the project where we have done the same thing. All the periphery units had a really high water tightness. And then another aspect in the same project was the architectural fins. So these architectural fins had to be combined in the unit itself. Since I said the unit is on the aperture is exactly on the facade line. So all the architectural elements also had to be incorporated. So a lot of design challenges we had, lot of work we had to do, but it came out pretty well. So this is one of the example where I will little speak about the structural challenge that we had. So you see it is a 2-track system with an integrated railing. Here the question that the question that we solved from the consultant was the deflection criteria, live deflection combined with the wind load deflection. So the center shutter that you see, if wind is blowing, then it will deflect. It will deflect. It will deflect on the inside because it's coming perpendicular to the surface of the slider. Now, in the same time, we had to consider the live load deflection from the inside on the glass railing. So the gap that you see of 22 millimeter is primarily because we had to accommodate the live loading from the inside and then the wind loading on the shutter which is coming. And then also the deflection should be maintained so much that there should be at least 5 millimeter gap when both the loads are, load combination is happening. So this also gave us a good gap between the two glasses. So the cleaning problem, what Govind sir was mentioning, the challenge that happens when the railing is there. So that problem got solved here because of that. Then the third project, which I will speak a little about, is the One Hyderabad Park in Hyderabad. Here the challenge was the same sliding system had to be integrated into a real-time facade. Real-time facade, when I say it is a unitized facade. So it was a floor-to-floor configuration, and we integrated the sliding system into that. This is the bottom part that you see on the right side. This is approximately 600 millimeter, which is really high. So this, we will see a little more in detail later. The sliding system is sitting exactly onto the facade unit. So here also we did the same integration. There was a seamless integration done in design where the outer frame was part of the facade system itself. So the facade profile was designed in such a way that it can accommodate the sliding shutters into it. What also we did special here was it had integrated gutter system. You can see on the right side. So the gutter system is also integrated into the facade design, I would say, or a slider design, whatever you want to call. Then one more special thing that we did here was this 10 mm interlock. This is something which is really interesting because we had to do a structurally glazed sliding shutter. So in general, you have a frame all around a glass for a sliding unit, but here we structurally bonded the glass onto the shutter system, and then we made the interlock only 10 millimeter. It's just half of this, not even half of the finger. We also gave a mesh provision in this, so everything, whatever challenges anyone can think of in designing a sliding system, we had already addressed in this project. Now, since in the last presentation you saw the issues, so the story was built up by Govindji, which I'm taking it further. So what we do at Shuko, and how do we address these challenges that comes from the developers and the consultants? It's the same kind of approach what we do for Façade. We have certain challenges from the architectural side, so we get the architectural intent. We know what typologies we have to offer there, what should be the face width, how small it should look like, now what is the depth available to us to design the system for, what should be the element thickness, what should be the glass thickness. So all those things we already know from the design intent, and we see that what special thing we can do in this project when it is a high-rise. I'm not talking about the mid-rise or low-rise building, we are talking about high-rise. So there has to be some special consideration done for this kind of fenestration product. Then, from the consultant side, we get the specifications, and we know that wind load is high because it's a high-rise residential. So we have a definite live load criteria. We have a deflection criteria, which is not as per the code most of the time. So there is always a special deflection criteria given to us. Then, if it is a testing has to be done, of course, it has to be in a closed condition. So open condition check is something which we do specially for high-rise residentials, and that is something which I will come to later. We also have to give due diligence to the air permeability and water tightness, and plus the torsional buckling of the profile section, because everyone wants slim, so slim things never comes easy. So there is a slenderness ratio that is involved, and we have to address that. Couple of projects we have also come across where we have acoustics requirement, thermal or cyclic, and RC class requirements. The third, again, kind of architectural intent, I would say, is the custom integration that we are talking about, where we get requirements to integrate railings, a couple of times facade integration that you already saw. Then a few projects we need to give some night ventilation. Then certain different kind of wall attachment, because the civil opening is not fine, so we have to be prepared from a design perspective how to address those issues. Couple of architectural elements also come into picture. And then at the last, the safety elements. Safety elements in the sense this is completely specific to a high-rise residential we are talking about, where we have to be very careful from a safety perspective. We already saw in the last presentation there was a fallout, window fallout, so it was blown out, broken, shattered, glasses shattered. So how do we address to those issues? Because this is something which is a real-time problem. So in order to that was the listing for the design considerations that we give. Now I'll quickly run into the special considerations that we do. Okay, so we saw that 300, 450 Pascal is something which is normal, right, or a high requirement. Now we are talking about at Shuko, where we have gone up to 1000 Pascal. And this is something which we have recently done. So I will start off from 600 Pascal and build up the story for the 1000 Pascal. So this is a design that we have already executed in a project here in Mumbai, on the left side and on the right side. Both are from the same project. This is with Chhaja profile, and that is without a Chhaja profile. This is how we solve the problem for 600 Pascal. So now this is a dry area I'm talking about, not the wet area, because it is already exposed, so the water will go out. So in the dry area, we are utilizing the chambers. So the chambers are designed in such a way so that it contains the water. Okay, so 600 Pascal is equivalent to certain head of height of water. So this is how we utilize the chamber itself and route the water through a controlled drainage from the system. The first one is with a ball wall design, the second one is with the NRV design. Now coming to the 1000 Pascal design. What special we need to do? 1000 Pascal is really high for a fenestration product. Facade, still okay. We can do it, we can solve, because it's a completely gasket-based system. This is a design for 1000 Pascal water tightness with a 2-track system, and we are utilizing the chambers. Now the chambers are designed in such a way that it contains enough water to counter this 1000 Pascal. Just to show you an example, this is the life-size sample I'm talking about. This is a 1000 Pascal. Okay, this is a 3-track system. Looks crazy design, but this is something which is working. We have already done an internal testing for 1,000 pascals, and a third-party testing is also done parallelly in Japan, and we are confident that we will pass. So this is the size that we are talking about for 1,000 pascal, okay? Next challenge, higher wind load. 3 kPa, 3.5 kPa is something which is common for the weather condition, but we are not so sure what is going to happen in the future, so we have to be prepared for it. So we at Shuko, we have designed system where we can go up to 5.2 kPa as a design wind pressure with a L over 200 deflection criteria, not L over 175 as per ASTM. So this is class B as per EN. This is what we have done. So it is again with a slim 37 mm face width I'm talking about, and the interlock is something that we have really worked on and developed the system. 5.2 kPa design wind pressure, L over 200 deflection criteria. So this is already solved, tested. Third thing I would like to speak about for high-rise residential special considerations is system overlap and the open condition check that we do at Shuko. Not everyone is asking to do so, but we at Shuko are a little concerned about the safety of the products going further. Then what we do is just to understand from what wind pressure, how actually it works. So when the wind is acting, so we have a trapezoidal and a triangular kind of a loading, okay? So this is a triangular loading. When triangular loading happens in the areas where the width is lesser than the height, okay? So in the height part, when the height part is more, you will have a trapezoidal loading. So when you're designing the center interlock, you will have loading 2 trapezoidal loadings onto both the sides of it. So this is how the wind acts on the different parts of the fenestration system. So close condition check is possible to do because there are standards, codes, and you can do a test on in a laboratory. What you need to do for an open condition check? This is something which is completely new for the industry. Many of them, they don't understand the concept, so I just wanted to introduce this concept a little. There is no standard or code available, but we have some considerations that we do at Shuko. So open condition is like the shutters are still closed. It is not physically locked, but when the wind is acting, so we are considering only one side of the loading onto the shutter, not in the interlock section that you saw, both side loading. So we will consider only one side of loading. We will ensure that the shutter doesn't pop out. So that's the main aim behind it. So deflection is not a criteria because deflection is only for the closed condition check, but in open condition check, deflection is not a criteria, stress is the criteria. So we make sure that the system, here it is deflecting 111 millimeters, so deflection, as I said, is not a criteria. The main aim is the shutter should not pop. So what we did was we introduced a kind of a mechanism, a mechanical component like a profile, where we are able to increase the system overlap. So the first one that you see is only with the 8 mm overlap. There is no physical a profile which is increasing that engagement. The second one is with a certain profile on the top where we are able to increase the engagement to 18 millimeters. Then the second generation profile we developed, and that we developed through various experiences we got during the testings. So roughly around 25 testings we have done in the past 2 to 3 years, I would say, and we have seen that this 18 mm is really sufficient for a really high wind load condition. So 5.2 kPa that we saw earlier was also designed with this kind of a system. Now, the latest third generation profile enhancement that we have already done and tested is by increasing a little further to 20 millimeter. So this is the maximum that we can go, and we saw that approximately till 10 degrees, if the shutter is bending, we are still able to prevent that pop out. Okay, so this gives an additional edge, and this is the extra thing that we do at Shuko to make sure, since it is not required by any project requirements or standards or protocol, but we make sure that we are doing the right thing for the project. We will quickly see this, since the time is running out, we will quickly see the integrated railing systems. There are different kinds of railing systems we have available at Shuko. So this is something which is already integrated into the interlock itself and then onto the outer frame. And this side, no mesh can be given because there is already a projection. In this system, which you saw again at Oberoi, here the same integration is done with a mesh provision inside it. Aluminum railings are used here. In the previous one, it was glass railing. The third is, again, a railing system where majorly for a wide configuration, without a mid post. So there is no, since it's a two-track, two-shutter system with a meeting style, so the wide opening is there, and we were able to provide a solution without a mid post. So when you open, you get a clear view, so there is no mid post there. Then we have a system solution. This you saw earlier also, where we were able to give a special consideration for the different load combinations. So this is completely concealed in the outer frame, but it will come with a mid post. This is one railing system where the shutter, the mullion profile of the shutter has the capability to hold the glass in itself, and we can still use a mesh system in this. So it is completely concealed, no additional attachments for the railing. So in the system itself is capable of taking the glass railing. The last one which we'll see is the wall attachment and the integration. Here I will speak about the Hyderabad project, and I can show you how we were able to integrate the sliding system into the facade configuration. So you see this is basically a sill gutter, facade gutter, where we were able to manage the sliding outer frame seamlessly designed with the facade system. So this is something which is very special to us. This also has a integrated gutter system, two types of gutter system we have developed for this particular project. With this 10 mm interlock that you see here, this is the interlock that I was talking about, and then a provision for the mesh also integrated. So this makes it really wide, 600 millimeter. Really beautiful product, I would say. Also capable of taking the deflection of the slab because of the special expansion joint that we have in the top. So this is one of the sectional view, just to show you how things are arranged. So it is basically one facade panel here, the other facade panel there. So the installation is just like that. Since it was a floor-to-floor configuration, one fixed facade will come, then the sliding outer frame facade will come, and then again a fixed facade will come. And all the three units are connected via the same gutter system. So the same gutter profile will come, and all the three units will come and sit on it. Right. So the last part, the additional accessories. So this is from a safety perspective, I would say. Everything related, whatever you saw was from completely a design from a profile. So aluminum, we played around with aluminum, satisfied the design criteria, the performance criteria, the deflection criteria, and so on. This is something which, again, now is not regulated by the code, but the NBC also 2016 was talking about it. The new version 2023 version is forcing us to take this as an action by the code. So we at Shuko, we have developed these accessories, and we make sure that we are complying to the codes that will come in the future. So this is one example clicked by my colleague during a cyclone Varda in 2019, and the shutter was blown out. So the problem was the shutter will blow, but we have to still hold it. We should not fall down from the top of the building. So this is something that we have developed recently at Shuko. This is a safety catch, which actually holds the shutter in its position. We have done a couple of testings for it, which I will just show you. So this is the aluminum absorber. This is the vent frame connection. This is the steel wire, and that's the outer frame connection. There's something which is not new, I would say, for the market. There are other companies who offer this kind of a accessory, but what we have done at Shuko is the testing. for it. So as I said, there is no parameter for the testing criteria for this. So we had some considerations and we did the testing. So the most important thing that we considered during the testing was the impact load, the dynamic wind load, and the sustained loading or the creep effect that we speak about. So just quickly, I will show you a video. So this is the UTM testing of the steel. This is the drop test that we did.
380 kgs. Start!
So this is the drop test or the impact test that I was talking about. And then we left the shutter for 48 hours after that. So that, 48 hours, by 48 hours, because once the cyclone is gone, when the shutter has dropped down, so we will give at least 2 days for the team to come and take action on it. So that's why 48 hours testing we have done. As I said, there is no code available. That's only our consideration. So this is the pressure blast out slam test that we have done at Windwall. So this is depicting a real life scenario, what can happen. And again, the shutter was left for 48 hours. And then the last dynamic wind load testing with an aircraft propeller we did. So it was, this test was continued for 2 hours. So this dynamic wind load condition we did for 2 hours just to simulate, real-time scenario if wind is acting and the sway will be higher. So it should not break the other glasses on the other side of the facade. So this is something which I'm sorry, I'm running out of time, but quickly to see, this is something which we have developed recently at Shuko. This is called as an engagement catch. This is designed for openable systems where there is no mechanical locking happening. So the shutter is open, wind is blowing, and nobody is there to close the shutter when the wind is blowing. So automatically, there is nothing like, a drive or anything is there that it will sense the wind and then the shutter will close. It's a mechanical system. So when the wind is acting, the pressure will come and the shutter will close. So this is how actually it works. Just a quick video to show. So this is a movable part, the brass pin, which actually engages. This moves along with when the handle is rotated, and there is a safety pin onto the vent profile. So this vent profile, when it is closing, it will automatically come and it will lock to the this brass component there. So this is what I was talking about. The shutter comes, it closes, and then in order to release it, what we need to do is, so the shutter is closed now. You cannot open it. So it's a single point locking automatically happening. So you need to just rotate the handle, it disengages. That is why the spring movement was there, so that it disengages, and then you lock it back again, and it works fine. So couple of tests again we have done, and we saw that till 600 Pascal, one engagement catch is sufficient. So why 600 Pascal? So say what, like 3 kPa is the design wind pressure for a project. So 20% of the design wind pressure is something this accessory should start working. So 600 Pascal is basically the 20% of the 3 kPa. So we did a couple of tests and we found that till 1.5 kPa, it works pretty well with 2 engagement catch. And this particular component failed at 2 kPa. So that's all from my side. So I want to say that we at Shuko, we have a really good engineering team, really competitive engineering team, and we are capable of handling any complex jobs, any challenges that is given to us, which a couple of things I showed you today. So please feel free to speak to us. We are at the booth here to, if you have any questions or doubts for these projects. Thank you.
Thank you. Sure. Thank you so much. Thank you, sir. Thank you. With the length and breadth of their clients, I must say it speaks a volume of the excellence they've achieved. Let's once again give a big round of applause to our gentleman out here, Mr. Awasti. Well, now I'd like to bring to your attention a keynote speaker who's joined us all the way from Hong Kong. Ladies and gentlemen, we're talking about a very interesting topic, building without building. I'm not going to emphasize anything further on that because we have with us Gregory Kovacs, Design Director of Benoy, joining us. Let's give Gregory a warm round of applause. Thank you, Gregory.
Thank you, thank you. So thank you so much for having me. Very nice to meet all of you. I really love this city of Bombay, so I'm so happy to have this discussion with you guys. So today I want to talk about something that might not be the most obvious thing for Bombay, but I would like to make a case for repurposing where is possible and to be consider this as an option more often than what we do. So in order to meet our greenhouse targets, we have to change quite a lot. And when I grew up, I understood architects as being the good guys, the guys who are solving the problems. And in the past few years, it turns out that we are the problem. So what can we do? So when you look at the global emissions, our industry, all of us here, we are actually producing a very significant chunk of it. And so far, much of the discussion about carbon emission has very much been about the operational carbon. It's trying to make our buildings more efficient. But in reality, when you look at these charts, the orange is the embodied carbon. That's actually a much bigger problem, and it's much more difficult to tackle than the operational carbon. We have made quite a good progress over the past decade on the gray part, but in the next years, we have to start focusing on the orange parts, because without that, we cannot meet those targets that I was showing you at the beginning. So if you want to do a carbon neutral future and a carbon neutral building, it's very, very difficult to do that if you don't reduce the embodied carbon. And the easiest way to reduce that embodied carbon is actually to reuse existing buildings, to reuse the existing structure. Now, India and Bombay is an emerging nation. We need to build a lot of new structures here, no questions. But there is an opportunity for recycling some of the existing buildings. And I think sometimes we tend to value the land too much here, and we, by default, go to the option of demolishing and building new. So these are just a couple of shopping malls around the city. And there's an amazing opportunity to upgrade many of these assets into something that can, again, be more inviting to the public, especially in a city where there's not that much public space. These shopping malls are not simply just spaces for buying and selling. They are really important spaces for the public where people can actually meet. So one of the really interesting statistics for the future is that even though we are building a lot of new buildings, if you look out your window today, and if you look out your window in 2050, the majority of the buildings will be there. So in 2050, the majority of the buildings that we will have to live in and work in will be old buildings. And really the question is, what can you do with them? How can we move into a future where there will be a lot more engagement with these old buildings, a lot more repurposing of these old buildings to bring them up to the standards of the day. So living and working in old buildings, it doesn't mean that you have to lower your standards. The question is how we can take these old structures and bring them up to the standards of the day or the tomorrow. So really, in other ways, in other words, the question is how you can change these buildings without really changing them. So I want to show you a couple of examples from our recent projects of what we have been doing across Asia. So this is a structure that we inherited in mainland China, in notorious Wuhan. This was the original design by other architects that we turned into this. This is another structure we inherited. No one wanted to finish this. This was standing in the middle of Chongqing for 10 years like this. And the question was, do you demolish this or what can you do with this? So this was the original design. that we turned into this. We are just opening this, this development this year. Another project in mainland China, an old shopping mall, very similar to the ones that I was showing, that we are upgrading into this, creating an outdoor street on the facade that can be open when the shopping mall is closed. This is Singapore, Holland Village, that we are upgrading into this. Another structure in the mountains of Chongqing, a hotel. This is the structure that we inherited. This was the original design in the UNESCO heritage area that we are upgrading into this. Another project we are currently working on, upgrading this into this. A project from not too far from here in Ahmedabad. This was the original design that we turned into, kind of broke down the volumes, and we turned into this. A power station, an industrial building transformed into cultural and commercial functions in Shanghai, turning this into this. Or this is a project that I was just a week ago in Hanoi for the opening. So this was the original design before us that we turned into this. It's a shopping mall with a series of terraces that opening onto the surroundings. So at nighttime, when the weather is good, people can actually sit outside. And one of our recent projects in Singapore that we are upgrading into this. So these are just a couple of examples to show you the transformational power of facades. And I really believe that there's a lot we can do with that. And all of these projects, the common theme in them is that they are all retaining all of that concrete structure with that very significant embodied carbon inside of them. So what kind of future do we have here in India? What is it? This is an amazing emerging superpower. And I think the opportunity here is that we can learn quite a lot from our neighbors, especially from mainland China. What are the things that we can learn from them as kind of the mistakes that we don't want to repeat here, and what are the good things? So look at this view. Can anyone guess where this city is? Any guesses? No? Not too far. So this is Shenzhen, but the point is that this could be just as well in the US, it could be in the Middle East, it could be in Asia, it could be in Australia, it could be anywhere. And the problem with these generic developments is that, first of all, I mean, you see all of these glass towers. They are ignoring a lot of the environmental realities, and they are also creating very generic neighborhoods that people don't really feel like is theirs. It really could be anywhere. So how could we build a future in India that is somehow more Indian, that is somehow it couldn't be anywhere, it couldn't be in New York? And our answer to this is to consider sustainability more holistically. So far I've been talking a lot about environmental sustainability, but we believe that there's much more to it. To look at not just environmental, but economic and social sustainability. So I will show you a couple of projects in more detail of how we do that, and I hope that these can be some kind of examples of how we can build a different future for India. So this is a project in Singapore. It's already under construction, and the interesting thing about it is that one half of the development is old heritage shop houses. The other half of the development, same client, is this quite ugly podium and an old office tower in the middle of it. So how can you create something that brings these two completely different parts together? How you can create a facade and the language that mediates between these two different parts? So these are the old shop houses. One of the key things that we did, and it's outside of the facade, is to create a circulation that combines all of these different parts together, binds them together into one coherent development. Creating a journey from the metro all the way to those old shop houses. But really the main problem is this facade. What can you do with this? And so number one thing that we started is the scale of it. So can you borrow the scale of the old shop houses and apply them onto this large podium? Using the columns that are exposed on the facade to bring that kind of human scale onto this large podium. To do something like this and to create a completely new experience for the arrival into the office tower. To create a new address for this development, because here the office tower is actually one of the most valuable parts of the scheme. And then moving on to the office tower, how we can improve the slightly kind of grade B qualities of the space. So at the beginning of the day, John was showing his views and his building with the parapet wall, and how that doesn't really bring much light into the space when you have a glazed parapet. So I think that's absolutely true, but there is a psychological aspect to it. So when you start taking the parapet panels out, what we did here, the whole building feels a lot more open, and psychologically, it actually adds quite a lot to our tenants. And we managed to take these panels out. You see on the left the before and the after images. And we managed to turn this whole office into a grade A office without very significant changes. So even the glass panel that you see on the facade, that is the existing glass panel. We just removed the internal solid parapet wall. We did the same thing in the common spaces. So this is the lift lobby upgraded, the main office lobby upgraded, and then the typical office lift lobbies on each floor. So the next facade that next project that I wanted to show you is more about belonging. Is how we can create a sense of belonging where these developments are becoming a community center. So this is the project I was showing you earlier in Wuhan. And our challenge was that we inherited all of this structure. What can you do with it without demolishing anything? So all we did, you see those steel extensions on the concrete structure. That was the only thing that we changed. We added a couple of these steel extensions to modify the massing of the buildings, but we didn't demolish anything. And the purpose was to create something that relates to the heritage parts of the city, to bring the qualities of that very pedestrian-friendly neighborhood into this new development. So we created this facade that is all about this kind of zigzags, and it's a very flexible system that can allow you to insert an advertisement, a shop front, and it can really accommodate all kinds of different conditions on the facade while still remaining consistent across the whole scheme. And then when you look at the entire development, so this is a kind of a heat map of the different requirements. So this facade can respond to these requirements of the interior spaces and also of the environmental constraints of the building. So there could be parts that are really closed, that you see here on this side, and the other parts could be a lot more opened up. So to do something like this, where you have the FMB units, the facade really opens up, and in other parts, where you don't need, the facade really closes down. And to have this sense of journey across the scheme, a very pedestrian-friendly, community-friendly neighborhood. In these projects, we are using a lot of computational design. The scheme is inherently complicated, and really the challenge is how you can deal with that complexity. So originally we had 35 different facade modules, which we managed to simplify down into 6 different modules, making the whole construction a lot easier and much more affordable. So even though it looks very complex, it's actually only 6 different facade modules. And this is how it looks like. We opened it about a year ago. Also very important for us that from very early stages on, we test out everything in one-to-one. We do print out prototypes of the facades, and we test in VR and augmented reality all of the pieces together with our clients. Looking at materiality very early on, so cost doesn't come as an afterthought when it's already too late. The other thing that we do on these projects is looking at the economic sustainability that I was mentioning, how we can make sure that these projects are performing a long-term for our clients. So this is a pedestrian flow simulation that we very often do on our projects to understand how people would be walking through the spaces, especially when we are working on retail, to make sure that every single shop is getting sufficient footfall. Every shop window is getting sufficient views across the scheme. And what happens if you rotate the escalator by 15 degrees? And then what that actually means for leasing values within this shopping street or shopping mall. So this is some of the views, the key arrival, and this journey through the scheme on multiple levels, really activating all of the floors of this outdoor retail street, even the basement, turning it into something that doesn't feel like a basement. And then you get to the very heart of the development. Working with all kinds of artists to activate the spaces, sometimes local, sometimes international, and putting a series of artworks across the scheme. The next project I wanted to show you is about community. It's a very large-scale project. It's in Seoul, Korea. It's 85 residential towers and a series of community buildings. Again, on this project, all the structure we inherited. It was all built when we started working on the project. And the challenge was that you have 85 of these towers, and they all look exactly the same. What can you do? How can this become more than just a development? How it can actually become a neighborhood? And then all of the buildings were almost like this kind of walls. How you can break this down? So we started with trying to understand the overall urban condition on the site, how this can be broken down into smaller pieces, something that people can engage with. So again, we looked at the pedestrian simulations. How would people actually commute in this large neighborhood? What are the key routes that people would be taking? And then what are the spaces that are actually becoming more busy and more quiet? Looking at the environmental performance of the area, looking at sun shading, what are the spaces that are comfortable and what are the spaces that are less comfortable during the year? And when you put all of this information together, you get this quite interesting detailed diagram of the spaces that are busy and very comfortable. So we could start creating clusters and public spaces around that. So this whole kind of grid of 85 towers is no longer a kind of uniform grid. It actually starts to become a network of nodes. And these network of nodes allows us to start creating mini kind of neighborhoods or mini communities. How you can differentiate between them? We were looking at color. Maybe you can apply different colors to the different buildings, but maybe we can do it in a more interesting way where the colors are gradually blending into each other. So you are in the blue zone, but it kind of gradually becomes the green zone. The next issue was this kind of wallness of the buildings. So they are very long, narrow buildings. What can you do with that? How we can break down these wall-like buildings just using facade, just the facade expression, how can that change the impression of the massing? So trying to break down the buildings into a series of mini towers that feel a lot more slender, using the fenestration around it, the heights of the tower. And then the next step is actually how you can make this whole development feel a lot more human scale. So we made the towers feel more slender, less wall-like, but they are still very tall. Could we have two different kind of facade systems on it? One for the lower part and one for the upper part. So when you are walking around this neighborhood, you would be focusing on the lower part, applying the color to that, and the top part would be something that kind of blends with the sky, and all these towers would actually feel a lot more human scale. And this line between the low and the high rise would undulate across the whole development. So as you are walking through, all of these towers are the same height, but as you are walking through this neighborhood, the whole perception of the space would constantly change. There would be zones that would feel quite low rise, and then we are walking, it actually starts to feel very high rise. And this also gives us the opportunity to use a more special cladding on these zones, on the lower zones, something that we couldn't afford on the entire tower. So here we are looking at terracotta facade panels. That is something that feels very precious. It's very nice to touch, very nice to go close to it. And how this kind of different color scheme create different clusters and different addresses. Now, interestingly, this site is actually at the old Olympic site in Seoul. So these color schemes actually work with the history and the heritage of the site. So this is what it looks like, all of these different color zones together, and some of the views of the different neighborhoods, the arrival into the whole development. So the last project I wanted to show you is trying to engage with the local history and the local culture. And I think that's particularly challenging. It's very difficult to do it in a way that it doesn't become tacky. So this is the project I was showing you in Chongqing. This was the original design that we turned into this. And I just want to walk you through some of the history of this project. So we inherited this structure. In the middle of it, there is this massive central plaza. It's 240 or so meters long. And the client thought it's very important to create big public spaces. But China is actually very different from Mumbai in that sense. Mumbai doesn't have that many public spaces. China tends to have too many public spaces. So when I went on site, I was walking around, and everywhere I went, I just found these massive open public spaces. But the one thing I couldn't find anywhere was actually small spaces. Spaces that you enjoy walking around, like this old village that used to be at the place of this city long time ago. So what we set out is, could we borrow some of the spatial qualities and some of the architectural qualities of these old villages and do something in the middle of this open plaza that would become a streetscape that the whole neighborhood can use and go to and just walk around and enjoy. But of course, do it in a more contemporary way. So we're not trying to build an old fake village. Borrow some of the principles of the village, but do it in a very contemporary way. So these are the houses that we started to create, borrowing some of the aesthetics and the kind of structural logic of the old timber framework houses, by creating a green roofscape on it, and then creating a canopy, roof-like canopy on the very top of it that creates a very comfortable condition, both on the streetscape and also on the roof terraces. And all of it kind of references these stilt houses, these local stilt houses with these long legs, to create a streetscape like this. So on the one hand, it feels very much anchored into the local vernacular, but on the other hand, it actually feels very contemporary. And I think this is something that would have a lot of mileage here as well. We work very closely with the local government because obviously this was outside of the original planning permission to do this street in the middle of the project. But they saw the value of what we were doing and we got planning permission for it. The nice thing about this streetscape is that the local climate is actually quite harsh, and these small buildings really allow that central plaza to be used throughout the whole year in a very comfortable and create a very comfortable outdoor environment, working with the solar angles, trying to capture the cooler winds. and create a streetscape and a couple of indoor gardens connected by this streetscape. Now, looking onto the outside, that the big kind of podium facade, what can we do with that? So that was I was showing you the inside, the retail street. So again, we use the same kind of language, but in a very different way, trying to break this facade down into smaller pieces, working with this kind of grid-like language, but in a much larger scale. And we found this really interesting heritage in this part of China, which is about these puppet shadow theaters. So these are traveling theaters. They would go from one village to the other. And it's a really interesting thing. You have these translucent sheets, and the puppets are behind it. And the further the puppet moves from the surface, the more blurry it becomes. And the closer it is, it becomes more sharp. And it's generally quite black and white. So what we were looking at, could we actually design a facade that does something like this? Having a very simple frosted glass surface on the bottom, and behind it a cheap, low-resolution black and white LED screen. So between these kind of advertisements, all of this zone can be animated and you can create a content on it. And that content can really belong to the local community. It can belong to the owner, and it can really relate to what is happening around, whether there's a festive season or what is happening inside of the shopping mall. So here it shows all of these people, but you can imagine these people kind of moving around and really animating the facade of the mall. So these are a couple of examples of how we can bring these three aspects of sustainability together to do something that feels a lot more anchored and a lot more unique and bespoke to the local culture, the site, and the people who will be using the project. So this is my kind of vision for how we can create a sustainable international metropolis here in Bombay that is unique, and it has a very Indian flavor to it. Thank you so much.
Thank you. Thank you so much. One thing we got to compliment Gregory on his presentation was definitely he inspired us to consider sustainability as a holistic picture. Of course, we'd like to also compliment him on the impeccable designs, what he showcased. So ladies and gentlemen, once again, let's give him a warm, warm round of applause and thank him for his guidance. So up next, we have our first panel discussion at the Zak World of Façades. This panel, of course, is going to be very enlightening in terms of the knowledge you as individuals are seeking today. We're talking about challenges in designing high-rise building with glazed curtain wall. So on that note, as our stage is set, ladies and gentlemen, with a warm round of applause, firstly, if I could have the honor of calling upon our moderator, Regional Director, India, Inhabit Group, Gautam Basim.
Hi, good afternoon. This is what the face between you and lunch looks like, so we'll try and keep it tight. I would start by inviting the co-panelists that I have, and thanks, Zak, for arranging such a stellar panel. We'll start with an industry veteran, architect Kiran Kapadia, founding director of KAPL, who we've all known for decades. A good friend and a stellar architect, Kalvadia from Architect Hafiz Contractor. Another veteran who I don't think needs any introduction. I think I shouldn't be saying anything more than that, Mr. Naveen Keswani. Representing the people who actually make it all possible, for our clients from the developer industry, Akriti Kapoor, Design Head South from K. Rai Jacob. Representation from the project management fraternity, Mr. Jawar Sheikh Mace. And then lastly, from the facade design industry, Vicky Vora, founder and principal, V3 Facade Design Studio. Welcome all. Thank you for letting me do this to start with. Can we have the slideshow? What's up? So before we start the discussion, I think it's important to set the context of what we're going to talk about today. We've been doing curtain wall for donkey years, but it's important to see where we all started. And I think glass has been around on buildings since early 1800s. Float glass from somewhere in the middle 1900s. But I think the first time that we ever saw use of unitizing or unitized curtain wall, that's literally the weapon of choice for most buildings these days, was here, the United Nations headquarters in New York, where the Secretariat building was about 41 floors, and it was really ahead of its time to start exploring unitizing in facades, and literally a landmark by itself. And again, anything and everything UN, all countries fight to put their own architects in the mix. So you have multiple architects, and imagine 7 architects in a room trying to design one project. And we all complain about how many options the client is asking us to do. They ended up doing 37 options of that project, and out of that 23B, which was a mix of 23A and option 32 that got passed. This building was so ahead of its time that at the time where the building it was decided that the building should be reclad in 2015, they took 3 panels. So this is basically the building under construction. So you can see the image on the left. It's all panelized. There's no frames being visible. There's no glass going independently. It's quite an interesting achievement. And in 2015, they decided that the building had aged close to 63 years in service, with the Eastern River, the salinity, and everything else sort of corroding it quite badly. And at that point, when the building was being reclad, they took 3 panels away in their corroded condition, in their real character, and decided to put it in the Museum of Modern Art in New York. So that's the history of curtain wall internationally. I think we started seeing use of glass curtain wall on our shores somewhere in 1982. I think this is the first project that had extensive use of curtain wall, the Meridian in Delhi, which was in Lutyens, Delhi, which was a very different character architecturally. A lot of old buildings, a lot of stone being used with tiny applications of glass, and then suddenly you had this monolith, very interesting form that started coming up with a lot of glass applications. And then I think we have a lot of veterans here on the table who have been involved in some very early glass applications in the city. Now, with that, I think the tone is set, so I'll probably start with the questions, and I think the question really starts from the architect, where the building starts taking shape. And I think either of you, Kiran Bhai, Kakal, free to take this question. How did curtain wall get introduced to your respective practices? I mean, how did you think, like, okay, is pe curtain wall lagate hain?
So good afternoon.
And sorry, as an extension of this question, was it like trend, or was it need, or what was the driver behind the use of curtain wall?
So first and foremost, curtain wall predates me, and the introduction of curtain wall into our practice also predates me. So I won't be able to precisely answer your question, but what I can say is that growing up as a young architect in Mumbai, definitely from what I can recollect, curtain wall came to India as an aspiration rather than a need. And it remained as an aspiration for a very, very long time, until recently, where curtain wall is being seen as a faster method of construction, a more permanent solution to leakage. And of course, there are much more intelligent and sustainable ways to do it. And therefore, I think we are in that stage of Indian buildings where we are moving from curtain wall being an aspiration to curtain wall being a need. And we've also sort of picked up the art along the way, how to do it in a better way than than what was done, say, 20 years ago. So that's my answer.
Very pertinent. Kiran Bhai.
Okay, no, so I agree with what Carl is saying. So, I think, curtain walls started coming into, especially in the residential sector, as aspirational. So I think that's one thing, and then it's moved on to, a more practical way of constructing, faster way of constructing. Also, I think just to do with the, kind of, wet work that goes on to the site, et cetera, et cetera. But I think, we have to evolve a way by which, I think few projects have, how do you kind of localize it to the Indian context? We don't generally have conditioned buildings. Our residential buildings do, even very tall buildings are not centrally air conditioned. Some of them are, but people still like to open their windows. Now, how do you open a window on the 45th floor and things like that? And I think that is part of the kind of learning curve that needs to come in. I think a few experiments have started, which Govind I saw also presented, where one of our projects we've actually done at the park, we've actually done, ventilators that have kind of been incorporated into the frame of the building. I think it's a very effective way of doing things because you have natural kind of wind flows coming in without having to open your windows all the time and things like that. So I think an evolution of, how we can kind of, customize it to the Indian conditions. And I must say that curtain walls are really looked at more in terms of, high-end residential buildings. In the medium end to kind of mass housing, obviously curtain walls do not become affordable. So this, we're talking about the higher end of buildings and things like that, where budgets, etc., should not be that much of a problem. So, and I think it's something to stay. And I think, I think the industry is also evolving, but I think it needs to kind of push it up because I think we're building significantly, big amounts actually, and the industry needs to kind of, keep up with that also.
Yeah, great. That was actually a good segue into my second question, but I'd like to talk to the client first, like we all do. I think KRC has a very strong legacy of curtain wall buildings. I think literally the first curtain wall that we saw, that has the name KRC on it. But I think we've seen a massive transition, as Kiran Bhai said, that a curtain wall was like a default option for doing a commercial building or an office building, but we started seeing the transition coming into hotels, we've seen the transition coming into residential buildings as well. What has really led to that change from a client perspective? How did that inform your brief?
So I think I'll just like to spend a minute on, taking notes from what Kiran sir and Carl obviously mentioned. So initially for offices, of course, it's more to do with the tenant profile that we are working with. Most of our tenants are multinational companies that have offices all over the globe. And as employers, they kind of want all of their employees to have a exact same feeling that some of their colleagues have sitting in the Silicon Valley. So, and Façade, fortunately, is, one of the major contributors of that because a glass building kind of gives them a look and feel of being anywhere in the globe. So that's obviously how it started. Along with the facade, obviously there are other things like amenities and all of that have suddenly become, the need of the hour, and like top-notch things are happening around the country as we speak. But, from basically when we started building offices maybe 15, 20 years ago, the scale that we were working on was very different from the scale that we are working on now. We would, do 5 lakh square foot, 7 lakh, 1 million square foot of building would really be a large building. In the last 10 years, there has really been a paradigm shift. So these days when we are talking about places like Pune and Navi Mumbai, 1 million square foot of development is a very average development across the board. When we are moving to Hyderabad, you're looking at developments that are 3 million, 5 million single building. So it's just become a need, like how Carl mentioned now, from the perspective of you just want to keep the junctions as minimal as possible, you want to keep interventions as minimal as possible. The moment you use, plaster painted facades or punch windows, just as an example, the contractor is coming up and doing the wall, somebody else is doing the plaster, somebody else is doing the paint. So just the number of elements that are coming together, you want to minimize that to minimize the amount of tolerances and, the errors that might come and leakage issues and all of that. So I think it's really really the scale of the building that has contributed a lot to this. Also, when we look at scales that are 3 million, 5 million, we're talking about floor plates at an average that are 40,000 square foot, 50,000. Hyderabad has like floor plates which are 1.5 lakh square foot, you know, single floor. So on these kind of floor plates, from a price point, which is where the real developer in me, you know, comes out, is, you know, the facade area to the floor area starts becoming so minimal that from a price point, that stops becoming an issue. Earlier, just the amount of facade area to floor area was, you know, so much more. So now I think that has become a larger contributor, and we're able to bring down our price points in that sense and kind of decrease the sensitivity over there. Similarly, when it comes to residential, like your question was, homes, of course, like people are doing whatever they want, you know. So, but residential, large-scale residential developments is purely an aspiration at this point of time. They want to live in condominiums that look like Manhattan and, you know, all of that. As a developer, obviously, we are doing both at this point. You know, we are doing an affordable segment, like Kiran sir mentioned, where plaster paint, punch windows is very much, you know, still applicable. The ultra luxury apartments where people are paying, you know, 40 crores, 50 crores kind of numbers, they are located in regions where, like say in Gurgaon, it will be in the middle of a golf course. You know, in Mumbai, it will be right at the seashore. So people just want uninterrupted views, 360-degree, you know, perception of the nature outside, panoramic views. That's just kind of a sale point, and to adhere to that, it just becomes an obvious choice. The unit sizes also kind of increase when you go to ultra luxury segments. So again, like I said, the facade to floor ratio kind of just starts becoming a lot better. So price sensitivity is also not that much. So yes, of course, from an, you know, we still have to deal with issues like Indian context. People still want to look out of the window. They want the sea breeze right into their living room. You know, all of that is obviously fire, for example, is something that will evolve as we evolve, you know, as developers. But at this point, residential, yes, surely it's definitely, according to me, an aspiration of just, you know, taking back from what the desire of living in a high-rise apartment should look like.
So I think it's a varying degrees of aspiration, but more importantly, it's about speed, quality of construction, reducing trade dependence, etc., which I think there's one answer where something gets fabricated off-site and you don't have to do anything on-site, which again is a challenge on high-rise buildings.
It's just like a plug-and-play system, right? So a system facade, it's not necessarily only glass. It could just be granite coming and plugging in a system-based facade.
Right. Going back to the architects, and I'm not talking about history anymore, Carl, you can take this question. How valid is curtain wall as a solution for our climate? I mean, I know there's some aspiration involved where somebody has gone to New York and needs some fancy apartment, or, you know, a person who's worked in a Microsoft office in Seattle comes to Mumbai and wants to work in a very similar kind of environment. But how good an answer is a curtain wall for our climate? And then do users typically end up responding well to a curtain wall being used on their homes or their offices?
So curtain wall is often confused with glass. Curtain wall is basically it's a system of glass, spandrel, all of it put together. And just to put some numbers out there, today almost I would say 90% of all construction in India is happening with formwork, commonly called My1. You know, all our clients out there have very robust engineering teams who keep guiding them that, you know, we can keep reducing the thickness of the external wall to save cost and all of that. And a well-engineered curtain wall has better insulation properties than an external RCC wall. So we as a country haven't seen in the next 10-15 years how uncomfortable our residents are going to be living in these My1 buildings. Because we start making the windows smaller and smaller, saying that glass is more expensive than concrete. And the walls are getting thinner and thinner. And once the heat gets in, there's no way for the heat to get out. So that story has not yet played itself out. So I think curtain wall is absolutely appropriate for our climate, because it's also used in the coldest places of the earth as well as the hottest places of the earth. Like Kiran Bhai mentioned, it is a growing trend now in a lot of projects to insert, ventilator panels within the actual window. I mean, Shuko is here today, and we've done a project with them where you have these ventilator panels that allow air in, but they don't allow mosquitoes and humidity and all of that. So again, going back to the initial point, I think well-engineered curtain wall, keeping in view of, is my facade facing north, south, east, west? I mean, that used to be a discussion only reserved for commercial office buildings. I don't know why it can't be had for residential buildings as well. The extent of the chajjas, I mean, for example, somebody showed a facade system with a chajja. We've done one in a project in Mumbai executed by Aluplex. But I wish if I had some more money, we would have probably done the west and the south facing chajjas a little bit larger and done away with the ones in the north, because we don't have any direct sun on it. And in that transaction, sort of optimize the cost. So there's a large section of our fraternity that is against curtain wall. I'm definitely not in that section, because I think it works if done intelligently. That's the main line.
Yeah, I think consultants and contractors really like that statement, so we'll stick to that. I'll take a second part of that question, and this is more specific to residential buildings. I think we have all come from low-rise living and then suddenly graduated to high-rise living, and you go around looking at residential buildings with curtain walls or with sort of curtain wall balconies, and then suddenly you see these sort of pigeon nets and, ceiling fans on the 50th floor in a balcony, and, somebody's just installed a sliding panel. I think there are certain adaptation issues maybe, but I think Kiran, if you can throw some light on that, of how do people react to such spaces?
No, so I think, I think there is, I think one of the, and I think I just want to say that it's an evolving field. I think multi-storied or very, very high buildings, and today, tall residential buildings, today a 15, 20-storied building is not considered tall. But I think once you go beyond a certain kind of height and things like that, I think one must really question whether balconies, like say for example a balcony on the 50th floor with the wind pressures, etc., will ever be used and things like that. So I think those are concerns that I think we as as the fraternity, the architecture fraternity and the developer fraternity needs to mature up and say that that what is it that one should do and one shouldn't do. I also think that as we kind of increase the use of glass, which I agree with what Carl is saying, that just kind of using glass incessantly without any thought may not make sense in our kind of climatic consideration. But I think glass as opposed to a lot of concrete definitely makes sense. It allows kind of natural light to come in. Also our spaces, because of the ticket price, are getting smaller and smaller. So natural light coming in just makes your space feel far more, visually nicer. And I think that, one has to look at, how curtain walls are kind of put together. I think if they're not put together well, they can be a real problem in terms of, cleaning and stuff like that. But if they're well put together, like for example, incorporating horizontal or vertical, chhaja elements into the facade rather than doing it in concrete and then cladding it, I think those are kinds of issues that we have to kind of completely move away from. And I think gradually we are moving away from an integrated system where windows, chhajas, vertical fins, etc., all incorporated into the kind of main facade system. So I think that it's an evolving thing. I think some projects do it better than others, and I think overall the general standard, in my opinion, in the next 5 or 10 years will, I think, enhance considerably, as also the industry keeps improving. I think the industry is also, personally speaking, in its nascent stage. I've known Naveen for a long time, and he started off with Windows, and now it's graduated to a much more complex system of engineering, etc., etc. And I think that is, so I think clients need to mature up to the industry needs to mature up to the challenges, architects need to mature up, and I think that's what the need of the hour is actually. I'm mainly talking about residential buildings, not the commercial buildings, but residential buildings is the key challenge today. I think a lot of what we are building is a lot more residential than office buildings, that kind of a thing. The other thing that, I also feel that, one of my pet peeves actually is this, that, most office buildings go in for, ratings. And I'm not a big fan of ratings, but at least they kind of discipline you to see how your building is really going to behave. And the reason for that, I personally feel, is that commercial buildings, the whole kind of nature of the game has changed completely. Then, generally speaking, these buildings are not sold. They are kind of held by some kind of a fund or a REIT, and they lease out, which means that they have skin in the game. By skin in the game, I mean that there's an owner who is leasing out the property, very concerned about, what the tenants will want, how the building kind of performs in terms of climate, in terms of energy use, etc. Unfortunately, in residential buildings, that is lost completely because we still follow the sale model, which means that, a unit is sold and then, goes away and stuff like that. And I think that needs to change significantly, I think, where I think developers need to take ownership of the projects way beyond this thing and stuff like that. I'll give you an interesting example of a residential building. We're doing a large development for Lodas at Palava, where the building is over, occupants have come in, occupied the building already, and now, we're kind of going back. And now doing, for 2,000 people have actually agreed, these units have been sold, to come back, and we're doing a kind of a retrospective study of, how the facade is behaving, whether we can, use better quality glass. There's no curtain wall there, but how we can use better quality glass. A lot of this is even getting, this is quote-unquote green funding. It's getting funded by the World Bank, where, we are monitoring use of water, use of light, electrical, etc., etc. So I think, residential buildings need to, the whole kind of component needs to get a lot more kind of energy conscious as to, what are we really bringing to the table with the end user. And I think, and I don't think it's impossible. It's not the question of just selling a unit and then the developer. I think developers themselves are, I think, equally, I think quite committed to it. But I think how does the end occupant, the designer, and the developer come together as a long-term plan, because it's a win-win situation for everybody kind of a thing. And I think that's the need of the hour, in my opinion, actually.
Right, so I think we can actually carry forward a lot of learnings from that exercise, but essentially we're talking about more accountability from a developer standpoint. You just don't sell and move out. You have some level of responsibility continuing into the car.
I want to add a small point. So, when I saw the presentation from Benoy and what you were also saying, Kiran Bhai, we as human beings are basically wired up to be wanting to be close to nature, right? That's the holidays we take, that's you roll down the window of your car, etc., etc. So I think that balcony topic is much like the curtain wall story. In fact, in Bombay, the higher you go, people want larger balconies. Maybe in some time, everyone will realize that that was a big mistake, and they'll stop at some level. So I think it'll play out.
Sure. That's what it's an evolving kind of, it's an evolving game, and I think, everybody needs to kind of mature up, architects, developers, end users. I think that's...
Agree. Before the architects take the mic on, I'd like to pass on the next question to Vicky here. What are the key differentiators? I mean, how do you actually differentiate the design process between doing a curtain wall or like a fully glazed facade that goes on a commercial building versus residential building? What are the drivers? What are the differentiators in the design process?
So, since it's a curtain wall element, so the design principles, whether we go for an office building, the basic design principles for an office building or for residential building, they remain similar. These are structural integrity, water tightness, air tightness, seismic considerations. Beyond this, the differentiator factors would be selection of materials. Example, if I'm proposing a glass for a residential building, expectations are more sunlight to come inside. But at the same time, we need to catch some amount of heat or leave the heat outside the apartment. Whereas in office building, we want to have more thermal efficiency because the HVAC heat load conditions are not similar in both these scenarios. Second is selection of materials in terms of their durability, maintenance. The maintenance aspect, what we can get in an office building, because they have a facility management team inside, the frequency is quite regular. In residential apartments, if there is no certain facility management team, then probably this maintenance aspect goes for a toss. So materials should be selected in such a way that they are much durable compared to what we use in office building. Third aspect would be safety. If I'm designing a facade for an office building, I know that there's a mature adult who is going to occupy the space. When I'm designing a facade for a residential building, I know there's a child who's going to be 3-4 years old and is going to be risking himself or exposing himself to any fatalities if there's a design flaw. Example, if I'm using a railing, I should not be keeping sufficient ledge on the inside on which the child can stand over it. So that's also a critical aspect. After that, balconies, like we just spoke. Currently, when you have balconies, facade in curtain wall glazing, you have a tolerance in which 15-20 mm you can play around. But if the construction tolerance is way out, suppose every subsequent floor has a in and out movement, the integration of facade, the detailing of facade becomes very critical, and there can be seepage issues which can be a later chaos. One more concern with balconies would be, majority of time you'll have a drain which is facing towards the building. So when you have a drain facing towards the building, you have a gutter channel which is going to drain the water out of the facade, then again there's a clogging effect which might happen around. Second aspect would be punctures in the facades. We all know that curtain wall performs better when we do not have any interruptions, an uninterrupted floor plate. Unlike in office building, we have a floor plate which is completely open. But in residential apartment, you'll have walls somewhere. So the more number of punctures, the more probabilities of having this water failure. So yeah, these are the key determining factors which we keep in mind while designing the facade for an office building and the residential apartments.
Great. So apart from the technical parameters of how the building is supposed to perform with wind, with water and other factors, I think it's equally important to consider who's going to be using that space behind the facade and how they typically live or occupy in that space. And that starts defining a lot of things in the design approach, material selection, safety, and so on and so forth. Next question, which actually took me a couple of hours to come up with, that's for you, Mr. Keswani. And I mean, I literally could not think of a question, what do I ask a man of your stature? You've seen curtain wall applications over I think a few decades now. I think a lot of people say that, McDonald's, when it came into India, it changed India, but I think India changed McDonald's more than McDonald's changed India. How did India change curtain wall? And I think we've seen a lot of jugaad applications and everything else. How did we adapt curtain wall to our way of working, our way of building, our way of constructing?
I think if I start from where you stopped, and if I talk about only two people, one on my left, one on my right, or with due respect, one on my right first, then we go further. And it's going to be a continuation of what you asked me now, because he just said something, and I was waiting to interrupt him, and I didn't. And you said something, waiting to interrupt you, and I didn't. And then you said something, and she said something else. So I'll first start with her, if you don't mind, because she's a lady. And she's got me excited, not because she's a lady and a good-looking lady, but the fact remains that she got everybody excited, all the contractors, including Shuko, who's a system supplier, because she said the market's so big. And she spoke of such big floor plates. And she's talked about what 200,000 square feet mean nothing, 500 million means nothing, and what is happening all over the country, particularly in Hyderabad and other areas she talked about. So I think the market's so big right now. It's on a Red Bull run, like I've been saying. And when my great stalwart friend on the right, who is more a friend than an architect, and he brought curtain walling to this country, which he didn't modestly tell you, as the second curtain wall in this country, the first structurally glazed curtain wall, which we did for him for a building called Crossroads with a Singapore architect. And I still remember him calling me one day and he said, let's go to Singapore, just come with me because you know how to make good windows. And he should be applauded for bringing curtain walling and structural glazing to this country. And when I'm going to tell you the second story about him, it won't take more than 20 seconds. It may create a lot of embarrassment for a lot of people who don't know this story. This young man one day, I still call you young because you still talk about curtain walling. And he called me one day and he said, I have to go to Bangalore with a builder. And I said, who's this builder? I don't even know whether you remember this story. This must be about 24 years ago or 25 years ago. And I was still the same energetic man that I still think I am, or maybe I was more energetic. And I told him, I don't have time to come. And he said, why? I said, I have another client, I'm going somewhere. And like a good friend, he said, you Sindhis only know how to make money. And then I asked him, who's the builder? So he took a very simple name. He said, you won't even know this man. So I asked him, where's his office? So he said, Mahalakshmi, and he's in a building called A to Z Industrial Estate. I'll never forget that because my industrial estate was next door, called Mahalakshmi Industrial Estate. And then after 4 days, he goes to Bangalore, and he goes to see a building which we had done for Ascendas, and we were making a park there. And for Ascendas, with a lot of glass. And my friend goes, they go in an ambassador car, which also I got yelled at later, because that time there was no Uber or nothing, we didn't organize. And he and Mr. Abhishek Loda went together to study curtain walling and bring it to India. So he's the man who again brought curtain walling and structural glazing in the Loda group of companies. One more applaud for him. And more importantly, I still remember that when he came back, he designed again the third curtain walling building of this country, which was the I Think campus, where K.R. Suresh was the consultant. And together they created the first structural glazing job of this country. So it's evolved. And I may not take more than half a minute more, but I must talk about Carl, who just now said 5 minutes, that 5 minutes back or 20 minutes back, that curtain walling came here much before him. Carl just brought in the largest sliding window, integrated, built-in residential high-rise project which he designed for Crown, where BS got involved. And I know what has gone through it, where every single unitized panel, ladies and gentlemen, is 7 meters wide, 4.2 meter high, how we transport it from a factory, how we bring it there, how we got integrated tracks, not with only a system, not with only a transom and two male-female verticals and one head and a stack, but with a built-in track extruded and how the shutters get in. And we're doing a 70-story building, or rather 3 towers, and he'll tell you more about it. So he can't say, I don't know the subject, I don't know, I was born yesterday. And you know, he is very deep into where he's coming from. And where I'm trying to tell you is that the market has evolved. Curtain walling today is part of the high-rise structure in terms of high-rise residential. This is where your question comes from. And I'll just end with you because you must know from where you said, Vicky sir, you're a consultant. And consultants are a breed apart. Architects are dreamers, according to me. They take a pen, they sketch, they draw the impossible, and it has to happen. Owners are cost-conscious, time-driven, bulldozers. They agree to everything with all that the visionaries say, which you will agree. And the contractor gets the brunt to bring the cost down. And then you guys come in between somewhere who are like Gautam and others, and they create history by using that right word which Gautam doesn't like, called value engineering, but that's what it's all about. And then you call us and say, now value engineer the facade. And there's nobody better than a contractor to explain to you that there's nothing called value engineering. And there's nothing where you can challenge the specifications. So when you say that there are very complex corners, and in a residential facade, you have too many joints, too many corners. What do you think you guys are there for? To create that magic, put the spelling, tell us where the fire stops are there, tell us what to do. What do you think we are there? And you mentioned something about leakages. Why should a curtain wall leak? It should not leak. They should not leak at all. It's been tested, it's been done, it's been designed, it's been engineered, it's been fabricated, it's been produced. It's gone through the rigorous test. It can't, sir. With due respect to you. Not because of age or because of my experience, but I'm going reverse. Curtain walls don't leak. Curtain walls are not supposed to leak. Curtain walls are supposed to withstand every single aspect for which it is designed, engineered by a curtain walling company or by a system supplier, provided it is rightly fabricated, delivered logistically, and installed. I still have to hear from anybody telling me that an aluplex curtain wall leaks. Or for that matter, my own brother is sitting here, that an alu-fit curtain wall leaks. I could name another 20 names. They don't leak in terms of any way. But by and large, you need good fabricators, sir. And you need good people who understand, who are passionate about what they're doing, and then the magic happens. So your answer is there that the residential market is there and the product runs.
I'll try again once maybe. I think one part of the question was that you said that there's a term that I don't like, which is value engineering. So we value engineer the facades as soon as they hit the shores. Classic solution that we've seen abroad, like, "Arey bahut mehenga hai, aluminium kitna hai isme, can we reduce it, can we increase it?" All of that. But apart from that, how have we adapted? How have we changed curtain wall that reaches our shores compared to what we see abroad, what we end up liking abroad, and then we don't see the exact same thing happening here?
India is a dynamic country. Indians are people who adapt so fast to everything. You're the only country in the world where there is a death in a Christian family and he goes with a suit and with shoes. And you go to an Indian ceremony and there he wears the suit at a wedding and he wears white at death. So we people, I'm just giving a raw example, but we understand everything here. You take a city like Mumbai or like Bombay, what we would say. There's a, bomb blast. And 24 hours later, the trains run and everybody goes to work. It floods, nobody complains. I know people who cross 4 trains just to get to work. So people adapt themselves to everything. When we were young and when we were looking at curtain walling and we used to go abroad and see buildings, I actually remember with those old Kodak cameras that we had, which I call them Kodak, and lying once on a street in London, in US, and sleeping down and taking the photograph of a building called the Chicago Towers, which was there at that time and still around. And we look at big buildings to dream, how will this ever happen here? And then you showed me Shenzhen just now. Somebody said that, Dennis, so I would say George showed that, Gregory. And Shenzhen came up in the last 25, 30 years, and 30 years ago it was raw, barren land. Look at Mumbai now. Where was it 10 years ago? Where is it now? Where was it? What I'm trying to say is, look at Hyderabad, look at Bangalore. The Indian curtain walling product has adapted itself as much to an Indian condition to as much as it has been duplicated from abroad. The same product comes here. The same product is engineered. Just now, 2 hours back, we spoke and we had Shuko showing you the 1000 kPa bottom track which he was talking about, or the adaptation. And the Indians keep on adapting it and moving it faster. And how, when, where, why is a subject which can have a separate session. But you can see that it happened. It's like saying Saint Gobain brought in glass. And they brought in clear glass initially, or reflective glass called ST. And then they went to ET. And then they went to SKN. And it wouldn't stop. And I can only end up with one example, which again will be in lighter humor, but I can't explain your such a small question in a half a minute. Otherwise, I have people like Suresh saying that I'm going to keep them away from lunch and we'll keep talking till midnight. But the point is, like, look at McDonald's. You mentioned it, so I bring it back to you. You never thought of having an aloo tikki McDonald in this country, yeah? But Indians do it. Indians do everything fast, yeah? We are faster than the best. And I always say, you're better than the best. I'll end with one sentence. I remember Russell Cole sitting here, who's right now sitting as the, according to me, the keynote man or the key person in the global facade industry. He came once to a project we were doing in Hyderabad, in ICICI. And Rajan and Gautam, you both are offshoots of Russell, I would say. So am I. And with due respect, he came and he saw that building midway, which Rajan was doing. And he came and he asked for the facade contractor. And he took me to the corner and he said, "You actually produce this in India?" So I'm trying to say that Indians do everything and they do it correctly. Give them a chance, give them an opportunity, give them money, give them time. Otherwise, you won't have so many Google presidents and Pepsi presidents who are all Indians. Thank you, sir.
Amazing. I think we could have dropped the mic there and then moved on with lunch. But I have one more question addressed to The project management side, I think we all design great solution, engineer it. What are the sort of key drivers when it comes to successful procurement of a curtain wall solution or a glazed solution? Like we all spoke about the efficiencies that it brings about, where everything is off-site, it just dovetails into each other, it's like a plug-and-play system. But I know you've seen the pain points and the blood that goes behind the wall of how to actually make it successful. Any thoughts on that?
Yep. First of all, it's a pleasure to be on the deck with such experienced panel. Now, we deal with the delivery of the project, basically, when it comes to project management. And as Mace, I'm representative of Mace doing project management for some of the key projects here in Mumbai and across India. One of the, and Mace is a contractor in UK, and they have evolved as a contractor saying that the project should be more like a production industry. Here, the curtain wall plays a very important role. In some of the buildings, what they have achieved is about 90% off-site production. You know, construction with 90% of off-site production and only 10% on-site. And that's basically assembling. I see the curtain wall is one of the key player over here, you know. So it gives me modular system of construction. So once structure is finished, you know, you can quickly complete your facade. And generally, you know, the facade starts from the concept design, from the mind of the architect. Facade is nothing but it's an appearance, first of all, you know, how the building appears. From there, the design evolves to usability of the building, how the constructability, modular construction, how quickly I can finish the building once my structure or skeleton is completed. So here, for me, the curtain wall plays a very important role when it comes to designing the curtain wall, which gives very good appearance, at the same time, reduces my overall construction period, and gives me a good view and usability for a long time. You know, if the project, once we complete, we need to be very proud of. At the same time, that project has to be very much viable for everyone across the, say, industry. For example, developer says that, okay, you can have a very good curtain wall system, but if it has like 20 modules, 25 modules, the production time increases, the installation time increases, and the complexity increases. So what we see as a project manager when it comes to value engineering, you know, which people don't like, and we bring it at sometimes very late states, that's our problem. But you know, the constructability, one of the late problems what we bring is about the constructability. If we reduce the number of modules, if we reduce the intersection, number of intersections, if we are reducing the, for example, different types of materials what we are using in the facade. So these are the things will generally, you know, make the construction quick, give the deliverability, you know, to the developer, from the developer point of view. At the same time, this will, you know, give the complete, say, as an industry like fabricators and production people, as well as, you know, the procurement strategy, make it very simple when we go for, from doing the off-site construction to getting on-site and just, you know, plug-and-play system. So that's where the curtain wall system, you know, gives me a very good flexibility, and it's a future for India. That's what I see. The curtain wall system is the future. How best we evolve with that? I have seen some of the factories recently, you know, visited them, and some of the innovations what they have been doing, that it's really appreciable. And I mean, if I see the high-rise buildings, you know, the balconies is a very particular issue of India. Most of the countries, we don't have such huge balconies. Indians like balconies, but it comes with its own problems, which we need to, you know, resolve and come up with the systems which are required for the industry. In overall, what I see is that the curtain wall system reduces my major problems. Number one is, completing the structure within the timelines. When the skeleton itself has delayed because it's unitized system, I can come and hang it at later stage. Number one. Number two is the durability. The facade is more durable. Accuracy, it gives me very good accuracy and solves many other problems, which are inherent problems due to some other type of facade if you are going other than unitized systems. That's my point of view. I think I covered so many other things in a random way.
I think the timings couldn't have been better. 5, 4, 3, 2, 1. You can have a very quick go, Vicky.
I'll be unsettled if I leave this discussion unanswered. So answering two of your points, Navinji. One is about value engineering from the consultant's point. So when we work with client, with architects, our first role is to satisfy architect's intent, keeping in mind the pocket budget what client has. So value engineering can be as small as just redefining the grid panel sizes and save some cost on glass wastages. Ultimately, probably there have been rounds of iterations with the architect, with the client, with the consultant. Hence, when it comes to a contractor does not see much of scope for value engineering because those exercises have already been taken care by architects and consultants before the tender is floated. Second, we all are here, we all are working on curtain wall majorly. We firmly believe curtain walls don't leak. The point what I was addressing is to Gautam's question of design parameters and challenges with regards to using curtain wall for an office building and for residential building. But that never said that curtain walls leak.
Okay, I think we can carry that banter. We're out of time. If there's any questions, there is lunch outside. All of us are outside, so we can carry it there. So thank you, everyone. And thank you for the panel.
Thank you so much. What a great day this has turned out to be, and I hope you all are able to find the connects, learn from one another, and of course, that will indeed help you in innovating in your respective fields. Well, taking the conversation forward, we're now talking about fire hazard. Is it a jinx or a reality? To address this particular topic, we're elated that we have with us Regional Director, South Asia, Avante Façades. We're talking about none other than, ladies and gentlemen, put your hands together as we welcome K.R. Suresh.
Thank you.
Thank you so much.
So today is going to be a fiery session now. I start with the video, and I know everybody knows which building this is. It's all images which are scary and which can happen to any building in Mumbai or anywhere in the world. So I'll just, these are all the flames. This is basically a building, Grenfell Tower, which has been shown multiple times. Everybody has seen it, and that's how things have changed all over the world. I think everywhere. I think if you see DLF has changed all their ACP panels. Bombay has seen some changes, and I think it's a good lesson to learn. So what has happened after this is, I think it's more of, codes have become more stringent, and we've got more, everybody's been aware of what we need to use and what materials we need to consider for, especially for high-rise, where you can't think of replacing that part of the building because it's too expensive to replace it. So you do it right the first time. So this is actually another incident which happened where we talk of soffits in the balconies. We feel nothing is going to happen there. So this is what happens. Somebody put a cigarette butt in a plastic can, and that burned the ceiling. And over time, what it did is it went 23 floors up. It's an actual project. It's in Australia. So now you may have combustible material in any part. You may have a curtain, which is combustible, or you may have maybe a PVC or FRP pot in your balcony, which can burn, or you may have an air conditioning unit which can burn. So this is what happens. So we feel that nothing will happen to our building, but that's not true. So as a consultant, what we believe is, to take a precaution before, rather than, thinking of what to do later. So these are the actual pictures of the project. So I just want to get a context to what I'm talking of, and how do we build this up, So if you look at it, there is something, you need to consider as a fire resistance. Fire resistance is to a system. It's a system-based code, where we talk of, a whole system has to perform. It has to resist the fire. Either it should not structurally fail, or it should not allow the heat to travel, or it should, be insulated. It should ensure that the person standing on the other side doesn't burn because of radiation. So that's what we look at. In this, it's a system-based solution. Now, your fire stop is a system-based solution. So you're doing a fire stop in a building, which is between the floors. So I'll just come back to that. This is for the material, where you're talking of, different class, where you don't want to use a combustible material. But in the market, there are so many products, and we are all confused with the products. Everybody comes up with a test data, which may not be true. It is from a lab somewhere, and you just do whatever you want, you want to see as a client, and you buy the product. So you may have, polyethylene, you may have PVC, soffits, you may have, different products which are combustible actually in reason. And across all countries, there have been many changes happening. But in India, being a developing country, and in 2-tier, 3-tier cities, people just use it. But we don't know what the fatality could be, So these are the codes which are already there. Only thing, we don't read them well. We read it for our interest. We just do what we want to do as a developer or as an architect or a consultant. So I think this is more important that we understand what it is about. This is all there in the NBC. I won't run through this. So if you look at it, one is the perimeter barrier and spandrel, and then you have a linear gap seals. Wherever there is a seal, wherever you need to flash it, it has to ensure that the fire or smoke doesn't travel. So you need to have an integrity, which is basically EI 30, basically means 30 minutes. So you can go till 120. Now your fire stop is actually 120. It has to be 2-hour fire rated. So your flow slab and the gap between the flow slab and the curtain wall should actually have a fire rating of 2 hours. So that's the assembly. Now how good do we do that? That is something we need to look at. Now, in terms of a material, we talk of insulation. Now what has happened is during the, the climate change and the LEED certification, the performance of buildings, we forgot to understand that there are materials which we are using as combustible. So we talk of insulation. There are different types of insulation, but we need to use the right insulation at least. So what has happened is, if you look at this glass wool which we use for curtain wall for the spandrel areas is basically it's not hydrophobic. That means it can absorb water, and the performance can reduce. This is a mineral wool which is not, it doesn't absorb water. It has got a higher melting point. Now why we don't use it is because it's more expensive than glass wool. So we try to think that both are A1, class A1, and we can use any of them. Now this is basically a foam insulation which we use for better acoustic and better thermal, but we forget to see that it's combustible in nature. So what the supplier talks of is it doesn't aggravate the fire. But if the source is there, the material is going to keep on burning. So what you saw in the other slide is the same. Like it can go 23 floors, it can keep on burning because source is there. So this is all the different types of insulations which are there. Why I'm coming to this is because your fire stop is related to a mineral wool. Every material is related to an insulation which is put in. So now this is a typical layout of how a fire stop is installed. So if you look at, there's insulation where the heat should not travel up to the next floor, and there's integrity, that the material what you put in between the floors should stay. So if you look at this, there are 3 ways the fire can travel. One is through the floor slab, between the gap between the floor slab. One is between the spandrel, and the third could be a frog leap effect, where if you reduce your spandrel height, the glass can break. On the other floor, it can just travel on floor to floor. So this is what happened. This is an image which is 20 years old. This was one of the sites where we took we made a report, inspection report, and this is how they used to do the fire stop before. They used to have a GI tray, they used to just dump in some glass wool and say, I've done my fire stop. So there was no tested system 20 years back. But because of all the fires which have happened all over, there's been awareness. So now people have started understanding what is the importance of this. And there is also, I appreciate all the agencies who are doing it. They've got good applicators, and they're actually promoting it in the right way. The awareness was not there 20 years back. And recently, I think 5 years, we have started doing the lectures and, on fire, and a lot of conferences happening. So it is good in terms of awareness. Now, this is what happens when a fire stop, how does a fire stop behave when there is fire? So what happens is like what previous speaker said, the aluminum softens and it deflects when there is fire. The building also, there is a movement to the building. So this is what happens. So this whole fire stop should not disintegrate. It should not allow the fire to travel to the top by keeping it in place. That is what you need. So there are two types of systems. One is a wet system and one is a dry system. So wet system is something like, you have a mineral wool. Both the cases you're using mineral wool. You're not using glass wool. You're not using foam insulation. You're using mineral wool. You're compressing it so that you put it into the cavity depending on the size. And you have a elastomeric spray which is applied to ensure that it expands. And when the mullion deflects, it should expand. So this is how it is installed, and that's the spray. This is a dry system where actually they turn the insulation and they compress it. They do it, the grains are turned the other way around. It's already manufactured like that, and they just need to keep it into the cavity. And there's a dry system where basically they put a tape on top of this. It's a fire stop tape which they put where the joint is, so that your fire and smoke doesn't travel from one floor to the other. Now, in this case, what happens, it's more easier application because you don't have to spray. But then both systems are good in terms of there is no problem, it's all tested, and it's all recommended. Only thing is the applicator. We need to have the right applicator to do it. And as a client, you need to get the warranty from the applicator and the main manufacturer, like, it may be Hilti or Siderise or whoever. They need to give you a certificate for the project. Now, when you test these things, there are two ways to test it. One is a ASTM and one is a EN. So in ASTM, what they do is they basically have a furnace, and the material is kept below that, and it burns. Now, I would say this is good for a material testing. In the sense, if I want to see whether it's combustible, whether it aggravates the fire, I think this is the best way to do it. The other system is more for a curtain wall, where you have a cabin. You have a chamber which is there, and the heat, they have the certain codes which say how much is the temperature and all that, and they simulate it, basically. So this is something which is more stringent, and I think it's applicable for our curtain wall. Now, this reaction to fire, what we are talking is more to do with materials. Like, how does a material burn? How combustible is it? Or is it something which we should be using for our project? Because replacing a material later is a big challenge. You'll never be able to replace a material if it is 10,000 square meter. Nobody's going to do it. And plus the cumbersome, you need to replace everything. You need to replace the system and everything. So you need to think of a material which can be used. Now, there are 3 parameters which you need to look at. One is a flame spread. How is the flame going to spread when there is fire, from the source? Second is droplets. If it melts, if there is a material which is combustible, what are the droplets which come onto you when it burns? And third is the smoke. So all 3 parameters need to be considered. So when you see a test certificate, you need to look at that parameter. So if it is basically A1, A2, that is something which is not combustible. Your smoke development, it is S1, S2, S3. So you have basically, it should be S1, which is basically, it is less of smoke during the burning of the material. And third would be burning droplets. It should not happen at all, because you can't afford to have burning droplets coming from the top. So you need to be very careful on that. And there are codes already made. It's all there. Only thing is we don't read it the right way. So this is the whole summary of it. Now, this is the whole, what you see, like S1, S2, S3, D0, D1, D2. Now, what you see here is non-combustible, and then you start with B, C, D, E, F is combustible. Now, if you look at most of the materials which are combustible, and they are used for different applications, are in the category of B, C, D, E, F, which I think for a high-rise, we should not even consider that. That's something which we should avoid. So for a high-rise, I would consider this parameter. I would consider this parameter as the base, and forget all the other parameters. I would not even consider that for a high-rise. If it is a low-rise, it's easy. It's a different thing altogether. If it is a clubhouse, it's a different thing. If it is an open surface area, it's like a shed or something. It's a different application. So there is no problem. Now I'll just talk to you about what, like there are so many circulars which are come by the fire officers, and every building has a challenge. I see some buildings which have got a top hung window, whereas the CFO talks about a side hung window. You need a handle on the inside, outside, and all that stuff. So this is a project where, this is as per NBC. We need to make a 1 meter by 1 meter window with a handle on the inside and outside. So what you see is this, where it spoils the architecture. So what I would say is, we need to rethink on this whole thing. Even though the circular is open, I would say that, a hardware has got a warranty. It doesn't last forever. So your building is going to stay for maybe 30 years, but the hardware will start failing over time. And these are the challenges which you'll face in a high-rise building, where you can't keep on replacing these things. And there can be fatalities later. Window coming off the building. Like there may be hardware available, but everything has got a time. You can't have it lifelong. So there's no hardware which is lifelong. So this is what is one of the challenges. And second, this was the remediation. You could have a breakable glass. If you want to evacuate people, you could have a breakable glass where the smoke goes out. That is something you can do, because your fire tender can't come above 50 meters. Even though you got a 100-meter fire tender here in Bombay, but your roads will not take it. Your infrastructure is not good enough to take that. So other way of doing it is you have actuators, which I think the next session will talk about that. But actuators, when there's a smoke alarm, the window automatically opens and the smoke travels out. And it closes in, and it is used for also skylights, where you have heat trap. This window can open automatically and it can take care of the heat. So this is how the different options are. Another topic which I would like to touch is the cavity barrier, which I don't think 90% of the projects ever uses the cavity barrier. Because we just go for metal cladding, we go for stone cladding, but we don't understand that when it's a staircase and when there's a window, there is every chance that the fire can travel from the cavity. And that's a danger, because it can travel all over the building till the top. So if you have a flammable material, it can burn the whole floor. So we talk of, it is not near my glass, so there is no problem, it is not flammable. But you may have a cladding which is flammable and it's on the staircase wall, but that can burn the whole building. It can just go into the building from some place or the other. So the cavity barriers are basically made so that you trap it every floor. Like your fire stop, you're basically doing a cavity barrier. So like your high pressure laminate, which we talked about before, it should have a cavity barrier in between the floors. So it doesn't allow the fire to travel. So previously, this was the system. They used to put an insulation and they used to put it touching the cladding. But the problem was you could have, because of the rain screen, you could have water accumulating in that cavity. So what they started doing is, this is a new system which they use an intumescent and keep a gap between the cladding and the insulation. So in case of fire, if this gets heated up, it basically starts, the intumescent starts blowing up and it closes the gap. So you don't have fire traveling. It basically stops the fire at that level itself. It's like a compartmentalization which happens. Now these are the tests which are done. So Intratech is already there, they have a booth outside. I think they are the people who are basically authorized to test these, and we got Winwall also here, who test fire materials. The other thing which I want to touch base is, because I've been giving these fire conference lectures all the time, but there needs to be a solution. So the only solution is, if you start thinking, how do I avoid it? At least for the future buildings and for the old buildings, which are dangerous. So in UK, I was just talking to Russell also. I was confirming it with him, whether they are implementing it. So basically what he said is they implement this system. So EWS1 is a form which is given to, if you want to lease or if you want to sell a property. You can't sell it unless you get a certificate. It's a simple certificate. It talks about whether you're using combustible material or not. And if you're using a combustible material, are you repairing it or not? And what will be the repair charges? That your lease rent will depend on that. So there's a form which is given like this. But then I would say that the difference here is, I don't think they don't make pictorial takeoffs. So it's a lack of people. You don't have people. You need somebody who's, who understands the subject and look at 10,000 buildings in UK maybe, to which are basically cladded with metal or with some flammable material, combustible or non-combustible material. So what has happened is, I feel in India also we could implement this. This could be a good start, where you have some authority who's talking about it. And the CFO could do that. He could say that I need qualified people to come on board and inspect these buildings and give me a certificate, and you're responsible for it. Yeah. So I think that is what I feel it should be done. Now, what I don't see is a pictorial audit takeoff, because there is no lack of people. So I think this is something we could implement here. Maybe go slow, but you implement it in a way where you have a pictorial takeoff of the building and keep it on record, so that when there is a fire, in case there is a fire, this guy is penalized for it if he's giving the wrong information or something like that. So it could be, an engineer who's inspecting it could be negligent to, inspect it properly, or he may just give a certificate. So all those things can be reduced in this when you start getting pictorial takeoff and have a record of it. So I feel failure is good as long as it does not become a habit. I would end my session with this, saying that we need to be careful, but we should also need to understand what is the right way to do it and take precaution on it. Thank you.
Thank you so much, Mr. Suresh. One thing we have to compliment him is, of course, he helped us to envision so many various aspects which could help us avoid a fire hazard. So let's compliment him with a big round of applause, and of course, sharing his futuristic vision of what India as a country can do. Thank you so much.
Thank you.
And thank you for being so kind with your time. Up next, ladies and gentlemen, at the Zak World of Façades, we're moving ahead to our next topic. Well, it's said that 2 is better than 1 in this scenario. We've got the topic, automated facade smoke extraction. We're talking about the solutions front. On that note, it's my honor to invite on the stage 2 very prominent personalities. First up, the Director of Global Sales, SE Controls, Martin Oates, along with the Managing Director, India of SE Controls, Nikhil ParasuRaman. Let's give both of them a warm round of applause. Thank you, Martin. Pleasure to have you.
Okay, afternoon everyone. It's fantastic to be here. Thank you for welcoming me. Everyone I've spoken to, full of energy, full of enthusiasm. It's what I love about this place. Our weather at home makes us a little bit more dull, I think. So today I'm here to talk about facade automation. SE Controls have been a business in 40 years now, global reputation for this very subject, with Nikhil here in India for 11 years. So what we're going to talk about here is the concept of extracting smoke through facade. Very simply, to explain the concept, without that we have smoke that will build up within a building, no escape routes, no ability to fight the building. With smoke ventilation, of course, we detect that smoke early, we automate vents, we get smoke out of buildings quickly to enable people to escape from the building and enable the fire officers to come and tackle the building. So just a few examples for you here of actual facade applications. So here you'll see a common area where we're automating a window at high level to create smoke extract so that person can escape. That could be a corridor, it could be an office, and we're keeping the stair free of smoke as well. Here we have an atria application where we're bringing air in and smoke out. So it's creating a natural effect using the buoyancy of air to get smoke out through the facade. And here you can see a firefighting application. So we have a lift lobby with AOV windows in. We detect, open, get the smoke out the building, get the smoke out the stair. So you've got a tenable area for the fire officers to tackle the fire. Okay, so Suresh, I must pay you later for that introduction on actuators. Thank you. What we're talking about here is an actuated window, or a smoke vent, or an AOV. Well, actually, there is a term. There's a global term for this. It's called an NSHEV, Natural Smoke and Heat Exhaust Ventilator. So that's the terminology of it. So let's get into that mindset. This is a dedicated product. It's a smoke vent. It's not an actuated window. And because of that, there are global product standards for that. We have 2 we have an ISO 21927, and we have an EN 12101, Part 2. Both those standards are very much the same, pretty much identical, and they both exist within our market. You'll see them in certain specifications, I see them in specifications, usually airport-type projects, larger infrastructure projects. And the purpose of that is to create a prescriptive solution. So that is a solution that is repeatable, that's standard, that's sustainable. And why do we do that? To make it work. That's its job, to save lives and open in the event of a fire. So to make sure that product is fit for purpose, and we know it's going to work, we test it. So the actuator and the vent are tested together at an independent laboratory under all the criteria that's important for a smoke vent. Ability to operate in heat, reliability, wind, etc. So we test that product and we place it on the market. So even with compliant products, things can still go wrong. And what I want to talk about here is process, and there's been a few discussions about that earlier today, about getting the process right. Because if you don't get the process right, things happen. So we all are aware of Grenfell, and Suresh just showed a video of that. So post-Grenfell, the government commissioned a review. It was called the Hackett Review, if you've heard of it. And that identified 4 key areas to focus on, why the system was broken. The first one was a lack of policing of compliance. That is, at the end of the project, as it's getting handed over to the client, the policing process was insufficient. The second one was a clear lack of responsibility and awareness right through the build stage. Who's responsible? Who's making the decisions? And that then links into traceability, which has also been mentioned today. Where is the traceability of these decisions? Who made them? Why? When? And also ridiculously low penalties for non-compliance. Where's the risk? Where's the blocker? So what the government did was introduce what's called the Building Safety Act. And again, Suresh touched on that earlier. What that does is changes our market, and this is for high-risk buildings above 18 meters, as Suresh mentioned. So here what you can see is our previous methodology, right through the REBA stages of build. So not until this green arrow here, at stage 5, did we have any policing of compliance. And then the person who was responsible to sign that building off wasn't accountable. So accountable and responsible are 2 very different words in our industry. So what we did, the Safety Act introduced a new layer of safety and policing. And this red here aligns to safety products, fire safety products. And what we did was introduce these gateways. 1, 2, 3. These red black lines are hard stops. What we also did was introduce a new authority, independent, to take accountability for compliance. So not responsibility up there, accountability. And what these guys do at these various stages or hard stops, they stop the build, they check for compliance, and only then do they allow the project to move forward. Prevent the issues, find the problems early. And what we also did is introduce a new digital information process. So everything is recorded digitally into what we call a golden thread. So the client at the end will end up with traceability. That will then ultimately result in safer buildings for our occupants. Also sustainable buildings, as we mentioned. I'll leave you with this little story before I pass over to Nikhil. So last time I came over, we were driving around and I saw all these wonderful buildings, facades, fantastic. Lots and lots and lots of vents in them. So I said to Nikhil, this market is incredible. Look at all these vents. What are they? And Nikhil said, Martin, they're smoke vents. I went, well, that's amazing, Nikhil. That doesn't tie up with your sales figures. I said, so what's the story here? And he basically said, well, they're manual. So I said, well, okay. So I was quite proud of that picture, to be honest. I drew it in the back of a taxi in Mumbai, so I hope you appreciate my skills there. So then I drew that. And I said, Nikhil, why don't we talk to the market about this opportunity and this solution and methodology? And I think what really was interesting to me earlier when I followed the panel, you talked about the evolution of curtain wall, the evolution of facade. Well, this is exactly what I'm talking about. I'm talking about the evolution to practicality, functionality, and sustainability. So I'll pass on to Nikhil. Thank you for your time, and I'll see you all later.
So thank you, Martin, for setting that up. So like Martin said, I'll move on to the next slide. So this was a sketch we made, and that's the idea we are putting forward today. Why not reimagine the automated, or rather manual panel that is there at the moment, because that's not serving much of a purpose at the moment. So I'll start off with an atria ventilation, which is what application we do for airports, malls, the new train stations that are being developed. So anything that has a large atrium space, which you can use the natural stack effect, as they call it in basic physics, where you have top hung outward opening windows, which allow the natural fresh air to come up, and that allows the already buoyant nature of smoke to then drive up through bottom hung windows, which are placed on usually the higher side of the building facade. We also do roof extraction, for which we have a fully tested unit, but today we are focusing on facades, not on roofs. So however, so this is the typical scenario in atrium ventilation. So what this does is it allows fresh air to go in, and it pushes the buoyant smoke up towards the top side of the building. So today's code on NBC, basically it says manual openable panels, which are to be 10 meters center to center, and 2.5% of floor area, which also the calculation that is being used today is not the right way to do it, because the punch window size is usually taken into consideration, whereas you should take the actual triangles and rectangle into consideration rather. And then you have the size of opening, which was there in Sureshji's presentation as well, 1 meter by 1 meter. But because we want large vision panels, those are almost become 2 meter by 2 meter now. And to open a 2 meter vent, it's not possible by a human being. And presently the code suggests that these openable panels are meant for smoke exhaust, and the parties that is responsible to open them are the occupants and the fire officers. That shouldn't be the case ever. So if you see the downsides of this particular system, one is that the vent is too large, because of which the opening angle is too shallow at the bottom. And secondly, once the fire actually emanates, the smoke then comes and hits the ceiling and starts coming down. So by the time the smoke actually starts going out, even if it is manually opened, it's too late because he's already covered in smoke. And also that hampers his vision. Secondly, another thing we have noticed is because of the issue of, say, a trip hazard or a fall hazard, most of these openable panels are not going to open more than 250 to 300 mm. So that is not going to give adequate smoke release when there is actually a fire in the building, because essentially our buildings today in India do not have a method to take the smoke out other than from these openable panels. Either if it's automatic or, God forbid, the glass should shatter due to the pressure inside. So those are some of the downsides. And the other thing is, many of the high security buildings that we are seeing, the handles are taken off post handover. So there is no handle, so who's going to open that vent? That is the final question that I leave you with in today's code. So then what we thought of is, why not place the vents a little higher, which is your actual smoke extraction zone. May that be a 4 meter ceiling high or even a 2.53 meter ceiling high. You place the smoke vent a little bit higher, so that as soon as it opens, if you can see the difference between the earlier slide and this one, you're getting more angle of opening, because naturally the height of the window is smaller, so your angle is much larger. So there's higher chances of you meeting your geometric or aerodynamic free area requirements in a smaller vent like this. And because it is automatic in nature, there is no requirement of human intervention whatsoever for this particular system. So that way, in the early stages of the fire, within 60 seconds of the fire alarm signal being activated, these vents have already opened, and it's already doing its job of ventilating the space around you. So another fact that we are facing now is, we like to see big vision panels coming in, but one of the major downsides of that is, if you can see, the angle of opening is 7 degrees. It's as good as not putting a window there. So the idea, and also the amount of hardware that goes into it, it just makes for a very bespoke, rather expensive solution. We have done some parametric projects as well, but 85 to 90% of our projects are coming with very bespoke solutions, which is in today's day where we are all looking to save money and talk sustainability, but these are not sustainable approaches to designing a smoke vent in a building. So what we are suggesting is to have bottom hung vents which are shorter, smaller height that can open more. You can see the difference right away because the same actuator it's doing its work, but at the same time, since you're opening it more because of the height being lesser, you're getting more angle of opening there. And for larger grid widths like airports, you can go with wider grid widths, so you'll need to go for few more push points. Like we saw India Bulls example in the morning where they're trying to push that window. Now imagine pushing that window in an event of a fire. So, and that is not supposed to be done. So the top hung usually can be used, like I said, for makeup air. So these are some of the examples that I wanted to leave you with. And in summary, we would like to say that obviously today we are a globalized world, so we need to adapt best practices from all the engineers and architects that are sitting here today in the venue. And using best practice is the best way to kind of learn and evolve rather. And when you're using certified solutions, you can also be certain that the product is actually going to work when you're going to call it for during an emergency. And lastly, because it's certified, that's also standardization is applicable because then you're reducing the window size, reducing the amount of mechanical parts going into that system, thereby making it a more sustainable way to ventilate smoke in buildings. So that's us for now. We have a booth outside. So anytime you guys want to come and have a chat about it, we're always welcome. Thank you.
Thank you so much, Martin and Nikhil. Of course, some great suggestions coming in from them and some best practices, of course, being highlighted. But one thing we have to give kudos to Martin was the way he started off his entire presentation with that tinge of humor. It just shows how well a leader can do in adversity. So let's give both of them a big, big round of applause. Thank you. On that note, ladies and gentlemen, it is now time for us to go ahead to our next topic. Our topic in discussion is security glazing solutions with advanced anti-sustainable interlayers. On that note, ladies and gentlemen, coming up next is a Senior Technical Program Manager APAC of Kurere. We've got Malvinder Singh Rooprai. Let's give Malvinder a warm round of applause whilst as we welcome him on the stage.
Thank you, Bhavana, for the introduction.
Thank you so much.
Good afternoon, everyone. So let me just take over the security baton from Mr. Jagdish, who gave a very nice presentation about the security glazings. And at the same time, I feel very humbled in terms of the knowledge which I have to share with you for the security glazings. Okay, so I feel it's an obligation for me to talk about what we do at Kurare. So for those who don't know what is Kurare and what we do, Kurare is a leading manufacturer of the interlayers for laminated glass, and we have different types of interlayer for different applications. So this is an overview of our diverse portfolio for laminated glass applications. As you can see, we have different types of interlayer to match different types of glazings that you may have to use. And today I'm here to talk about specifically for this structural and security glazings. So security is something which is becoming a concern all over the globe. And we have witnessed a number of incidents of terrorism all over the globe. And very few countries are actually have been spared from the rising threats of terrorism. And what happens is glass is the weakest element in a building when it comes to an explosion happening outside the building, as Mr. Jagdish rightly pointed out. And very often, if the choice of the glass is not the appropriate one, it can cause very serious injuries to not only the occupants of the building, but also people who are outside the building. In 2016, we have, as you can see, a big explosion happened in the Brussels airport, and again, a European country which was considered to be very, very safe. And now even countries like Singapore, they are also talking about making their airports. The Changi airport is having its facade as resilient against any blast attacks. So this clearly indicates, we also need to make sure that infrastructure buildings in India, they also have this kind of resiliency when it comes to blast attacks. So we are a democratic country, and when people are not happy with the system, so they find very innovative ways to make their voices hear to the government. And very often we can see the facades of the buildings, they bear the brunt of their anger. So, which is a great loss for the corporates, and for the companies who are, having their offices, or maybe like big fashion brand companies who are displaying very expensive products inside these glazings. Yeah. So again, the choice of the glass is very, very important in here. So one big mistake that often people do is they get confused what is safety glazing and what is security glazing. So people feel that, okay, I have put the strongest glass, which is toughened glass, and it is categorized as safety glass. And so toughened glass is safety glass, but it's not a security glass. And if you make the glass laminated, you are improving its grade of security, but it's not getting really a security glass. Now, the big difference here is that safety glass is actually meant to make the people safe in case there is a breakage of the glass because of some any kind of incident which is leading to the breakage of the glass. Whereas in terms of security glazings, the intent is to increase the amount of time that a person is actually trying to make an entry into the building, and at the same time, it has to be noted that it is not a standalone solution. So here the intention is to increase the amount of time. Okay. So the use of tempered glass for this application is a strict no. You can't use tempered glass for this kind of application. Just excuse me, is the timer right? I don't think so. Yeah. Okay, so the breakage pattern of the glass is very, very important. As we can see, we are familiar with the breakage pattern of the annealed glass and the tempered glass and the laminated glass. So if you move to the right, the breakage pattern is improving, and obviously the level of safety and security that is also improving. But when we talk about specifically about the security glazings, just using a single standard laminated glass is not really serving the purpose. So when we categorize the security glazings, we can broadly classify into 6 categories. So starting from the basic or the entry level, which we call as a safety glazing, and then at the number 6 we have the blast resistance glazings, which is the extreme case of security glazing, sorry. So okay, let's go into further details, into deep depth about these glazings one by one. Okay. So we have, on the extreme left, we have the standard laminate construction where the minimum thickness of the interlayer is 0.76 or maybe 0.89 inoplast interlayer. So this is, you can call as the entry level of a security glazing. And if you go on increasing the interlayer thickness, then you are improving the level of security that it provides to the building. Yeah. And if you move on to the extreme right, we have the ballistic protection, where you actually need multiple layers of the glass and the interlayer. Yeah. Yeah. So I mentioned about the safety glazings. So most of the country standards, they categorize tempered or toughened glass also as a safety glass, which is not really the right choice for these kind of applications, because tempered glass has a tendency to break in small fragments, and these fragments have really a great amount of potential to injure the people, because these fragments can fly up to a great distance and injure the people. So starting from the safety glazing, as I mentioned earlier, so here the intent is to make the people safe in case there is a breakage of the glass, there is an accidental impact, or the glass is just breaking because of what we call a spontaneous breakage. So here we have the EN 12600 standard and the ANSI standard, which is basically simulating the effect of a person colliding with the glass. And So the pass criteria is that glass should be breaking into very small fragments and there should not be any large opening more than 76 mm thick. Yeah. To achieve this kind of level, you just need to have 2 layers of glass with a PVB interlayer, maybe just 0.76 and 0.89 sentry glasses. As you can see here, it achieves all the requirements of the different standards, the NZ standard and the EN standard, EN 12600 standard. So you can see just a standard laminate construction is good enough for this kind of level of safety glazings or the entry level of security glazings. Then we move one notch higher, which is the enhanced safety glazing. So these glazings are required maybe in a showroom where the intent is to prevent a smash and grab kind of threat. You know, if a person is just smashing the glass and taking away the expensive or valuable things which are put over there in a showroom. So we have the UL 972 standard and the EN 356 standard. So here the test is done basically by dropping a metal ball, 4 kg steel ball is there in the EN 356 standard. And the pass criteria is that there should not be any penetration of the glass when the glass is hitting on the glazing. Yeah. Then we move on to the enhanced safety. Yeah, so it's the same. So you can see here, these are the glass constructions. The EN 356 standard is has got different levels starting from P1A to P5A. So you can see the drop height of the steel ball, which is raised from a certain height. That height is getting increased and it is dropped in a triangular pattern. So all you have to do is increase the interlayer thickness for the higher threat levels. And for even higher threat levels, as per the EN 356 standard, like P6B, P7B, and P8B, the test is done through this mechanized axe and hammer. So the hammer breaks the glass, and this axe makes a cutout 400 by 400 mm in the glass. And the intent is to make a cutout and record the number of impacts which are required to make this cutout. And accordingly, this glazing is given a rating. So as you can see, the P6B, P7B, P8B, and the number of strikes, these are this categorization is done on the basis of the number of strikes which are sustained by the glazing. And these are the glass constructions which can sustain the level P6B to P8B with the PVB and the sentry glass interlayers. So the beauty of going with sentry glass is, if you compare the glazing constructions with sentry glass, they are much more thinner, so which means lighter, they are lightweight, and they require thinner framing to be used in the glass, in the glazing. Okay, then we move to the higher level, forced entry. I think the picture itself is demonstrating what it means by forced entry. The person who is trying to intrude into the glazing, they may find very innovative ways of attacking the glazing. They may be using some blunt tools or sharp tools, and they also may be carrying other kind of weapons like a thermal stress, which is like an extinguisher, a propane burner, or also some chemicals to get an entry into the building. So how this test is done? So this testing is as per the ASTM F1233 standard. As you can see in this table, this has got different sequences starting from a ball peen hammer and going up to the sequence number 11, which is propane torch. So they are like variety of tools to break the glass. And on the left hand side, you can see the different thicknesses of PVB and sentry glass interlayer which are required. Yeah. And also there is a different standard which requires these glass to be shot with a glass before attacking 3 times with a 9 mm bullet before you start attacking the glass with these tools. Yeah. Yeah. So this is called enhanced force entry. So in this case, the glass is impacted with the bullets, the 3 bullets which I mentioned about, and then you subject this glazing to the to the weapon attack which I mentioned in the previous slide. Yeah. And now school security has become a big subject in the US. In this case, the glass is shot multiple times. There are 10 shots with a 5.56 NATO fully metal jacketed bullet. And post the impact of the bullets, you have this kind of impactor to hit the glass. This impactor is released from different heights. You can see the height is ranging from starting from 150 to 1.2 meters. And actually these are 8 levels. So all this means is, you are impacting the glass first with bullets and then there is with this impactor. Let's see what is the type of glazing construction that can sustain. So again, we have a comparison with the standard PVB interlayer and also with sentry glass ionoplast interlayer. You can see with the sentry glass interlayer, it can sustain the highest level impact, which is the 8 impact. 8 impacts can be sustained with even with a 4.56 sentry glass interlayer. Yeah. Okay, so we mentioned about the BRGs with which is the bullet resistant glasses. So here we have the cross-sectional view of a BRG construction made with conventional materials which are making use of polycarbonate, which is considered as the weakest element in the BRG construction because it can't really sustain high temperatures and it tends to delaminate. And then we found a way to make this more durable if we replace the polycarbonate with a spall shield, which is a PET film which is applied on the innermost or the protected side of the glass. And and also we have replaced the interlayers with PVB to sentry glass, which helps in overall reduction in the weight of the glazing. So which means you can make the glazing constructions 50% lighter. And also they have high durability, high scratch resistant, easier to process. And lastly, the most important is they are more environment friendly as well. So I will cover that part in the sustainability part of this presentation. First, I would like to take you through that what is spall shield, which I just now mentioned about. So we have a ballistic test done on a BRG construction, which is BR6 as per the EN 1063 standard. So you will see this glass being impacted with multiple shots. And this is the attack side. You can see a lot of destruction, a lot of glass fragments flying here and there. And this is the protected side or the innermost face, which is absolutely safe because there is no flying debris of the glass. Yeah. So here you see there is no fragmentation of the glass. So the innermost face is still safe even after the third bullet. Okay. So I mentioned about the spall shield interlayer when you want to prevent the spalling. The beauty of this product is that it can sustain very high temperatures. So we have done the bake test where you actually expose the laminates for 16 hours at a high temperature of 100 degrees centigrade. So this test can't be passed with the conventional materials like the polycarbonate. So in fact, because of this reason, all the US embassies, they have totally moved away from the conventional polycarbonate-based solutions. And this spall shield is a proven product which is resilient against the commonly used chemicals for cleaning of the glass. Yeah. Then moving on to the blast glazings. So there are two tests. One is the, sorry to mention, I mean this timer is not correct. Yeah, is it? Okay, I don't think so. Anyways, okay. So so there are two tests. One is the open arena test, and the other is shock tube test. The shock tube test, as you can see, is this is a shock tube where you can actually simulate the effect of a blast. And the other one is, Mr. Jagdish mentioned about, is the open arena testing, where you actually make use of a real bomb. Yeah. So we can do this simulation if we have this, if we have input coming from the blast consultant for you. And these are the performance levels as per the GSA standard. Yeah. Then moving on to the last topic of my presentation is the sustainability. That we at Korare are committed to making this planet a more safer place to live. So we are doing our bit, and we have committed that by 2030 we will be reducing our carbon emissions by 30%, and we will be going carbon neutral by 2050. And we have 4 manufacturing facilities, and you can see these are the kind of environmental impacts we are currently making, almost around 4 kgs of CO2 for every kg of interlayer that we are producing. And we will have the EPDs and the LCS available already. For 2 sites it's already available, and by end of this year we will have available for all the 4 manufacturing facilities. Yeah. So this is basically mentioning that we are working on a product called the green PVB, which will have the lowest amount of carbon footprint to the environment. And I mentioned about the Sentry glass, that it has got the comparatively lower carbon footprint compared to the PVB. So this makes like another reason that why you should consider Sentry glass for the security applications. Yeah. Conclusions. Yeah. So interlayer thickness will actually depend, will actually govern that what kind of security levels you can achieve. And also it's important to know the threat level when you are trying to work on a security glazing. So it's very, very important to know that what kind of threat levels are anticipated. And just digressing from the topic, there is a new standard which has come up, which is the IS 17951 for the cyclone glazings. This is a very recent development which has happened. Last but not the least, so when you specify security glazings, make sure that you write the right specification. It should be Sentry glass, not SGP, because it's a fake product coming from China. Yeah. That's all from my side. Yeah. Let's continue the dialogue. We have a booth outside. If you have any questions related to securities, please do visit our booth. Thank you very much for your time. Thank you.
Thank you. Yeah. Thank you. I must say, Malvinder is a force to reckon with. We did have this thing about the time, but I wouldn't blame him when you're so immersed with knowledge and you'd like to share. Time just flies away. But then we're not going to get technical because that's his role. Let's give him a big, big round of applause. Thank you so much, Malvinder, for joining us. So ladies and gentlemen, continuing our conversation, we're now going ahead to integrated coating solutions for the built environment. Joining us are 2 core leaders from AkzoNobel. We're talking about Srishti Gulati and Kuppu Babu. Let's give both of them a warm, warm round of applause.
Good afternoon, all. We hope you are finding this afternoon to be productive and enjoyable. Rightly quoted by a famous author, Robert Swan, the greatest threat to our planet is the belief that somebody else will save this. And the same goes with diversity. Thanks to Jagdish Ji for pointing out this topic, that yes, from 0 to 2, women in architecture is also progressing. We will let you stay with this thought as we, Kuppu, and myself, Srishti, will take you through the integrated solutions for the built environment, which are sustainable, durable, and innovative, and most importantly, colorful, as we believe that aesthetics plays a very vital role in any architectural landmark. We will start by telling you a story about Nick and Bao. Nick and Bao enjoying spending time outdoors, like they go to nature parks for walk or bike rides. Since the ban by the government on single-use plastics, they are made more aware about the big environmental impact they have made before. And since the ban, they have been working towards finding a best possible alternate to single-use plastic water bottles. A hard plastic bottle, a bamboo bottle, an aluminum bottle, or a metal can. But one thing is very clear. They fully support the ban on single-use plastics because ultimately, the single use of anything is the worst choice we can make. But to understand the real environmental impact, they need to consider the full life cycle of the bottles they use. What are the materials used to create them? How many times do they use them? Once broken, do they repair or dispose? And how do they dispose once they are no more usable? You can find the answers to these questions by conducting a life cycle analysis. Analyzing a life cycle of anything, be it a single-use plastic bottle, an aluminum bottle, a pair of shoes, a shopping bag, paint or building is hard, extremely hard. But yes, we are not afraid of the challenges.
Let's have a look how we do that at AkzoNobel with our coatings. So, for sustainable business approach, we deliver innovative, sustainable solution products to our customers, communities, and plants are highly rely on. So, the focus areas of sustainable products like climate change, circulatory, health and well-being. Our key sustainability ambitions are like 50% less carbon emission in our own operation and our value chain. 100% circular use of material in our own operation driven by recycle, reuse, reduce. Then more than 50% revenue from more sustainable products. More than 100,000 people are being selected and being trained for the new skills.
At AkzoNobel, we aspire to building greener cities. We have just celebrated the World's Green Building Week last month in September. Buildings are responsible for 37% of the global energy-related carbon emissions, which makes construction one of the largest contributing sectors to climate change. A great recent example is the LEED Platinum-certified Stavros Niarchos Foundation Cultural Center in Athens. We supplied Interpon powder coatings for the steel window frames and other metallic building components, which made an important contribution to this building being classified as a green building.
So let's see how the paints and coating contribute to BREEAM and LEED certifications. So there are three factors. There are many factors are there in LEED and BREEAM qualifications. With respect to paint and coatings, there are three main criteria which involves, like indoor air quality, material resources, sustainable sites. When we talk about indoor air quality, we supply low emission products, which is nothing but high volume solid product. So the amount of solvent evaporation will be well less from the paints and protective coating business, which helps to deliver 3 points from the LEED and 2 points from the BREEAM. The next point is material and resources. In powder coating, we have EPD, like environmental product disclosure, and it helps to deliver around 1 point each from like BREEAM and LEED. We'll be talking more about the EPD products in the next coming slides. So when we talk about the sustainable sites, the heat reflective solution is the main point where the heats are absorbed more in the building. So from the coil and powder coating perspective, we supply cool chemistry products. What is a cool chemistry? Cool chemistry is basically whatever the heats come from the sunlight, it will not absorb, it will be get reflected. So the cool chemistry products are being delivered from the 2 points for the LEED certification. This been measured by SRI value. What is SRI? SRI is nothing but solar refractive index. When the SRI value is very high, it means that your products absorb very less heat. Can you go next slide? So you can see how it's been tested. There you can see the thermal image. When with the normal pigment, when you tested, you can find the buildings become very hot. With respect to the cool chemistry pigments, which is nothing but heat reflective pigment, the building become very less heat absorption. The variation between the normal pigment and the heat reflective pigment around 5-degree temperature.
We show our transparency on carbon emissions with our Environmental Product Declaration, an EPD. An EPD is a third-party independent declaration in accordance with ISO standards, which shows the environmental impact of our powder coatings to the nature throughout the life cycle. So it looks right from the stage of raw materials to its application and curing. An EPD can contribute to achieving points for green building certifications like LEED and BREEAM.
So when you come to the construction sector, we have the complete solutions from wall, beam, floor, wood, and facade and curtain walls. Now we'll be looking more about the curtain wall and facades. So there are two different products are available. One is from the liquid spray, another one is the powder coating for the curtain wall and facade. So we talk about the liquid spray PVDF coating, which is highly durable performance product, which is being specified by all the supplier specification sellers. As we know, it's very high durable performance. It contains minimum 70% of fluoropolymer. So it delivers and meets and exceeds the AMA 2605 specification. As you all know, AMA 2605 is the most stringent property requirement, which is qualified for C4, C5 category. It comes in two different systems, like 2-coat and 3-coat. 2-coat comes with minimum 35 micron, solid color, mica color, like light, medium, dark color, which is 3-coat, which is minimum 40 micron DFT. The particularly 3-coat is going because the metallic having tendency to becoming darkening when exposed to UV or sunlight. So the clear coat being applied, which delivers the high performance product, high performance. So when we talk about the trainer, we qualify with a lot of testings. Like we do testing with inorganic pigment, organic pigment. Both are being evaluated and the system is driven. You can see at the left hand side, inorganic pigment with different combination of TaO2 level. Same in organic also it been evaluated. During evaluation, after 4 years of exposure at Alunga site, which is in Australia, which is more rigorous site, which is similar to Florida. The performance you can see, the inorganic paint, the difference, color difference, much less. The chalking also no. But whereas with organic, you can find there is a complete color difference after 4 years. Within 4 years, there is a complete change color. So in the trainer system, we recommend to use inorganic pigment, which is nothing but mixed metal oxide pigments, which again is qualified for BEAM certificate, LEED certificate. Then it comes for 30 years film integrity. The performance being monitored regularly. So more than 11 years, we have the tracking performance. The delta E found less than 5 in the color retention value. So there are some of the projects we have done with trainer, which is mainly for the high-rise buildings, all the train station, bullet station, and malls. You can find there is a Galaxy Tower, Hyderabad, Bangalore Airport, then Goa Airport, Mumbai. There are many other international projects also being done.
Thank you, Kuppu, for taking us through the nitty-gritties of the liquid PVDF coatings. Talking about the next coating, powder coatings. We are all aware of powder coating technology and the different durability levels they deliver. However, it is worthwhile to highlight that now hyper-durable powder coatings can qualify AMA 2605 standards, further improvising the standards of durability delivered by powder coatings. One amazing super durable collection from Interpon is Interpon D Futura collection, which is a collection of trend-setting innovation themes to provide wonderful aesthetics to the future you are bound to create. Worthwhile to highlight that all of the Futura collection uses AkzoNobel's sophisticated bonding technology. Using AkzoNobel's bonding technology as opposed to dry blending technology, we can now provide bonded powder coatings with a consistency of metallic finish not possible before. A metallic finish second to none with a consistent luster and shine to dazzle and impress. Futura collection is revised every 4 years, keeping in mind the future trends which our consumers would appreciate. The latest Futura collection hosts 3 different themes: merging worlds, merging the trends from the past architecture to a future architecture, hosting key metallic shades like gold, copper, and brass. Soft abstraction, this is a poetic palette to reawaken the senses. Third, a very important theme, healing nature. This trend showcases a range of natural shades with a back-to-basics approach to soothe your body and mind. A very recent project quoted by Interpon D Futura collection is our Bangalore International Airport Terminal 2. Our next collection is anodic collection, an old-time favorite to help out architects and designers to achieve an anodic finish, but with long-term resistance to weathering and minimal environmental impact. There are a couple of items to which powder coatings differentiate with the real anodizing, such as exterior weathering. There are stringent standards for exterior weathering testing for powder coatings as compared to anodizing. Same hazardous environment, powder coatings performs better in acidic or marine environment as compared to an anodized film. And moreover, on the sustainability levels, it is found that anodic is the worst choice of a coating when it comes to sustainability, including the global warming potential. Now you can create the effect of anodizing with just a single layer of powder coat. The range of powder coating involves the entire range of anodizing, starting from steel blues to blacks, to soft silvers, to bright silvers, to gold, to copper. The recent example of the building which took Interpon D anodic collection is this building, DLF Downtown in Delhi, in Gurgaon. Most of you must have seen this building traveling from Delhi airport to Gurgaon. Another example is this golden skyscraper in Mumbai, the Trump Tower. And I would also like this moment to quote the first project quoted by Mr. Decruz in today's morning session, Surat Diamond Boss. And yes, we proudly say that the beauty of Surat Diamond Boss was enhanced by using Interpon D anodic collection. The next in line is Interpon D2525 stone effect. Yes, you heard it right. Now you can mimic the effect of stone over using a single layer powder coat over any aluminum or metal substrate. With the same super durable levels offering up to 25 years of film integrity and qualifying ARMA 2604 standards. There's a multiple range, starting from red brick to Portland stone to limestone to concrete grays. You can have it all. Quite a good example of using this stone effect powder coatings is Brentford FC Stadium in London. We always push the boundaries of what our powder coatings can achieve and how and where they can be used to enhance and protect even in the most harshest environment. We have a line of innovations with us in terms of powder coating. We have Preci Ultra Matte, delivering the deadliest matte layers for your structures. Interpon D2525 Echo helps reduce the inside temperature by 2.5 degrees centigrade for the buildings you create. Interpon D antimicrobial coatings, giving an antimicrobial effect to the surfaces you create. Interpon D X Pro, having an excellent scratch resistance to reduce the damages during handling and installation.
Together, the world is our canvas. So AkzoNobel continue to deliver revolutionary innovation in the facade coatings. You know that strontium chromate is very highly carcinogenic nature. So we have the system which is chrome-free primer. So there doesn't have any chrome pigment, not only in the paint system, even the aluminum, what pre-treatment people do, the chrome, hexavalent chrome, which is been now completely from chrome-free primer, so which is to have a sustainable product for the future growth, future environment. Then we have developed single coat paint systems with respect to all the color range, like medium dark. Also it comes in a different pattern, like wood finish, texture finish, and stone effect. All the effects been done in single coat systems. Then with respect to powder, what we have done, we increase the scratch resistance in the existing product, like matte finish and satin product line. It helps to avoid the damage in transportation or handling. We also introduce the self-cleaning powder coating. It helps to reduce the cleaning after installation in the building. So also saves the water. Low cure powder coatings been introduced. It helps to reduce the gas consumption at the customer end. During the coating, normally at 160 he coats, now it has come to 150, 140, that range where it is. Reuse of powder to create new products to reduce waste.
So just like with our products that last for a long time, and therefore is the most sustainable choice, we can say the same for the plastic bottles. Choose the product which gives you the longest lifetime and do not dispose them before they are at the end of their life. And if you put anything to waste, whether it's a plastic bottle or an aluminum bottle, make sure to do it well. We kindly welcome you to visit our booth and discuss what we can do for you. Thank you.
Thank you.
So, ladies and gentlemen, with that, we're going to be breaking in for 20 minutes. Let's get more energy with a hot cup of tea and coffee and network with one another. Remember, there's also a 1-hour networking for all of you post our events. So, grab your cup of coffee, tea, and join us back. 20 minutes, everyone. Thank you. Global edition of the Zak World of Façades. For all the ones who've just joined us, let me tell you, Zak is completing 30 years today, so ensure that whenever you meet the team, do give in a congratulations, and of course, that in itself is going to be helping you with your future endeavors. On that note, and with a bright smile and more vibrant energy, because if you've had that hot beverage, which is either a cup of tea or coffee, I would expect all of you to have more and more energy. All right, so ladies and gentlemen, on that note, without further ado, we're talking about lighting design needs storytelling. And we have with us a dynamic leader who's going to do that for us. We're talking about the director of Sahvia Façade, Ahmed Sumair, who's joining us. Let's give Ahmed a warm, warm round of applause. Hello, Ahmed.
Hello, everyone. I'm from Hyderabad. So during campus night studies, we used to wake around 3 a.m. So जब कभी किसी को नींद आती थी तो बोलते थे यार इतना जल्दी नहीं सो सकते मियाँ, चाय पीते हैं. तो so there is a story कि चाय पीने के बाद आदमी जागता है. So I'm not sure it's true or not. So after tea break, welcome everybody. And I have 2 seconds less actually, 19 minutes 58 seconds. Yeah. So timer galat hai. So today I'm going to discuss about the storytelling, why it's required, and how it's connected with the human civilization. Because from our great ancestors, it's a part of human civilization in different form, like walls, sculptures, then wooden sculptures, through paintings. So the great ancestors used to tell stories, the facility what they have in that era. So what in previously in the history, let's step back, how the great ancestors used to communicate their tradition, the living style, also a culture in form of paintings, in form of like sculpture, like a Gilgamesh sculptures, where the kings and their war, they try to translate and they try to communicate to the next generation in a different form. Then slowly, in advanced stage, it converted into like telling stories with the Bible, then also telling stories and sharing information with in a written form, like a newspaper, then television, novels, and nowadays the social media. So where we all aware the Instagram, Facebook, even we celebrate the small emotions through the status, and wherever we go, we capture images and tell the stories in a past and of a future as well. So storytelling, how? There is no one who escape without listening a storytelling from our parents. कि दादी की नानी की जो कहानियाँ हैं, I can say everyone has been experienced the storytelling. Then with the gossip with the friends, and through the culture, like every state of India have a different culture, different form of music, poetry, dance, and we try to tell the stories through our culture. So now, today, I am a student of architecture, and how we are telling our stories through the architecture, emotions, information, celebrations, how we are going to do that, we are explaining. So through the architecture also, there are like a temple architecture shows the old history, like Mahabharata, Ramayana, and when Mughal emperors came, and there is a story Shah Jahan made Taj Mahal for a beloved, and we go there, capture the pictures and all, and now that in terms of technology, we are sharing the stories, we are celebrating festivals, we are celebrating information through like a Burj Khalifa and all. Then one example of Ellora Caves, Maharashtra, where the cave 16, the Kailash temple, have a complete Ramayana scripted and carved on a stone how the Raja Ram is killing to Bali and how the Raja Ram killing to Ravan. So these are the story lines from the old architecture, transferring our culture to the next generation. Similarly, like as I said, Taj Mahal, it also says a love story, and the new modern technology where we celebrate the birthday, celebrate the national days, celebrate the information and world records on a global platform, and the end users, the people surrounded them, wait for such kind of events. And recently, during the G20 summit also, Delhi NCR has led up with a fabulous lighting where the Indian culture and shows on a monument in form of projector mapping. So how we are approaching to our projects with the stories, inspiration. So we are going to discuss about quickly 4 projects. Cybertham, it's a high-rise tower, twin towers with a hanging sphere. Iris Raghava, then Hontre Port, and another last project is a Fairmont with we are working with Santiago Calatrava on that. So, just 1 minute. Cybertham is a multi-story, 47-story twin towers, and we do have a hanging sphere is a transfer floor on a 37 level. So inspiration we took from the cyber dimension. It's a premium A-grade office, transferring data from one tower to another tower, transferring information to one location to different location, giving information from keyboard to main monitor. So this transferring data we adopt as an inspiration, and we started making a lighting transformation from tower 1 to tower 3. So these are the preliminary sketches we have done, and the vertical features we have highlighted, which are going around till 0 to 245 meter levels. So these you can see the preliminary sketches and inspiration. The RGBW from tower 1 to tower 2, it's transferring from the hanging sphere. So one information from T1 transferring to T2. The hanging sphere we are making like a space ship on soffit, and on the top level we are making completely a dynamic lighting. The next project is a residential tower, 45-story, 3 towers, and these 3 towers are connected with deck. It's a jogging track on 45th level. It's a 185 meter tall 3 towers. Iris is a flower, the project name, and we took inspiration from that iris flower, and we started drafting and coming up with the stories and some couple of renders for that. So the crown iris, this is the flower, birds, stem, and we started correlating it. That upper part, the crown part, it's completely related to bird, and the mid part is as a stem. The mid part cladded with vertical twisted aluminum fins, and the crown part twisted aluminum fins cantilever around 13.8 meter from the terrace level, and it's dropping around like a 7 meter and covering the service floor as well. So this is a top view of iris flower and inspire, and the color palette also we have adopted from those birds, and then lighting simulations with it. So here you can see, without affecting to end user, because it's a residential project, we have to consider end user privacy, and without disturbing to their bedrooms, and also we made in such a form. So we have a beautiful sky deck, and we started like a sky deck full of gardens, and we took a butterfly inspiration, and we started sketching and projector mapping and artificial butterflies in form of lighting. We did on a sky deck. So these are the sky deck and laser lights for special locations to attract the surrounding. Then Hantre is a maritime tourism project in Vietnam. So inspiration is from sea atmosphere. It have like a subtleness, and inspiration we took from sea animals. Inspiration we took from Poseidon, the Greek god who known to be a lightning god. So we have 4 special domes on the walking area, and we made the completely dynamic lighting, the cracking lighting on the domes. So these are some renders from waterfront. So these are 4 domes where you can see the more shiny on Friday, Saturday, Sunday, and the weekdays we will have a very subtle lighting. And these are real after installation one. This is a view from the front, waterfront. Fairmont is with the Calatrava. This project is very completely special. The project location is a very calm in Phuket. And the story and the brief we got from Santiago is we have to have a ecosystem sort of lighting. And they ask us to make a dark statement, not leading everything. Because the project location itself is such a beautiful location and flooded with the nature. And it's a good prominent location, I can say, for adventurers who are love to be in a nature place, who want to be escape. So this is a good location. Then we started telling the dark statement, like the plants and animals, they are dependent, or they are living with the atmosphere of a day and night. They enjoy the night for a reproduction, they enjoy the night for sleeping, they enjoy the night to have a safety with the predators. And the daytime, they perform. So we took the inspiration from that, and we started telling, no light is a light. It's not necessary to light everywhere. So we started with that line, and we started sketching. So these are some inspiration we took from surrounding of the project. And the geometry itself is a very unique. It's a multi-curvature facade, and starting from 1.2 meter to 10.9 meter cantilever in a different form. And the light, the simulation we have done is in a very subtle form, very subtle intervention for end users. This is a side elevation for a landscape and interior areas. Now, these are the storytellings, renders and all, and everything is possible in the render, but whether it's possible in a practically or not. So there are some projects where we have taken inspiration and we come to in a realization also. Because that is a very big question comes from every client. Okay, boss, हो जाता है Photoshop में, मगर बनता है क्या? Realistic है? या उसकी integration and provisions, is that Indian contractor are fully equipped or not? That is a very right and very big question we do have. So I can say we have couple of projects is already completed. I don't say like in a very bigger form. Whatever best with the inspiration and transferring into the reality, we try to do it, and we have achieved successfully with the performance facade, with the help of some manufacturer, contractors, architects, and obviously the client. So Advante is in Noida, the SAS in Hyderabad, Radial IT Park with Ascendas Chennai, we did. So Advante is a PEB structure, is a G plus 72 story, G plus 27 story multi-curve facade. And the inspiration we took from a sailboat, the curvature, you can see the belly curves on two area. Pixel dot on the longer facade, and those pixel dots we started celebrating like festivals like Valentine's Day and flag. Multiple events we have celebrated on the pixel dots. And the curvature area we inspire from the digital screen initially, And due to the budget, we came into, we'll go with the dynamic, but we'll not go with a completely micro media panel there. Then we started making up some combinations with the multiple pixel lights and all, and that's how we end up. So that one is a render what we have done in the concept stage, and this is the actual one. So how to integrate this one? Because the major task now, integration of lighting fixtures into a facade will bring leakage, air leakage, water leakage issues. And if you have not done a proper integration during the concept and tender and during the shop drawing stage, it's a very difficult to accommodate in a post installation. So we did complete provisions and everything during the shop drawing stage. We visited the factory of contractor. We make sure that they have done the notching as per our requirement, as per the tender design, and as per the breathing system, like a leakage and ventilation system. So these are detail you can see in the spandrel area. We made a provision for power supply cables, and these pixel dots we have installed on a smaller area. And recently on the same facade, we have extended and added a more fixtures, and client wants to celebrate the G20 summit, and they want to welcome the other countries, put the flags and inviting them. So the provision was there. So the first installation phase 1 was here. You can see the less pixel dots here. During before G20 summit, we have added more pixels because we already have a provision for that. We have not done any post puncturing on there. So this one, and for a belly curve area you can see, so these are the mesh. Instead of a complete media mesh, we made up pixel jalis, and we integrated into a solid aluminum sheet and plywood in the vision area. So from inside you will see the powder coated finish, good finish, and from outside you will have completely dynamic lid facade. Now for a SAS I tower, it's a 5.6 million build-up area, 48 story tower, 3 towers we do have. So this area, the east side, while coming from the airport to the city, this area is more prominent visible, and client says 70,000 cars daily going to see this facade. So we started picking up dynamic lighting on this area. So they want to celebrate all the festivals, especially like flags and all. Then those areas we made with a completely RGBW dynamic light. Then this is under installation stage. We already completed facade installation till 37 level, and we have made all the provisions during the fabrication time. So you can see after installation also we do have a provision for a post fixing of power supply and drivers, and here the puncture in the system, and this after sealing. So complete integration we did, and the challenge here is we have a different size of fins. Like every alternate fin have a different size. It starts from 90 mm to 450 mm. And puncturing that 450 mm and getting inside for a power supply is a big challenge. And doing that after installation is a nightmare. So we made during the shop drawing stage, we integrated, then we tested in lab in Chennai to understand what is the behavior after puncturing the system in a long distance. Then radial IT park. In radial IT park, we do have staggered form LED linears. It's not a continuous one. It's a randomly, and the fin size is a static 350 mm from the glass line, and we made a provision integrated with fin bracket like a L form, and we have installed all the RGBWs there. And here the building height, the clear height for a second level to terrace was around 38 meter. So there were no puncture required in a system. We made provision in a ceiling for a power supply location. So one driver located on the soffit and the another driver located on a terrace level. So what challenges and provision? So before and any project, any client, if want to have a unique light on facade, it's a compulsory or necessary if you want to have a well coordinated and well planned and well integrated with the all other elements. We have to have all the consultant on board first, make them understand what is the behavior of facade, what are the materials we do have, how that system works in terms of functionality, in terms of installation, and how the system behave if you temper after installation. So that coordination between the principal architect, contractor, maybe the contractor comes in a very advanced stage, but the lighting consultant, facade consultant, and MEP consultant play a very key role to make a successful facade. If we haven't done any pre-plan design during the concept and tender stage, there will be like a huge leakage we can have in a future. So and also adding a lighting fixtures after installation, there will be a lot of cables on a facade. You can see there will be like a different sort of arrangement, like a jugaad you have to have on a facade. So to avoid those kind of things, like it should be well coordinated and within the time. Thank you. Thanks.
Well, truly a well-rounded presentation it was. We did see a lot of great examples of how the lighting design needs the storytelling. And of course, I'm sure a lot of inspiration from the upcoming projects which he's doing or the projects which are already executed. Just before we go to the final panel discussion, by show of hands, if I may ask you, how many of you have met 5 new people today? If you have, please raise your hands. A little higher. Can we have both the hands up? Yeah? Can we get some energy and clap? You know, sir, the entire cohesion and the entire vision behind the event is, of course, to learn, to connect, and of course, further to innovate. So we encourage as much networking as possible. So do get that on. And ladies and gentlemen, now it is time for me to start with our final panel discussion. Well, up next in our conversation at the Zak World of Façades, we're talking about our final discussion being around BIM and related technologies. The potential to digitize, standardize, and gain productivity. Well, for this conversation, we're elated to have with us our moderator, Managing Director of Shuko India, Shyam Raghunandan. Let's give Shyam a warm, warm round of applause. Thank you, Shyam.
So it's the last session for the day, so I'm fully sensitive to that fact. So I'd like to really ask my colleagues on the panel to come forward. Mr. Amit Kembavi, Director Architecture, DSP Design Associates. Mr. Ankur Jadhav, Project Head, L&T Realty. Mr. Jagdish Kadu, Vice President, DB Realty. Mr. Gaurav Sangvi, Co-Founder, Pentaspace Design Studio. And my colleague, Mr. Rangarajan from Alufit International. This is really, Mr. Nitin Bansal could not make it from Brookfield. He had a high-level meeting in Bangalore, so the entire Brookfield team could stay back. But I think we have today a really distinguished panel, starting from the investor community, who faces the market, to the architects who bring the concepts, and then I guess somebody who has to then make the design come true on the ground. So I think we'll get a full perspective, and I really thank each and every one of you and look forward to the discussion. So then let's just get started. So the topic for today is digitization and how various digital technologies could be used in a practical way in India to gain the productivity advantages that I think our industry desperately needs. So I'll start off with a question for each panel member. Maybe we can go counterclockwise. You know, from your perspective, you know, what does digitization mean for you? And what are the benefits that you expect to achieve at a very high level on the perspective of, you know, timely completion, quality assurance, cost control, sustainability tracking, or operational maintenance? Because at the end of the day, the investors want this. At a very high level, what is it that you think of digitization and how does it help? And then we can get into more details.
So thanks a lot, Zak World, for inviting me for this panel discussion. First of all, we as a developer definitely would like to see the digitalization should help us in terms of delivery part of it. So timely delivery with the quality ensured. Okay. Now the way digitalization is happening, especially after COVID, we wanted to have everything got connected on the app or some kind of a tab, and then make it effective for the functioning part of it. So as you mentioned, there are 5-6 panels. I will just try to touch upon on the timely delivery part of it, because as a developer, any project, whatever we do as a commercial development, typically for any commercial development project where we have facade as a very important element, the timeline in a typically it is go for 24 months to 36 months, sometimes 48 months in a development like environment in Mumbai. And being the commercial project, it is a capital incentive. In most of the projects we have to first invest and then probably we get something on the lease or build to suit kind of. So for us, if I have to touch upon, the delivery part is very important, and how the digitalization can help me in sort of sourcing of the material, have tracking or minimum wastage, what I can have it, all my supply chain is aligned with the fact of the matter, all my deliveries, all my supply chain management got in line with it. That will be the more important aspect for me.
Thank you. Ahmed sir, from your perspective, how do you see digitization? How does it help overall?
Yeah. Thank you, Zak, and thanks, Shyam, for inviting for this panel. For us, what we see is as architects, how we can, first is in terms of reduce the reworks so that we are getting things right in the first place. So by introduction of BIM, we would say that most of the complex part of the structure, which obviously at many a times is the facade part of it, whether it is in the forms of shapes or any other complexity that it has, it can be addressed very well at that particular time itself. So when we are digitizing the design part of it, so that construction-wise the time gets reduced, because time is key, time is money. So our effort, I mean, as a industry, is what we are also trying to very actively promote is the pre-construction time is very important. BIM or digitizing doesn't mean that your works will happen fast. So your works will happen fast only at the site when you give the right amount of time for the pre-construction to get into the details of these things. So yes, it helps us to address the complexities at the very initial stage. Second is it will address us to arrest many of the reworks that we as designers tends to do, okay, isko baad mein dekh lenge. We'll detail this out later. So in BIM, you can't do that. You have to do everything right there, right then. So you have to be very alert when you're digitizing the entire stuff. Third thing is, it reduces the time what as developers they have to spend on time. I mean, on construction. So that is a very important aspect that what it goes. Fourth thing is definitely by doing all these things, it helps the developer to actually get a right budget, quantifying things very early in the project itself, so that the business plan, the business case is formulated and approved, so that there are no surprises later on. Why was this not thought of, unless and until it is a design requirement. So I think according to, from the design part of it, I think which he will also agree to some extent, that digitizing means giving more time pre-construction. So as the saying goes, the more you sweat in peace, the less you bleed in war. So that exactly the formula is applicable very much in the digitized world.
So I think, sir, you had mentioned digitize to reduce waste and keep track of your supply chain. You have mentioned invest in peace so that you don't sweat in war, so that in pre-construction get into the details so that the rework is minimized.
Yeah, I mean, the use of BIM is primarily to finalize and get approved almost all the things that you want to get into the project before it hits the ground.
What do you?
First I'll thank Zak Façades to invite us and have this panel. It's a very relevant panel with the amount of work which is going on in our country, and you need to fasten the pace of work. It has to be up to a certain standard. So I think digitization is going to play a key role in all of us delivering good products out there. I see digitization to give me control over the project, right? From a design standpoint of view, say from a concept stage, once I start putting my energy into visualizing something, and the platform takes me from a concept to development to working drawing, and it becomes seamless, because I don't miss on anything. I'm always adding stuff at different levels. And as so rightly said, the idea is to get a product which encompasses everybody's thoughts, right? So from a developer, his financials, his BOQs are in place. From a design point, the philosophy which you want to get onto the table. From a construction standpoint of view, they want drawings to be delivered on time, which are more accurate. So I think it just makes it seamless from the first thought you've had to the final product. And I think that is the beauty of digitization. Control.
Hi. Good evening, everybody. Myself, Jagdish Kadu. See, there are small difference between digitization and digitalization. We are speaking about digitization at present. Digitization means to convert the physical data into a digital format and improvement of the computers network as well as internet networks. Basically, nowadays in India, not only in metros, but in 2-tier and 3-tier cities, in construction industries, everybody using the computer and networks for the improvement of quality, reduction in timeline, and getting the benefit of digitalization. With respect to completion of the project, on timely completion of the project, if anybody book the flats in any project before 10 years until waiting for the delivery, means we can assess that the developer only giving the interest and not principal at all. Means the 10-year interest part is more than the basic investment. That's why the timely delivery of the project is more important than other any aspect in construction industry. And we are seeing every projects are delaying for human error. And that reduction in human error is only possible by digitalization. Means we use computers, we use software for quality control, we use digitalization for planning and design tools. We use it for different aspect, construction aspect from design, planning, management, as well as the delivery, and timely delivery. How we achieve timely delivery? We reduce the human error. Project is delayed generally by human assumption that is going wrong at later stage, and which we could not predict during planning. But we plan the project digitally, means there is very less chance of delay, very less chance of error, human error, and we are able to deliver the project within the time schedule, and that will the big achievement in construction industry to digitalize. And next point, I would like to talk on cost. Cost is the major factor. In developer point of view, end user point of view, getting the product within a reasonable rate and deliver the product at the minimum cost is beneficial to the developer. Developer is not work for delivering the good project, it work also for getting the good profit. If the cost is increased after planning day by day, the profit range will be decreased, and the main motto of developing the project will be hampered. So, first, we reduce the cost by using digitalization, by reducing the resource management, by implementing the technical tools like BIM technology, which we'll use for design as well as the storing the data, drawings, and producing the product as we plan it. Thank you.
Thank you, sir. And Ranga, what about you? You are finally holding the baby in your hands.
Yeah.
How do you see this?
Thank you, Shyam, for inviting, and thanks, Zak. Okay, good evening, all of you. See, with our experience, I am from facade contractor perspective. Okay, whatever the drawing, BIM model or Revit we are getting at this moment, okay, just for, it is a replace the architectural drawing. Earlier, we used to get the architectural drawing in a 2D. Now, that is substituted with a model, and from the model, we are extracting. And what happened after that? So, till finalizing the job with the facade contractor, they are showing the model. After that, no one is updating the model. Our site inputs, all should be integrated with the model. In parallelly, all the stakeholders should be in touch with the model. They have to put it in the cloud, and everybody should work and make a digitization. Exactly what Mr. Ahmed said, the digitization, doing this, it's not going to reduce the time. Okay, definitely we can identify all the clashes with the structure, and tomorrow, in future, it will help the facility management to analyze the building, understand at various level, course of time whenever is required.
Great. So I think, at least with that first set of thoughts, the ideal scenario seems to take shape, that from the investor perspective, having everything digitized gives you control on the project, gets into the detail, and from the investor team, the first focus seems to be timely completion. So some kind of a software, a digital workflow, a platform that helps you to finish the project on time. I think from the architect community, it was more, again, control, minimize rework, so that what is designed is actually what happens. And then from the fabrication contract perspective, the ideal scenario would be, yes, I've digitized it, but then keep it alive on the real job site conditions. So that seems to be the ideal picture we would all like to see. So then I think that gives me the station for the next question. What is stopping us from getting this done? Because clearly, I think all of us can agree, this happens in a non-ideal way, in bits and pieces. I think there is CAD models, but then like Ranga said, on the job site, it vanishes. Or maybe there is some digital stuff on the job site for which there is no CAD model. I think I leave this open. What is stopping the Indian building and construction from saying, I do the fully digital job site? What is the biggest barrier? Is it a lack of platform? Is it a lack of communication?
Okay. See, what happened, somewhere we are failure in planning actually. There are cases in our project, we delivered the panel and the changes from the client. It is a difficult scenario when you put it into digitalization and updating the model. It's all really make more complex to us. And moreover, when come to the facade especially, lot of details we have to do in a micro level. So it is not possible straight away work in the Revit model. So we have to do it in 2D drawings and lot of details interface with the structure, bracketing, all this thing. Then we have to take architect approval and client approval. Then we can transform into the model. So that helps. That is a better way I feel from fabricator perspective. Because we do a lot of changes while doing the job.
Okay. So what you're saying is, even if you get a BIM model, there's a lot of detailing still to be done, which needs to go back into the model, and without that, it makes no sense to continue.
Yeah, definitely.
That's one of the barriers.
Definitely, we have to do AutoCAD in 2D because there are a lot of constraints when you constructability point of view. In the Revit, if you go 0.5 radius, die, and all, you can't make it on that. So we have to do it, and they'll take approval. That is a better way of doing it. That is the way how we success in the 2 projects in Hyderabad Airport. Also, I said very clearly in my first meeting at the tender meeting, we take all the drawings in 2D approval. Then once you give an approval, we'll put it in the Revit model. All the level of drawings, LOD 500, we submitted to the client, which got approved. Same way in Wipro Hyderabad also. The client is very keen on to use on the BIM. That is only one project in my experience in India in 11 years. I'm outside the country for 20 years. Okay, I have noticed only one project with a client. All the stakeholders will get a notification whenever they update the BIM model. So none of the job I'm getting it. So that is all very important. It should be a master planning is a very important.
So I think to answer your question, what is stopping us? So according to me, there are a couple of points. First thing is the vision. The vision has to be very clear that yes, we have to be digitized in whatever way. Second thing, the biggest mind block is the mindset. Because any change is the first thing that what we resist. So typically the construction industry or the architectural fraternity or whatever, so there are certain conservative ways or the traditional ways how to do things, how to approach things, because that's been the age-old tradition of how we have been doing things in this part of the geography. Second thing is, now things are changing, even everybody needs to catch up with the pace. But having said this, I think there are 2 very important things. One, the vision of the owner, of the client, or with respect to, let's say in the architecture fraternity, the owner of the architectural firm, no, yes, we are going to do everything in Revit and BIM. So that should be the mandate. So then there is no ifs and buts. Second thing is the mindset. So if the vision is clear, then the mindset will take some time to get cleared. But I think at the end of the day, when we know that there are so many benefits which are coming out of it, and if we are not catching that bus, so we will be left out. And third thing is, coming to his point, there are some couple of projects where we are working, and as he rightly said, everything when it is put on the cloud. So BIM, when we get into the actual details of the BIM, so there is a humongous amount of coordination that is needed from each and every stakeholder, whoever is a part of it, whether it is the contractor or whether it is the consultants or the client. So now, with some certain projects and with some of our clients with whom we are working, they have set a vision that the entire site will be paperless. So there are no drawing prints that are going to the site. So which means that our BIM model is on the cloud, fully coordinated, all the details are there, and the site supervisors are being given tablets so that they can see, measure, and do drawings and get the data there. So one other important thing that is also stopping us is when we work on Revit. So it's all done in families, the families of certain, the products or anything. So not every product is available as a family right now in India. So to answer this question, that yes, on BIM you are seeing some things, but they again have to go into the 2D part of it and then get it and then plug it onto the things. So that is where we as architects will request most of the vendor partners over here who are into manufacturing of all these products, whether be it system company like you or anybody else that are there. So try and create and make these families available for free or for whatever, because we also understand that yes, there is a number of research that has gone into making that product. So there are patents, everything is there. There are a lot of compliances also. But if some such families are being made available to the Revit world, so then his problem of details not being captured, the model is there, but it's not detailed. That will get reduced to a lot extent.
As rightly said by both participants, we are getting the good fruits of digitalization in metros. Forget these metros. In rural India, there is the most challenge of developing online infrastructure because the cost of online infrastructure is huge. Until there are huge gap between metro and the villages for digital literacy. Till we develop the digital literacy, we cannot move whole India digitally in construction industry.
So if I... So adding back to his point, vision, that way we at L&T, our vision statement has mentioning embrace digitally. And it is been true spirit been followed at our project sites. So I would happy to share that at our project site, everything, all our consultant, all our projects are 100% on the beam. My project engineers who are working on the project site, they don't have carry any physical hard copy of any drawing. They have a tab established. So because it's an vision and driven from the top, that's why there is a lot of focus on that, but all our quality checks are happening, or our safety checks are safe to start happening entirely on the digital platform. Now coming back to the challenge part, as he rightly mentioned, 100% of things are still not available on the beam. We need to take the support of 2D drawings, particularly giving the detailing part of it, some of the details. Yes, there is a bit of amount of work needs to be done. Secondly, all the whatever softwares we have, it comes bit of cost, and not every time everybody is sort of interested to invest. For any Collabro, anything, one user, it's cost around 50,000. So is the license or is that is available for all those people? For every stakeholder on the project will be given, all the contractor will be given. So there has to be, that sometimes comes to the mind when we are a very cost sensitive, I can say the people. So that we see an upfront cost for it. The third part of it, at times at the project site we had the issues with the connectivity and all. So that sometimes pose the challenges. Overall, I can think the mindset part of it, the extracting the, so we all have sort of agreed to, and largely yes,
The digitalization, like giving your tea vendor or anybody paying in a Paytm, it does help. Getting that digitalization benefit to all along in our entire process chain or supply chain event, everybody has to come forward, and right from not only with the developer point of view, even the fabricator or the suppliers, they have to sort of embrace themselves for this change.
So actually, the resistance is not. It's more from the client side, I feel, because you have to operate at a hybrid model because you got to cater to all clients. So they don't all have that same vision. So there are clients who tell you that they want BIM, it's a part of the contract. And there are some who don't have an internal team who can actually process BIM. So even if I propose BIM, it doesn't go through, right? So just now, at least at an architectural standpoint, like all clients are not very comfortable with BIM. There is a hybrid model which I operate also in the company because we got to cater to all sorts of clients. So I think we are still in that stage of transition, and I think cost is an important aspect which should be looked at because it is not a cheap software, BIM, and cloud space, X, Y, Z. So I think that is also adding to the deterrent where even the client is hesitant to adopt completely, right? So I think if there is some way that bridges, this thing, I think as a creative people, I think there is sense to it. And I don't think anybody resists that. But from a client point, because there is a cost involvement and there is a financial input involvement, I think that is where I think there is a disconnect. So definitely these families, what Sir has been talking about, I think over a period of time, I think all of the facade guys, the window guys, all of them will start putting that into the families. But the cost is going to be a major driver if you want it to penetrate, as Sir rightly said, all the way down, digitization. And I think examples are your telecom guys. As soon as prices start going up, digitization started going up, right? So that is a model which I think our industry needs to look at, and how we can subsidize that and how we can actually push that digital concept through.
Great. So trying to summarize that topic, why we are not reaching that ideal state, I think starting top down is the mindset of the investor. And I think we can all agree the investor is the driver. If the investor says, karna hai to ho jayega. Yes. So I think that's the number one.
Absolutely. Yeah.
Second, if I heard that discussion correctly, it is karna hai, but then all the suppliers, all the ecosystem have to jump in together at the right level of detail so that everybody jumps. Because if one person is not digital, then the system doesn't work. So all in or the machine does not work. The third aspect is the cost of implementation, getting the investor on board, the cloud costs, the digitization costs, and so on and so forth. I think these are the three, I would say. And then I think what I really liked was the practical topic on the job site, do you have connectivity? So I think that seems to be, let's say, the four big barriers. If we can solve that, then maybe we can make one step forward.
I just want to add 1.1 more into it, ki availability of BIM professionals. You see, that is also
the level of skill and talent.
So that's a level of skill and talent. So that also needs to be, as an industry, the way SAP is been available so modestly everywhere, every organization has it. Maybe for the BIM, that level of skill set
has to be developed.
It is.
I think it has to start from the college itself, right? From the seed level.
And that I can fully agree with, because I visited now a couple of colleges with a couple of facade consultants. A, they don't know the word facade. B, they don't know it is a field. And C, they don't know the industry exists. So I think while we build up the talent, I think there's a request to the whole room that at least people should know there is facade and the industry that is making these buildings happen.
It's a proxy with an elevation for us.
Yes, exactly. So on that angle, just a quick twist before I get to the last question. In the morning session, I think the gentleman from Arup showed a very nice use case or an application using the drones, using the building for inspection. Now, is there a way where, this heavy investment into I have to digitize the model, I have to convince the investor, I have to move the mountain, versus let us use what we have, and the value added thing is, I think what you said, control. I can take a photo, do digital inspection, and confirm to the investor, yes, what I designed happened. Is there a possibility in that direction, especially in the Indian market? Or are we back to, I take a photo, what do we compare against? And I need everything digitized anyway.
I will answer this. See, now recently the project of Microsoft, everybody knows that Katera is wind up the company. Then Alufit won the job now. So already 1,600 panels already installed. So we are doing complete audit, okay? Complete project, we are doing the audit on them. So this is the first step. This is the first project. We use a drone. We use drone all around the building to understand what they have done it, first place. So it's very difficult to reach each and every nook corner. So the drone is really helping us in that way.
So it's possible in that direction. And
it gives ideas. It gives ideas. What exactly, how many panels installed, what is that? Yeah, you can't go in a micro level detail what they have done inside, but at least in outline you can.
So simple things like how many panels are installed.
Yeah, definitely.
To that extent, okay.
So from the progress monitoring point of view, yes, it is a very good tool. But as you mentioned, yes, the additional part of that software is there you can compare, I can say a 15 days tracking or a month tracking, that facility is also available. Okay, that kind of facility is also there, available. So it as a robot or as a drone, it goes and go on clicking these snaps all around, and then
absolutely
you can compare what was the things a month before or 15 days, and then you can track the progress. But from it, it is more execution friendly or tracking part of it. Yes, it will give the confidence to, if I'm doing a building for build to suit project, I have to give a track update to my customer. Yeah, it will definitely help me to present in that fashion rather than our typical way of presenting, taking the snaps and putting in a PPT. It's a better way of representation.
Sure.
So I think the good news is while we prepare this infrastructure, maybe there are simple use cases which anyway you seem to be already implementing to start this digitization journey in a more practical way while we wait for the 4 barriers to be overcome. Okay.
I think just before the drones also, I think we used to use webcams.
Cameras.
So it is always going to go forward, right? So from webcams, we've gone to drones, satellite imagery, right? So I think I just read the other day that Google is giving maps where you can actually see where to install solar panels. So they're giving images of your building, and they will give you an area where you're getting the maximum sunlight, and you can install panels there. So I think digitization is only going to help us take decisions, but it happening at a more pragmatic level is going to take its time. So the hybrid model is still going to just, you have to keep falling back on that, because you don't want to just leave your entire studio onto something which will take time to catch up.
I think my take on this is a bit digressed one. So while we are talking of drones, yes, it is a very practical approach nowadays because we need to use technology. But also coming back to, from a developer perspective, as Sir was saying that the projects get delayed. And he was right that most of the time it is due to the man-made things. So one of the important aspects of using the digitization and the technology before we start the project also, which we have now started implementing in most of the projects, is the 3D survey of the land. So what it captures is not only just the contours or the trees and everything, but what is underneath also. Because in India, you don't know which pipeline is running from where, what is there, what was there, in the earlier years when that land was available. So many a times when the excavation starts, so we end up with a lot of surprises. There's a pipeline here, there's something what we have found, or we have to change the designs. So that is going to, again, affect the cost and the time. So using of 3D surveys, using of, I would say, digital scanning. Because most of the time what happens is when it comes to the refurbishments of certain buildings which are old, we don't have the data. So we don't have the drawings. And we don't have the time to do a measure drawing, because it's a insanely huge task of resource. And at the end of the day, you will not still feel correct that whatever the measurements are taken are right. So this is where the digital scanning actually helps a lot to minimize the time and address the complexities, whether if it's a refurbishment kind of a project or to start a new project, what is there underneath.
Cool. So my last question, I think there's a huge amount of experience on the panel, and while we have a dream, there are some practical barriers, there are some practical solutions. Maybe we can just go around the panel, and as a positive ending to that discussion, in your experience, what has been the best practice example you have seen for a digital job site, and what made it work? Maybe it was not 100% digital, but in your experience, what was a project that was the best digitized that you have worked on or you have seen, and what made it work? Because that's something we can take as a starting point and keep building on.
So, the project what we sort of cherish within L&T is the most, I think, digitally tracked and could make the difference was Statue of Liberty. Okay, though I am not directly, I am from the L&T reality, but it's a part of L&T. I know what has happened and how that has been built. So as most of you would have known, see, it has been more, see, once that artist had made the statue and then making it to a bigger level and then divided every component of that statue, giving the RFID, tracking it right away from the material sourcing at China to reaching it to the ship, from there to the project site and then getting installed step by step. See, everything was fully controlled with the RFIDs, digitalization into fullest extent. And see, result we can see in a record time we could build the world's tallest statue. So I think that so there are many examples available within L&T, but this is the promising one which comes.
So there you actually crossed a barrier. Basically, got the supplier chain digitized. The mindset was clearly there.
Mindset
so
was clear.
Of barriers you mentioned we overcome.
Yeah.
Great. Any other examples that the panel would like to share?
From the architectural fraternity, one thing which has helped using the rivets and the BIMs is that a lot of the staff or the resource or the teams that are working with us, most of them are not fully compliant with the 3D visualization. So in terms of, let's say that we plan something, the third dimension might be something else. But when the staff is actually working on it, the teams are actually working on it, sometimes they find it they used to find it very difficult when they were working on the 3D in terms of visualizing it, how it comes in the 3D. So while drafting the sections, drafting the elevations, so it was a task. But now with the help of the 3D, this Revit, the visualizations have been very easy. So it has made them also think fast and make them understand also fast as to how this part of the building is functioning, why there is a curve here, how it is, at what degree, and so on and so forth. So that's the good part of it. I would say rather a flip part of it is that with the use of Revit and everything, the revisions have become very fast. And the flip side, why I'm saying is that every time client is expecting everything now, because you are using Revit. So that's the flip side of it.
Is there a project in your experience, sir, that where for you is a benchmark of digitization?
Yes, we have used the benchmark of digitalization, but due to the computer literacy, we fail in getting the object which we have fixed, in getting the deadline of the project till we have not completed the project within the deadline.
Any thoughts?
I think it's going to be the next project because I'm still not happy with the digitization because it's just in bits and pieces, right? It's more hybrid in nature. But from my standpoint of view as a promoter, I'm still trying to reach a point where I will say no to a project if it is not BIM. So I'm still not getting that courage. So I think it will take some time from my side to reach a point where I will say that I will not do it if it's not BIM. So I think that is a tipping point which I'm working on still.
Fair enough. Any project?
As I said earlier, the two projects we have completed, one with L&T Hyderabad Airport, another one Wipro Hyderabad, we have completed. We submitted the as-built also in a BIM model. Okay, completely, even the client has given approval, everything. That really helps actually. We have to evolve with the latest technology, definitely it's required. But only my humble request from the facade fabricator point of view, don't give the project in the nth moment and do the BIM model and all. Everybody knows the 3D takes a lot of time. Minimum time we need to invest for 6 months actually. So in India, especially that is a big problem. We get the project in the last moment. Architect and facade consultant, they associate with them. They work for year and year. And finally one fine morning, they'll finalize the vendor. And the moment they gave the drawing to us, they want a panel next month. Then how do you expect from the facade fabricator? I'm sure over the facade fabricators here, I'm sure they will support me on this line.
That's, I think...
I want to conclude this question that why, after using digitalized tool, why we are failing after failing? See, the digitalization is the complex thing, and using only one tools like BIM or drone is not sufficient. To bring this whole construction industry in digitalization platform, we must have to use multiple tools. In my view, I think BIM, drone, AR and VR technologies, computer and things, network and things, and AI technology has to be implemented hand in hand. Then and then we can complete the project in fixed deadline within a schedule by using this digital technology. I will share just example of each BIM. We can store the drawing, as well as design. In drone survey, we can take the snap. See, for this facade, we cannot inspect the quality of facade during construction from outside the building manually. But by using the drone, we can inspect every joint of facade, clear cut, and put our quality control and get the assurance of completion within a time. By using drone, we can do the survey or take the snap of about 50 acres of area within a single day with a 20 megapixel of camera with the accuracy of 3 centimeter each. Means we can reduce that pictures into the realistic data. Then the data we can process by using the software to the Excel sheet, and then we can convert it into numericals. Then we can correlate it physically. By using AR, VR technologies, we can design the tools and visualize the model which we generally not visualize
by our mind generally. But we can resolve the complex problems in construction industry by using AR and VR technologies. Computer thing, we can use the network, we can use the sensors for the energy consumption as well as air quality control inside as well as the outside the building. For getting the perfection, we must use the different tool at different level. At last, we have to use artificial intelligence to modernize the available techniques to planning step by step and to get the resources within a limit, within a reach, and control it physically. And AI technology reduce the human error, and by using it, we can get the project delivered within scheduled period. Thanks.
Great. So thank you very much. I think we could do this for a longer period of time. I think it's a very deep topic. I think there are some success stories. I think we have some shoots where we can start with, but I think there are some significant barriers to overcome. And my request to the entire community, and I think also to the investor community, I think let's get the mindset, find small projects where we can make lighthouses, learn from it, and move the industry forward step by step. Right? Thank you very much for that discussion.
And I'd like to bring to your attention for the final closing, ladies and gentlemen, and we have the director amongst us, Zak Exhibition and Conferences, Ahmed. Let's give our gentleman a warm round of applause.
Thank you. I'll be quick. Thank you all for attending today's event. I hope you liked today's event. As I mentioned this morning, we've recorded the event. I will share a YouTube link with you of all the presentations we've got permission to share with. And we look forward to hosting you next time. So we've got a small networking session outside. We've got some snacks and drinks being served. So I look forward to meeting all of you outside. And until we host you next year, next time. Take care. Thank you so much.